The next speaker, I forgot already. So my mic is on. Is it coming through? Yeah? Okay, good. So have you switched the stream on? Okay. Okay, welcome everyone. Thanks for coming to the first inaugural version of Postgres Extensions Day here in Montreal. It's beautiful weather, so hopefully we'll have a chance to enjoy that as well. Few notes here. This event has been made possible by our sponsors. That's Amazon Web Services and Postgres. So thank you for them and their help. A few housekeeping notes. It's going to be a very tight day. There's a lot of presentations, so we'll try to stay on time. Please help us doing so. Also, the microphones that we're recording on are very sensitive, so if you want to talk to a colleague or friend, please do that outside. Otherwise, you'll be recorded as well. What else? Basically, we'll have presentations. Every presentation is capped at 25 minutes. After 25 minutes, there is a 5-minute question and answer period. And the next speaker will be preparing during that time. So we'll be putting microphones and all that. If you have any questions, always happy to answer them. Get me outside of the room and ask me any questions if necessary. Please abide by the code of conduct. That's our requirement. And let's have an enjoyable day. During the lunch, we'll have an opportunity to discuss things more in depth. And there's going to be an optional dinner, self-pay. There is a form in the email that you have received this morning. Please leave your name so we can plan accordingly to pick a venue where we're actually going to go. Without further ado, we have the first speaker. So please come on.
So, hello. I hope everything works. You hear me, and also recording works. And my name is Hannu Krosing. I will be talking about PLv8 and what can be done with it, and also how to make it much more easier and more powerful to use. There is a short history of me, but we don't have time for that. Also, I'm contractually obliged to say that I'm not speaking for Google. It's not any official project. It's just what I and some other people there are doing, but don't use it as anything from Google, at least for any decisions. So the slides are slightly modified from my talk at PGXN India, which was much longer, so I brought the important stuff in front and leave out some parts that this audience knows anyway, and let's see how far we get with this before we run out of time. So I will shortly speak about what is server-side programming, what are PL languages, how they work internally, also what there makes it possible to extend the abilities of them, then also a few words about WebAssembly, and then what are plans for future. So first, a small overview demonstration why it is a good idea to use functions instead of running everything from their client. So everybody knows pgbench, which is kind of built-in or patterns included testing tool for Postgres. And its main test workload looks like this. It sets a few random numbers based on scale. Then it does an update, select, 2 more updates, insert, and another select. And this can also be expressed as PGXN function that looks very much the same, where the random numbers are passed in as arguments, and then it does all in a row. And to run it from PGBench supports running scripts, and there you do the same thing, but instead of sending individual begins, inserts, updates, you just do a single function call. And now the results. Even locally, it's 2.5 times better performance, because instead of this 1, 2, 3, 7 calls, it does 1. So a small run runs at 13,000, almost 14,000 TPS. We're doing all these calls, and then 36,000 when doing just a function call for each of them. And the performance is even better when there's contention. Contention here is achieved by using a small scale factor, which means that all the updates will happen only on 10 separate rows. And in this case, the fact that the transaction is shorter makes the whole thing even more different. So instead, it runs now 6 times faster instead of 2.5. And the numbers are even more impressive when your client runs on a separate machine, so that there is a overhead from communication. There is still some overhead locally, but it's much bigger, up to, say, a millisecond, half a millisecond each time when you do it from a client. So Postgres is really configurable, and you can easily use many languages. Everything is defined in system tables. But the thing there is that just the data types and arguments are always converted to and from Postgres data types. And here are the multiple types of functions that are available, just scalars, I'm not sure how it's pronounced. Then ones that can return rows or tuples, which again, in case of Postgres, is also kind of scalar, because you can have structure types already. So row is just a type that consists of many subtypes. You can return table or set of records. So you can use this function in place of a table in your queries. You can operate on sets of records and then return scalars. That is done by aggregate and window functions. You can implement triggers, and then there are also internal functions, somewhat undocumented and can change. So we had at Skype, we had an early problem where we used hash functions for partitioning, and then they were improved suddenly in one version, and then partitioning didn't work anymore. And here are some samples. C and internal are basically the same. They are compiled functions that just are interfaced in system tables to user visible names and then called. Then there is a PL interpreted languages. It's the same function actually in both cases, or similar function. And the right side you see a nice feature of Postgres called $ quoting, so you don't have to / quote or everything in your strings. And also in Postgres version 14, we have ANSI standard SQL, where you start things, you begin atomic, and you don't need to put your SQL function in quotes. You still can have the quoted version, but there are some subtle differences. And then there are two kinds of functions also, one somewhat trusted and the other untrusted. C and internal functions have the full access always, which means that they can do anything. So if you allow somebody to put their own C functions in your database, then they can easily bypass any and all security controls, privacy controls. Then there are untrusted languages, which are usually trusted on the database side, but they can do things like opening files, sending signals, opening sockets. And the untrusted doesn't mean that you think they crash. It means that you don't want to give them to people you don't trust. They can do things you maybe don't want to be done to your database. SQL is always trusted. So there are always all the standard controls apply, grants, and other things that you can define on your functions. And basically, trusted means nicely sandbox. Basically, you have good control of what your functions can and cannot do. So what is V8? V8 is Google's JavaScript engine that is developed for Google Chrome. It is actively maintained. There is lots of effort put into security to make sure that people can't break out of the sandbox and then do stuff you don't want to do. It is high performance. It actually has, I think, 3 or 4 different layers of JIT compilation and optimization, which kick in the more you run your functions. So it can be really fast. And it runs both JavaScript and WebAssembly. And you can integrate them nicely. And yeah, there's also one problem there, because there is no public version of V8 as library. Then if you want to use it, you must go through a quite complex process of pulling it and using some Google tools to configure it for your own compilation. And which means that for last 5, maybe even 10 years, Debian, Ubuntu, Red Hat have not been packaging it. They still are packaging Node.js, so that it means that somehow Node.js has circumvented this problem, because Node.js also uses V8, and they must have some good solution. We need to look at it. And here is a sample function. You just write it. And if you want to use PLV8 on your system that doesn't have it yet packaged, then you can pull it and make install. This make install works because they are using a repository some good person made, which pulls the original Google version and then modifies it to be built to CMake. It is currently not well maintained. It's a few, I think, at least several months behind, but it still has most of functionality. It has good performance. So just to try it out, it's good. Also, PLV8 is available by all cloud providers, Amazon, Microsoft, Google. So also, if you have an account there, you can just install it. And yeah, we need to figure out how to get Google packages also on board backend and start doing it. So how do PL languages work internally? This is what the documentation says. You do create language and then provide up to 3 functions. The first one is call handler. The second is inline handler, which you use when you want to use a do block, which is a feature of Postgres where you run a function inline without defining the function first, just you run the code. And then there is a validator that does just the checking and not actual compiling. And the documentation says that it must be written in a compiled language such as C, and it must be defined as returning type language handler so that you can't directly call it. But once this language is defined and you now define a function using this language, then what happens is this function is called, it still it actually calls the language handler function, the C function, and passes the info to the PL language or the language containing your source code as part of an internal structure. So your language handler must use that OID, look up the function, get its source code, do whatever is needed, execute it, and then from that point, it's again like normal function. It will need to return the return value converted from that function. Fortunately, the part about must be written in C is not true. You just, when you do create language, it just checks the signature. You can easily write it in PLV8. Currently, the only way to get a language in PLV8 to have the return type of language handler is that you must actually go in PLProc and update it. But it was a very small change in code to allow it also to be part as create function. And another nice thing that helped is that even if you have this kind of multiple layer, you have defined your language handler in PLV8, the thing that gets called by Postgres is still the original language handler in C. So I even didn't trace how it does, but it still goes to the original C function, the language handler function from PLV8 code. And this means that you can now add support for writing your own language handlers to PLV8 by just modifying PLV8 so that it will go checks the call function, and instead what it does now, just getting the source and compiling it and then executing, also caching. It now can check that if this language is something else than PLV8, then it can go one step further, look up its handler first, and then execute that one on your code, which transpiles your code, and then you get the already poured JavaScript function that you can then use as any normal JavaScript language or any normal PLV8 function. And yeah, that's more or less it. In this way, you now can write any your own language handlers. If you look up, there are hundreds of languages that are transpiled to JavaScript. Some quite exotic, some actually used by people. Original PLV8 had also, it included two transpiled languages. It had PL CoffeeScript and PL LightScript. It was dropped sometime during the last 2-3 years, but it did it differently. It had just compiler blobs in the code and internally compiled and executed them when the language was defined as PL Coffee or PL LJ. Now we can move them to external functions. And also one thing why you can create your language handler and tell Postgres that it returns type language handler is that there is no check when compiling PLV8 that what it actually returns. It is only checked at the time you call it. So you could also have the exact same code doing multiple different things, and then just the conversion determines what type it returns. So you can then define, basically you will define a JavaScript function that takes argument list names and types and return type and the source code, and then creates a JavaScript function with these by transpiling it from whatever language you have. So where we are currently, we have some proof of concept batch that sometimes crashes, but that basically shows that you can do it, it works. And we are currently reworking it because of it crashes. It shouldn't crash, at least the normal cases, which have happened at some point earlier. And most likely we will just put most of it in JavaScript and have the compiled part. Currently it also takes the source, puts it in a few more strings that turn the poor source into JavaScript functions, and then passes it to V8 compiler. So just putting the part that does transpilation there is probably the most least interruptive and most sure way to do it cleanly. So we would probably want to have clean samples of bringing PL Coffee, PL LightScript back, and also have good samples of how to do WebAssembly. And probably an option that will skip doing the translation from Postgres types to JavaScript types, because in many cases, you don't want this overhead, and you may want to access the arguments directly, especially from if you're using WebAssembly. So I am almost out of time. I'll go quickly about something things, yeah, and two samples I gave at the last conference was using JSON schema. There is a thing called PGXN schema, which is written in Rust, where you use it as a check function and then can validate. But we were able to actually use a JavaScript package. I think I had a sample how to use it. Just check. Oh, here it is. Basically, you use Browserify to turn this into a single function that will be then something 2030 kilobytes. But it has a nice feature that you can first turn your JSON schema description into a function and then just use the function, which makes it different from the Rust version where you always pass in the JSON schema. And then it actually made it faster than the Rust version for usage. And even the first execution, it took only about 100 milliseconds to pull in this 230 kilobyte JavaScript and compile the JSON schema to a function. And then you see 20,000 executions was 255 milliseconds, which means that it's a small number of microseconds for each execution. And the other case was also how to use WebAssembly. So if you are interested, then there are some pointers how to actually set it up and use. So I guess that's all. You're all welcome to also come up to me later, but let's take some questions if there are any now. Yes?
Yeah, so you mentioned the JIT V8. The V8 JIT, I assume, I'm not familiar with that JIT, but I assume it's tailored at optimizing larger programs and just the database functions. Have you measured the warm-up time and maybe the performance increase of the JIT's work over database functions? And do they persist between database reboots, or will there always be a warm-up?
No, there is no persistence, and that's it. Generally in Postgres, it works much better if you use long sessions. Not just for that, but all kinds of caches work much better. So, but the warm-up time I have specifically not measured. I think in the very newest ones, there are even some options to force the compilation and optimizations ahead of time. But still, it takes some time to come up. So a few tens or hundreds of milliseconds for the first execution, and then it gradually gets better. It mainly, even for small ones, it still can be significant because it optimizes things like type inference. It doesn't use functions that work for all types. It replaces them for single type functions if it sees that it's always called to a single type. So, but it happens gradually currently, and then you should use your functions in longer sessions to get the full performance.
Thank you.
Yes.
Okay, I have lots of questions, so I will start with more. So this specific JSON validation, because I just looked at it with Rust, so can you repeat again? Can you repeat again why the Rust is slower than what you expect to achieve with V8? What exactly? Because I was actually ironing this.
Yeah, because this is because the Rust version check functions take the JSON schema as a text or JSON as a first argument, and then the actual thing to validate as a second one. And it's implemented so that each time it will need to compile the first. It kind of applies the schema against the thing, but the JSON version, JavaScript version, separately compiles the thing into a JavaScript function that then gets repeatedly applied, and also then all the optimizations as these kick in, and they gradually make it faster and better.
Oh, okay, so it validates the whole JSON tag right away.
It converts it to a real JavaScript function. It builds a JavaScript function based on JSON schema that does the validation against this schema.
Okay, and second question, and the rest I will ask later. So I am actually a huge proponent of using functions for exactly this reason, because I work with real-life applications and I know how it impacts. However, I was always wondering, so when you introduce another language, so the most positive impact we have when we can operate with sets rather than individual like scalar values, that's the way to conquer object relational impedance mismatch pretty much. But when we call languages other than PGXN, then we still cannot really operate on sets. So what I'm missing? I understand this particular implementation, like the functions which you described, I understand where they are getting the speed up, but it's like it's pretty much like milliseconds, and that's important as well on things like this conversion. But most of the improvements on the using functions versus direct SQLs is first that they do not leave the server, execute everything on server, and the other thing is that they can process bulk at the same time, which again, when you call any programming language, you lose this ability to be declarative rather than imperative.
Yes, that is a thing, but it looks like it's got much better. For the example, in this sample, you see that the function is single function call with all the call overhead, and it does quite a lot inside the V8. Is still that the single call is about 10 microseconds, so it's not that bad. But one thing I hope we get to in this PLV8 is at least avoiding the conversion of data types. Because this one runs fast because data types use the byte A, which is basically just a copy. But and hopefully we can even get around the copy at some point so that it's directly usable.
Okay, cool. Okay. All the rest of the thank you so much.
Yeah.
So you mentioned the option of possibly writing a PL any handler that declines the automatic conversion of argument types, so it can do that itself. Have you worked on an API? Is there documentation available for what the PL any language handler will see and how it is able to access that information and do the conversions itself?
My current idea is that its main use case will be WebAssembly inside V8. And in this case, what we need to do currently, we already compile lots of our code to bytecode for LLVM, for JIT. And we should just do the same compilations into WebAssembly. So we could use the type access functions from WebAssembly and then provide the direct pointers to arguments to WebAssembly. So in this case, it's basically the Postgres code for operators and modifications that is used directly from WebAssembly. So it will then avoid the conversions. I haven't done any in-depth thing, but the basic idea is that reuse the work we did for LLVM and then do the same thing for WebAssembly and then have the type functions available directly to it.
So there's an effort to, or there could be an effort to make it easy in the language handler to deal with things like the variable length data types.
Yes. Variable length anyway needs to, there should be some support, say on the Rust side, if we use Rust to compile to WebAssembly. It already has this for browsers and Node.js, so PLV8 should be just the third target for that. And then that could also use the pre-compiled WebAssembly blobs for type accesses and other things to do direct data access instead of needing to go through JavaScript and then WebAssembly. I guess we should let the next one in here. Probably one question, probably, and then I think we are done.
Thanks for the talk. Maybe a little unrelated question. Like browsers are usually updating with a very intense pace, mostly due to security reasons. Do you need to update PLV8 extension with the same pace as browsers do? How many vulnerabilities are introduced in V8?
I haven't seen any packages currently doing it too much. When we started supporting PLV8, we had some security things fixed and reported back, but none of them were very serious that would have required kind of immediate update. But they looked like something that potentially could lead somewhere. So yeah, but it is reasonably secure anyway. I guess if there would be some large breach, then it would be same as with Postgres, and then you should do emergency releases. But I don't think it is much different from that, and usually you can keep using quite old versions for a long time. It is a quite mature product. It has been in use 20 years at least, if not more, and I guess there are not. Of course, and probably if anything is discovered, we will hear about it. So, I guess we should be out of time.
Does it work? Can I start? Hello, fellow extensions developers. As every one of you knows, like extensions are very easy to use. Just click it, download it, use it. If you don't like it, delete it. No problem. It's fun to use it, and it's really hard to develop. And today I have a purely theoretical talk how to make core development the same hard. Bring same problems from extensions to core development. Like this is more like a talk to think about possibilities. It's not like real features that I'm working at full speed right now, but it's something that some other databases have, and why not to think about it. My name is Andrey. I'm working for Yandex. We have on a scale of some tens of petabytes of hot data in Postgres with some millions of queries per second. Not that much, but it's enough to feel pain of a scale. So I lead a team of Postgres hackers. Some of them are active on mailing lists. Some are working on extensions, just like we do here. I'm not a real expert in PG upgrade. 0 of my commits are in PG upgrade. But I reviewed some patches, and like git log mentions my name more than 100 times, so I know a thing or two about Postgres. But, well, reports about a problem and reverts also contribute to this metric, so it's like there was some reverts and a lot of them. Never mind. So, PG upgrade is actually functioning quite good because Postgres is popular. It has to function like properly. We can upgrade several petabytes, several terabyte cluster in few minutes with only a few minutes of being read-only without real downtime. If you are running service with 4 nines, that's okay. If you don't have more failovers in a month, you still fit into 4 nines. And this is good part of PG upgrades. The other part of PG upgrades, that it's not like an extension. It's difficult to get it right. It's hard to use. And the recent example that I saw on the internet is like if you use it wrong, you can corrupt the database. There was a very interesting write-up by Adient, how they corrupted their database by using upgrade and forgetting to turn off auto vacuum. And the fun stuff is that I had this in my production too. Here is some excerpt from our upgrade code. And this is a fix of a corruption. Spot the bug. Here is the space. In one comment, it was introduced by auto-formatting. It's not a developer who introduced this bug. Well, arguably it was a developer of formatting tool, but still, like it's so easy to mess up. This small bug was haunting our databases for a long time. So upgrade is a sharp tool. You have to know what you're doing. Very unlike with extensions. Extensions are mostly safe. Like still some strings attached, but you can experiment with extensions. You cannot experiment with upgrade at all. Like upgrade is a tool for high-level specialists. But upgrade is like you have to do upgrade every year. And this is a tricky operation that you have to do often. And if you're trying to change something in upgrade, we have to consider many dimensions of a complexity. Like Postgres is a super stable database because it's popular. We have to think about every possible workload that can be affected by our changes. Looking from this perspective, you shouldn't change anything at all. Just fix bugs, not do new features. But, well, for many decades, we are innovating. We are still bringing some new functionality. Performance is also a questionable part because, like, you want fast upgrade, but also you want fast database, and they might contradict each other. And most important part is pace of development. How fast can we bring new features, and how long we have to support old deprecated features. We have some now. Here are some examples. For example, we still have visibility flags heap moved in and heap moved out. They are from Postgres 8 to Postgres 7. I do not remember actually, but they are very old. They are not set by new code, but they still can be in your tables because they might be there for decades. Or another example, just invalid tuples, which are remnants of another concurrency model. 10 years ago, 15 years ago, just had another way to deal with a crash during page split. And these tuples are still supported by Postgres code. And many other examples. Here is a link to the mailing thread where we discussed that stuff. In 2018, I proposed, let's remove code that could end by 2023. I didn't start that. Back then, in 2018, I was scared of something that lasts a project that lasts 5 years. I shouldn't be. I should just go and do it and start back then. If I start now, I will finish by 2031. But still, I have to do it. And this part is handled by So our upgrade has no dependency on the size of your cluster. Millions of tables, you still have a very, very long upgrade. And that's a problem too. So what another part of upgrade, and then on and on. What changes are done to the system by PG upgrade? Well, most notably, we can see these changes in a Git log of cat version. We embed in the binaries catalog version, and every time a developer changes something that needs PG upgrade, they bump catalog version. So you can use just simple bash to compute number of commits that need upgrade. From a release to release, we stably need 80 changes. Like sometimes it's 75, sometimes it's 85, but most of the time less than 100, more than 50. That's interesting invariance that we are changing catalog with the same pace all over again and again. But the catalog is not the only thing that is changed. We have physical changes. Most of the time they touch wall. And when they touch wall, they have to upgrade another magic constant, which is called xlog page magic. It's embedded in every page of a wall log. And this is a part that cannot be managed as extensions usually do. This is a too physical part. Like one binaries can read and write this type of wall, and other cannot. But that's not that often. We have like 5 to 10 changes from a major release to another major release. So we can live with it somehow, or deal with it in a way. There are some other versions. For example, each heap page version, each heap page have this version tag, but it's not really changing recently. We might want to change it in future, but now it's very stable for many years. How other databases do it? For example, I took Microsoft SQL Server because they have this nice way to change compatibility level. How it works? If you have a database with old compatibility level, you can install new version and just restart SQL Server instance, and it will run database instance from previous version in a compatibility level. So you don't have like lengthy downtime. You still have some milliseconds to stop, to shut down one process and run another process, but it's much less than minutes that we have now. But at some point of time, if you want to use new features, you have to issue this SQL query, alter database, set compatibility level to some actual level. And the interesting thing is that they still support Microsoft SQL Server like 2000 or something like that. So each new version, like SQL Server 2022, still support 22 years of different versions. That's a huge amount of work to do to maintain all like unusual ways to deal with data. Can we have something similar in Postgres? Well, it would cost us some efforts. First, like catalog changes are very known problem for extension developers. You all write these SQL scripts that upgrade your extension from one version to another, mostly without downtime. This is just a like create new function or change the signature of a table. Most of the time you write your alter tables the way that do not require table rewrite. You don't want your users to wait huge amount of time when they are just upgrading an extension. Physical changes in wall or in some in memory structures need a restart anyway. They require to shut down, and well, upgrading without stopping process, it's doable, but super tricky. Let's not touch these matters right now. But moving most of the work done by PG Upgrade into extension-like functionality require binary change to support binary code to support both version of anything that you're trying to change. So I'd say that it slows down every feature that require catalog change, development of every feature that require catalog change by at least a factor of 2 or 3. It's not order of magnitude slower, but still much slower to develop new features. What is the most important feature of extensions that we would like to see in upgrade? Like extensibility, like being able to issue leave query to upgrade system catalog. Well, it is important, but it's not most important. Most important part is not extensibility, but like opposite, I said shrinkability. You can drop extension. This is the best feature of extension. You don't have to be afraid of extension because you can get rid of it. And core doesn't do it at all. So we support old features. And if we could bring a feature to drop something that is unsupported, even if it takes time, but if it's restartable and interruptible and incremental, it would be much better than we do now. So if we want to get rid of gist invalid tuples or heap moved in, moved off tuples, we don't have to introduce new upgrade which scans through every table and every data file and every index. We just should create a new service operation that deprecates some old data formats and guarantees that there are no remnants of old format on disk. Current approach that is taken that was planned a few years, 6 years ago, was that we add time when last vacuum or full scan gone through the data file to PG class, and ensure that you have scanned through all the table. But if we introduce just service operation, we can ask user to prepare database gradually for upgrade and then do a real upgrade. How this might look like? Well, at some point of time, you still have to download new binaries, install it into your system. Probably it's better if we start new major version in the primary, which emits timeline switch, and when standby sees this timeline switch, they just wait. They are still in read-only form, but they wait for they to be shut down and upgraded to new version, and then continue OLAP application, will redo. This will ensure that even when we restart the cluster, we are not completely down, we are just read-only. The cluster is able to show data. After that, the cluster should run in a compatible mode. So it should be able to run on a previous version of system catalog. And then when the user is executing some cleaning procedures, we might call it deprecation or maintenance or whatever, I don't know how we should call it. We can proceed to upgrading the system catalog in an online fashion. So just do this like alters register of new functions, drop of old functions, and all the other stuff. So heavy rewrites, heavy locking operations have to be done while the cluster is operating in maintenance mode. For example, you want to change something in the format how you write files for two-phase transactions. First, you have to support a new format in a binary code, and then you have to wait for a year so that every upgraded instance now supports this version, and then you run deprecation procedure to delete old two-phase commit files, and then you can remove support from a code. So actually, it is expected to last for 3 years. Any format changes cannot be faster than 3 years after you adopt after we adopt such a way of dealing with changes. And as we see previously, something similar will have to be done for 80 commits. So 80 commits would last for 3 years. This is a price that we would have to pay for our users not having a problem and pain of upgrades. Should we pay it? I don't know. I'm afraid that probably no, we shouldn't. But this is just an idea to think about. Maybe at some point of time, Postgres will be so stable that we won't actually to pay it. That's 80 commits that last for 3 years won't sound like a lot of extra work for millions of our users to have easier upgrades, online upgrades without downtime. Many critical applications depend on Postgres, and they are stopped each year for several minutes to do this upgrade. We can improve here. I know every one of you knows what is it. This is a compatibility macros that all we have in extensions. And we will have this in core too, in a lot of ways. Unfortunately, this technique cannot help extensions at all. So it's just will make the problems from extensions also in a core. But probably our users could be much happier. That's the idea that I wanted to discuss. My presentations ends here. Do you have any questions? So.
Have you thought of doing this kind of online upgrade or slow but non-invasive upgrade as part of physical vulnerability play instead of trying to just support it everywhere? Would that work in some ways, maybe with less effort?
I think I didn't get it. Of part of physical what?
So we should do physical replication so that you would have a replica that is knowledgeable enough to do the changes while applying to a right-hand node. Would that make to work in some way?
If you have a different system catalog on standby, you cannot apply records from a primary that have like.
It has several limitations, let's say. But maybe they are kind of.
I like the idea, but I see only problems. Like any
semi-logical replication that already a better version.
So you have a logical replication of system catalog, but physical replication of data files and indexes and extensible resource managers.
And that would also mean that at least the sizes of tuples shouldn't change. You could say deprecate the flag while applying, but nothing else.
That's an interesting idea. I'm not sure I can like think about it online, but we are here for discussion anyway.
Okay, a little bit off topic, but since you mentioned, as a person who constantly suffers with catalog tables having many millions of rows, and kind of looking at catalog more than I would like to, and seeing that it was designed like long time ago and probably needs upgrade. Anybody ever thought about actually making PG catalog better? Because it's like, I would love to. Have some extra indices which are missing, some foreign keys in catalog which are missing, and things like that. Because it's not like, it doesn't have to be that slow. By the way, when you have several million tables, I can tell you just system restart takes an hour and a half.
Sorry, I didn't get a question. It's just.
What's the question?
Yes.
Do you see whether it's possible to make changes to Postgres catalog? All the changes we see, with each version, there are more and more tables. All tables remain the same, and all the deficiencies of current catalog are remaining the same. There are lots of new tables and new columns every time with each version. Do you see anything which would prevent the existing catalog to evolve? Because it doesn't have to be this way, what I'm saying. It doesn't have to be that multi-million rows in catalog table is a showstopper.
Yeah.
And it is, not only for upgrade, for everything.
Recent radical change in the catalogs that I saw was proposed like 7 years ago to have a purely in-memory temporary tables. Because when you have millions of tables, usually it's temporary tables, not stored tables.
No, real one, not temporary. Users are creative.
Yeah. Well, like if maybe we can recommend them to restructure database and like try to million of databases, million of tables is like too much for not just the catalog, but for relation cache, for system cache, for anything around caches.
But we can have anything else millions without any much effort.
Yeah.
So why tables are?
My point, we are pretty happy with like multi-million tables. Why catalog actually like cannot handle a couple of million rows?
Sorry, I don't understand.
We'll pass it to the court. Okay. We understand what we're talking about, right? Okay.
We can have millions of anything else, but not tables or not database objects. So it's kind of a disjoint thing. We have a good database, but not good database for handling itself.
You can have a million of Postgres clusters.
Yeah, but you can have a billion of rows, and it also works.
Yeah.
But we'll take it offline, I think.
There are many problems with huge catalogs, and I think most of it's also connected with the trading part that we have like process architecture that have a cache of all catalog in every connection. So that's where the roots of catalog problems are. That we just have to cache it somewhere, and this cache is per connection. Okay, so thanks everyone for listening. Thanks.
switch it up, and then second one gets it.
All right, thanks. Well, good morning, everyone. Good morning, everyone. I'm Paul Jungwirth. Thank you for coming. I'm a freelance programmer from Portland, Oregon. I've been using Postgres for at least 15 years and building extensions for most of that time. I want to talk today about how Postgres inlines functions. I don't mean C inline functions, but the functions that you call from SQL. So mostly I'm talking about user-defined functions. Postgres can inline its own built-in functions too, but getting your functions inlined is more interesting. So I've got three categories that I want to cover. The first is set returning functions, which Hannu already brought up earlier this morning, or SERPs as I like to call them, that are implemented in SQL. Also other functions that are implemented in SQL, and finally SERPs that are implemented in languages besides SQL. These are all interesting to a Postgres developer and especially to an extensions author, I think. For extensions authors, I think that the last one is the most interesting. So probably you all know this already, but a set returning function is a function that can return more than one result. Typically, each result is going to be a row, so a composite type. Let's say that we have a multi-tenant e-commerce application. So we've got users, we've got companies, there are sales records being generated, and a user can belong to more than one company. This is a great use case for a set returning function because a user can't see all the sales in the database, right? We need to have some permissions logic to restrict which sales they can look at. You can only see the sales from the companies you belong to, let's say. If someone tries to see someone else's sales, that's out of line. It's convenient to wrap this logic up into a function. As we have here, we can call it visible sales. So you can think of this function as a parameterized view, really. You're getting back a table when you call the function. The only difference between this and a view is that you pass in a user ID to control what the results are. This example is based on several real customers that I've worked with, except their visibility functions are much more complicated and costly. You probably have permissions logic in your applications that could use something like this. And it would be really nice to encapsulate it as we have here in a function. Ideally, our function, our visible sales function, would compose well with other parts of the query. Encapsulating it this way shouldn't hurt performance for us. Here, we're looking up user one's visible sales, but only for a specific vendor, just vendor ID 5000. But this plan is not what we want at all. And Postgres will call our function to find all the visible sales, and then it will filter them. So it finds more than 50,000 rows, and it throws out all but 2. Can't we just go straight to the ones that matter? Note that here our query time is 58 milliseconds. This plan would be much better. It takes less than 1/10 of a millisecond compared to the 50 plus. Instead of calling the function and going over all the sales, Postgres merges it into the rest of the query. Basically, the planner is removing the func call node and replacing it with the query node based on the function definition. You can see that our plan has no more function scan. So first of all, there's no function called overhead, but that's really almost nothing. The planner thinks that we just have a subquery here, so it can apply all of its tricks. After unwrapping the function, it can rearrange everything into the larger query plan. Without that opaque layer, it can make much better estimates. And it can push down conditions, which is happening here. Our company filter is pushed down into the query on memberships. And also, this is an index-only scan because we only need the company ID. And for each of those, we'll find the visible sales using the index. You can see that Postgres is estimating 7 rows. It finds 2, so the estimate is very close also. As long as we can declare our SQL function as a stable function, then this is what we get. Stable means that our result might depend on what the tables contain, but otherwise it gives the same result for the same inputs. So there's no randomness, there's no time dependence, and it doesn't modify anything. Basically is what you require for a stable function. To get this slow plan back here, you can see I'm actually calling visible sales slow, and that's just the same function but not defined as a stable function. OK, by the way, this is not very well known, I think. It's not in the Postgres docs. I would like to submit a patch for that. There is this wiki page about it. I forget how I learned about this behavior, actually. I checked 5 books for this talk that were about Postgres performance or advanced Postgres usage, and none of them mention this behavior at all. But it's great news, I think. We don't need to fear performance when encapsulating our logic inside functions. But the big drawback is this only works for SQL functions, so not PGXN functions, not C functions, libv8 functions, Python functions, et cetera, because Postgres has to be able to see into your function and extract the query, right? And thereby convert it into a plan tree. So here's another example with just a couple changes. We're looking at a company that does have a lot of sales, but we're paginating the results and showing only 10 per page. And this is still very fast. We scan all of sales, but then we quit after 10 rows. And again, the permissions check is just an index-only scan. So again, these benefits happen because Postgres is able to inline the function for us. Let's look just a little bit about how this works. The planner has this function called inline set returning function. Obviously, the real thing is about 10 times as many lines as I'm showing here, maybe more. But I'm just calling out the essentials. So first, we look up the function definition. We also build this pinfo struct, which will let us wire up the function's own parameters into the generated plan tree. We parse that into a query node. And then we take the function's original parameters and inject them into that query tree. And that's what we return. And then the planner has this subquery that is part of the broader query, and then it can do all of its rearranging and magic for us. So here's a query that I wish I could generalize and then inline. And it's kind of the whole motivation for me looking at all of this in the first place. It implements a semi-join between 2 temporal tables. So you may know that SQL 2011, the standard, introduces a bunch of new features for temporal tables, which are tables that keep track of their history over time. But it doesn't give us anything for outer join, semi-join, anti-join, aggregates, union, intersect, or except. So we have to build those in SQL ourselves or take care of them somehow. I have a GitHub repo with SQL-based implementations for all of these. And it shows the pattern that you would use in SQL, and it has tests to validate those queries. But what I really want is to wrap them up into functions like this, but of course not with tables named A and B, but really functions like this. So you can give this function the table and column names, and it will build that previous query with the correct table and column names. The problem is then your performance crashes, because this function can't be written in SQL. It's written in PGXN. So if only Postgres could build this SQL and then inline that. We are so close. Let me just show you one other thing. There is a way for functions to advertise a plan tree that would be equivalent to calling the function. Here's an easy example. Let's say that in the same database with sales, we have salespeople, and they get a commission if they're responsible for the sale happening. So our sales table has a salesperson ID. Our memberships table tracks what the commission is for that salesperson. And here's a function that will tell us what a salesperson's commission was for a sale. It's a little bit of a contrived example, but it's just an example. But also, a sale might not have a salesperson. And in that case, the commission should be declined. We don't really have to look up anything at all if we have a null salesperson ID. And we can determine that at plan time, possibly. And Postgres has a way for us to do that. OK, let's see. Here's getting the sale. Here's getting the commission. Here's the pgproc catalog table, line by line. Every function can carry around a helper function called a support function here in the pro support field. Support functions answer various questions at plan time. Each kind of question is called a support request. And if the support request function is present, it will get asked all these questions. If it doesn't know how to answer a certain kind of question, it just returns null. Otherwise, the result depends on what support request you're answering. That's the general interface. So if you want to write one, now you know how to toe the line. Today, there are 8 support requests. Here they are. The first few help the planner to make decisions. This first one, support request rows, is how many rows are you going to return? By default, the planner assumes a setReturning function will return 1,000 rows. You can override this with the static value when you define the function. But a support function lets you choose on a case-by-case basis when you plan each query. I had a patch accepted to 17 for this, for Postgres' built-in unnest function, which is just a good example. If it already had a support function, and if you gave it a constant array, it would use the array length to say how many rows it was going to return. So my patch added to that so that if you give it a column, then it will use column statistics to guess how many rows it's going to return, which was something important to a customer that I had and substantially improved the query. So this support request can make a difference, I think. Similarly, you can help functions to say what their selectivity will be or their cost will be. Then there are some fancy ones. This next one is what is an index condition to pre-filter the rows going into this function. I believe that PostGIS uses this a lot. And I feel like you could add this to some date functions maybe to take advantage of indexes, because it's easy to write date conditions that don't take advantage of indexes, right? So I haven't thought too deeply about this, but I'm curious if it's an opportunity for removing a footgun. There are a couple for window functions. There's one to modify composite values in place. If you have a fancy custom type, that might be of help to you. The fanciest of all is support request simplify. This lets a function replace itself with an arbitrary plan tree. In the docs, this is used for mathematical identities, like anything plus 0 should be just itself. Here's an example, kind of like that. The commission since function. If we have no salesperson, then we know it's going to be 0. This query lets us gives us a report for any month and any salesperson. But we also want to know about sales with no salesperson. All we have to do is set the parameter 1 to null, and commission should be 0. But maybe there are a lot of these sales, and so we don't want to call the function over and over again, and we would like to just get a const 0 into our plan. And we can do this with support request simplify. Here's the same function, but with a new last line, where we're just declaring this support function. Here's what the declaration looks like for the support function. Of course, all the details are in C. It takes internal. It returns internal. And here's roughly the C code for our support function. You can find the complete code in the GitHub repo for these slides. The first argument is always the support request struct, which is just a node. Each support request has its own node type. So we have to make sure that the one we get is a support request we can handle. It gives us the parse tree for the function call. So we grab that. And now we can look at the arguments that are being passed to us and see if they're const, and what they are. Here's the support request simplify struct, by the way. So this is all the information that your function receives. You can use what's here to rewrite the function. So mostly we have the function call node, but that includes its arguments. We also have this planner info, which gives us some context if we need it. OK, back to our support function. So I'm skipping lots of error checking again, of course. Here we look up our function's second argument. So not an argument to the support function, but the argument to the original function. and that's the salesperson ID. If it's a const node, and if it's null, then our result can always be 0. And so we just return a 0 const node. And this will get placed into the query plan. Otherwise, we can just return null, which says that we can't make any simplifications, and Postgres should just call the function. What about handling non-const inputs? If our function is part of a parameterized query, like from PsychoPG or some other client language, then by the time we get here, those have already been converted to const nodes, and so that's covered. But if it was called from another like wrapping SQL function and passed parameters from that function, then those would be param nodes inside of our func args and not const nodes. Those aren't bound yet, so we don't have any knowledge of what they'll be. But if you can simplify other parts of the result, you can still do that and wire up the params, just as the SQL language inlining that we saw was doing. I haven't experimented with this yet, but it should be possible. And the point is that you don't have to return a const. You can return any other thing that simplifies calling the function. So what I asked myself was, could I return a query? And would this let me inline the temporal semi-join function? Sadly, that doesn't work because the planner simplifies set returning functions in a completely different place than simplifying these other functions. And as I said before, the idea behind this feature is really for like mathematical identities and simplifying scalar functions. But there's a patch for that. What if we patch Postgres? Over in that place where we inline SQL language set returning functions, let's accept a new support request to inline a function in any language. So I'm working on a patch for this. It got neglected this year while I was fixing bugs in temporal foreign keys. But I'm starting to pick it back up again. I think it just needs some refactoring. Having any of you check it out would be fantastic. Why not test it yourself and give me some feedback if you're so inclined. So here you go. This is the new support request that I'm proposing. And this is what you would write as the support function author, approximately. Once again, error checking wildly absent. I'm not even checking for constant inputs here, which you, of course, would do. If you want to see the real thing, you can look at that temporal ops GitHub repo where I have a support function for temporal semi-join that does this and uses a patched Postgres. Somehow you build your SQL string, and then Postgres gives you everything you need. You parse it, you do analysis and rewriting, and there's your result. This is basically just the same thing that we saw in the SQL inlining code that's already in core. But still, there are some caveats. The support functions, in all cases, your support function has to be written in C. This makes it hard for users to access, especially since these days so many people are in the cloud. I've kind of wondered if you could have some kind of C shim that dispatches to a user-supplied function, maybe it's in PLPG-SQL. That might allay cloud vendors' exploit fears, but I'm not necessarily sure it would allay all the security fears of the database owner. I'm not sure if there's security problems with that scheme. Maybe we could push things even further. Here's the temporal semi-join function again. You can see that we end with this return query execute. This has got to be a very common pattern, right? You build some SQL, and then your function runs it. Could PLPG-SQL even notice that your function has this pattern, that it's a stable function, and automatically attach a support function that checks for all const arguments, runs the PLPG-SQL up till return query execute, and then uses that string not to run a query tree, but just to build the query tree and then return that? I feel like that maybe is feasible. Accepting all const arguments is a little bit annoying. So to really dream, what if we did accept non-const arguments, as long as they just got passed through as parameters to the execute, and then we wired those up as parameters to the constructed plan tree, the same way that SQL language functions are doing. I feel like that's probably too much to ask, but it would be really cool if we could do it. But here's something maybe that is more realistic. if this patch I'm working on gets in, maybe you could even have an extension that does this, or eventually put it into core. But the extension would define a general purpose support function that lets you attach your own PGXN functions or whatever and dispatches to them. And it passes a JSON version of the func call node. And then your PGXN function just returns a string of the SQL that should be used. And then the extension does those steps that we've seen before. It parses the SQL just like an existing core Postgres SQL function. And then you've got your query node, and that can be inlined. And then I think you can even support parameters in that way by just including param nodes in the built plan tree. Again, all of this is kind of proven out already by the way we inline SQL functions. So anyway, I'm excited to see what people do with this if it gets into core. I feel like it's one of the most exciting kinds of features because it's the kind that lets people do things that the core team hasn't thought of yet. Postgres lore is that we started out in Lisp, and our C is still kind of Lispy. So what if we gave people macros? Here are some references. This first one is the slides itself, so that will get you to all the other references and everything else. I'm happy for any questions, feedback, flames, or anything else. Yes?
So in a lot of PLs, when you're writing a function, you have access to some API that lets you use essentially SPI to plan and execute a query. How far would it be, thinking about sort of automating production of a support function, you could do that by returning a string and passing that to the parser. How far would we be off from like using the PL's existing support for planning a query via SPI and using the results of that?
I'm not sure what would be the advantage of planning it with SPI instead of just calling the plan query function.
It may just be that you're working in a PL that already for years has had the ability to plan a query and pass it parameters, and maybe does not have any API yet for calling the Postgres parser with a string and getting back something for a support function.
Right, but if it's an extension, then it has access to those functions, right? I mean, those are.
Yeah, but they're not always visible to the author of the.
Okay, to the author.
In the PL, right? You're writing a function in a PL. You already have this interface provided to you in Tickle or Java or whatever you're using that looks like SPI and what you're already familiar with doing in SPI. Which under the hood is getting passed to Postgres parser and producing all of the data structures I think you need for your support function.
Yeah, I guess I would want to try it out. But I mean, if you're able to generate a plan tree, then it might be OK to use it. I mean, I'm a little confused because that still has to be in C, with a tree of C structs. Maybe it looks like maybe Hannu has a comment about this.
Yeah, my question idea is maybe we could just define a few extra return types of function that can return a query tree, that can return another query or a function, so that it's explicit there. And then when you call such a function, then it is actually evaluated like a macro, and then the return thing, either just SQL or anything else, will be integrated in the outer plan. So maybe that could be a way to abstract it. It's still hard to write and figure out, but kind of the user-visible abstraction could be yet another return type.
Yeah, I think both of these questions are kind of seeking the same goal, which is to make it easier to write these support functions without using C.
In this case, it would even be kind of as a support function, it would be more like a macro-like behavior, which, as you described, is currently available as support functions, but maybe it will be easier to understand, easier to explain if you just say that this function returns another function that is then used.
Right, right. Yeah, then you're probably, it seems like then maybe you're building a whole new abstraction or facility within Postgres. And so we already have support functions, which seems like the easiest place to add a feature like this. But yeah, a way to do it that didn't require C functions would be fantastic.
That was my idea, to expose it to wider public of developers to use.
Right, right.
Yeah, I was thinking rather the same thing as some way to expose it in SQL so that any of these languages could use it without any additional support, whether they return a custom data type that's specific to this, or if they just return text and a list of parameters that then some other function in SQL could pass those parameters to actually do the node manipulation. Seems like there are a bunch of potential ideas and possibilities for make it available in SQL effectively.
Yeah, yeah. If any of you have suggestions about that, I'd love to talk about it more. Right now I'm just using support functions because it's available, but
one idea is to use the with feature, so that if you put this macro-like thing as with, then you could kind of generate, say, another function or return part of the query tree. I have actually been thinking of adding function support to it, so that you don't need to define them always as functional procedures. We could say with this function do something. But that would then go one step further and use existing function to return the function that is then evaluated in the with. Maybe it's better separation of things and easier to understand, easier to explain.
So like a CTE,
yes, it will be the same CTE mechanism, but also but there will be a special form of CTE that evaluates something and then uses that as the real CTE that then gets evaluated and called.
Okay. I'll have to think about that one. But all right. Well, thank you, everyone.
And last thing, this works. Awesome. Okay, so let's go. All right. Well, thank you everybody for being here today. My name, in case you don't know me before, is Alvaro Hernandez, and I'm going to present a topic that you may think it's related to containers and definitely applies to containers, but it's not exactly all about containers, and actually could apply to almost anything, like running Postgres anywhere. So I'm sure you've gone to a restaurant, right? And you open the menu, and you pick whatever you want. Now, I want to claim that with Postgres extensions, you can barely do that. You just need to pick whatever someone has prepared for you. It's like meals, right, that come prepared. And I would like to have a way to go to a restaurant with Postgres and pick any extension that I want anytime in a very easy manner. Before that, just a brief who am I. You can read it on the screen. I'm just going to say that I like to do crazy stuff with Postgres. I like to try to think a little bit out of the box and come with stupid ideas. Some of them eventually end up being not that stupid. So, well, maybe this is one of them. Or maybe it's a stupid one. Let's see. Anyway, running Postgres in containers. Again, don't worry. I'm going to talk about containers, but not that everything are containers here. But anyway, let's start with this point, just to get it straight. So running Postgres on containers is fairly easy. It's as easy as it gets, right? You just run Docker, blah, blah, blah. I can actually demo this if someone is interested, but I think everybody knows how to do this, right? It just works. Now, by the way, this is using the Postgres official image. Just for the record, it's still a little bit off topic, but everybody thinks that this is the Postgres official image. It's not. Well, there's nothing really official here anyway. But this is Docker's official image. It's built by Docker. It's not built by Postgres community. Well, they're part of the Postgres community too. But anyway, just for you to know. So this is cool if you just want to run Postgres. But what if you want to run what most people want? What most people want are extensions. Extensions. Extensions, 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 extensions. Well, you get the point, right? Really bad actor. So anyway, if you want to run with extensions, things are not that simple. Well, you may say, come on, with Docker files, it's pretty easy. I just do a from Postgres, and then I create a derived image. Right? Well, in theory, yes. It's a straight railway. In practice, it's a little bit more convoluted. So why is that? Well, first of all, the Postgres official Docker image, that's the official name, comes with plenty of extensions already, the so-called core contrib extensions. But actually, maybe you don't want those. Or maybe you want one or two from those, but you don't want the rest. I mean, I have more than I want, not the biggest problem. Or maybe yes, I'll talk also a little bit about this. But what if that extension, particular extension that you want is not there? Now what do? Well, you need to typically compile it from source code. So now your derived image needs to download source code, needs to compile it. That extension will have dependencies, which you also need to pull. Maybe they're packaged within the base system that is contained within the Postgres image. Maybe not. Maybe you also need to build from code. Maybe you need compiler. Maybe you need support development libraries. And then you need to make a Docker file that will clean up after that and not lift all these building artifacts as part of the image. Otherwise, you'll end up with a few gigabytes image just for adding one extension, which is not best idea, right? Even if you manage to do all this and you have the knowledge to compile Postgres and extension, I mean, probably everybody here does, but not every end user is comfortable with doing this. But worse, now you've become a maintainer. Now it's on you to update the image, to update the extension. Now it's on you to check for security vulnerabilities. So now you're a maintainer. And all this because you just wanted this extension or that extension or whatever set of extensions, right? So it's not that easy. So I want this talk also to be a call for packagers or distribution creators to be able to find a way to package extensions in a way that can be easily consumed. And there's been plenty of efforts around being done. Here's another one. Now, one idea that I proposed some months ago is to use the OCI format, which is the format used for container images, as a transport, as a container for extensions. Whether you use containers or not, this could be a good idea. And actually, a small call out here for David, who actually followed up on this idea, took it quite far, and developed a lot of concepts around this idea. So here's a blog post if you want to check it out, if you haven't seen this. Now, let's think about how can we pack an extension or extensions in a container. Again, it could be used for running Postgres in containers or not, just because we want to use the OCI format as a container for Postgres and extensions. So I'm going to say there's three alternatives. The first one is what I call the fatty container. It's a bit fat, right? So the fatty container is very simple. You want to have 200 extensions? OK. Bring them all into your container image. OK, it will end up being probably a several gigabytes container image, but size does not matter, right? Or it does. Well, I'm not going to enter into that topic from that other perspective. But from the perspective we care, that is actually kind of a liability. Big container images, first of all, they're big. They take time to pull. If you're starting a Postgres node and you care about downtime, if you need to pull 4 gigabytes to start your Postgres image, may contribute to your downtime, right? If you're charged by network bandwidth, and in several environments you may be charged by network bandwidth, then this is going to cost you money. If you're charged by storage, this is also going to cost you money. But more importantly, there's an inherent security problem. The more code you have there, the more potential for security vulnerabilities. And in particular, extensions, what they are, they're essentially bits of code that someone has done and published on GitHub. You're pulling all that without potentially a lot of deep checking on the quality and security of those extensions. So I don't think it's a good idea to have a lot of extensions, essentially not vetted at all, into your container image and distributing this to everybody. Because people do care a lot about security, especially in container environments, because it's very easy to check for security vulnerabilities. And if you pack 200 extensions, you're going to have vulnerabilities almost yes or yes. And yeah, like actually a lot of people will not be able to use that because they run for security analysis on container images. They will say, no, your image is not valid. So this is not a very, very good option. There's another option, which is an approach that, for example, in my company, we've done for a software called Postgres, which is a platform for running Postgres on Kubernetes, fully open source. We've done this approach. This similar approach has also been done by Tembo and a few others. The idea is to dynamically inject the extensions into the container image. So let's start with a container image with no extensions. So it's not fatty and doesn't have the security vulnerabilities problem that I just mentioned. And then there's a mechanism that can pull the extensions binaries into the container image and wire everything so that it will work in the right way. This is OK from a functional perspective. But again, from a security perspective, it's also not the best idea. I mean, it's not perfect. It's not a bad idea, but it's not the best one either. Because if you're running containers, one of the assumptions actually is that your containers, or the container image on which it's based the running process, it's immutable. And this is violating that principle. Now you're mutating it. Actually, in the container world, there are tools that will flag this immediately and say, hey, someone is attacking you because you're modifying the container that you're running on. If you're running without containers, this may be less of an issue. But again, the same principle applies. If you want to know beforehand, if you want to know from a security perspective exactly which files, if you just have, I want to ask you, what is the SBOM? The software bill of materials of what you're running, and then you're injecting dynamically code along the way, well, you cannot provide that clear picture. So it's not bad, but definitely it's not the best option. So there is an option number 3, which is the subject of this talk, which is to dynamically generate container images. So why do we want to do this? Well, if anyone here is good with math and probability, probably you're maybe going to correct me now, but let me try anyway, right? Let's think of how many container images do we need to generate. If we want to generate container images with all the options, with all the extensions that we want, so basically, if I want to pack a number of, out of a catalog of, let's say, n extensions, and I want to pick at a given time r extensions, so I want r is 3 and n is 200. I have 200 extensions. I want to create an image with this particular 3. Again, if my math and probability is not wrong, with the help of some LLM that helped me also troubleshoot this and make sure I was not totally wrong, then the formula is this. This is a big number or a small number. Let's see. Well, that formula, that number, is bigger than this number. This is this part of this formula for r equals ½ and divided by 2, right? So this is a central term of this sum. So obviously, this number is bigger than this one. So let's look at how big is this number, so we know that that number will be just bigger. Right? So if we take N10, so a catalog of 10 extensions, I need to produce 252 container images. But if I want to provide hundreds of extensions, then the number is, if I'm not mistaken, larger than the number of atoms in the universe. And I don't want to pay for the bill for storing those container images, right? So because this is so hard, we had to come up with another way to do this. And this is, again, to generate container images dynamically, literally on the fly. Anyone wants to see a demo? Anyone wants to see a demo probably failing because of the Wi-Fi or whatever? Yeah. Let's give it a shot. OK, I need volunteers. Volunteers with sharp view, sharp eyes. Anyone can read anything there? Well, this is a set of images I have available for my set of extensions I have available for the demo. For you to trust that I'm not faking it, I want someone to tell me some random extension, and I will type that, right? So it's not prepared. Before that, let me just start with the demo first. So here I have a special repository for container images. Can you see the font? Is that OK? Maybe a bit bigger. Is that OK? OK. So let me do something like Docker. Let's actually, let's first do a pool. Then I'll run the images. Let's do a Docker pool. Here's my test server for images. Let's pull a usual Postgres image, no extensions, something simple, right? It just pulls from the repo. Take a bit depending on the size, the network connection. I'm avoiding the Wi-Fi from the room.
So size is important.
Size matters. Thank you. Well, let's keep this running. Actually, it doesn't really matter. It will just work because it was going to take some time. Or let's open it up for a different way. Yeah, let's do another one in parallel. So this will pull the latest version of Postgres image. Now let's say I want to pull Postgres at a particular version. Let's say 16.3. I just do this. This is cached. This I downloaded just in case Wi-Fi was slow. So this is just pulls Postgres 16.3. This is dynamically being generated right now, but it doesn't matter. It just looks, this one could be static. Now let's look at extensions. So any volunteer, pick one. PG stack monitor, right? PG under stack monitor. Yeah, stat, yeah, OK. PG stack monitor, all right. So what I'm going to do, I'm using a specially crafted URL format. This is not a URL. It's going to name and reference in container terminology, but I call it URL. I'm going to say, /e as for extension, and I'll say PG stat monitor. And this is generating dynamically a container image on the fly. You saw that it took, less than a second probably. And it didn't pull, it just pulled a new layer, which is the one for PGStat monitor, because the previous layer was already downloaded. It just downloaded a few kilobytes probably. It was so fast I didn't see it. OK, another one. PGML. I see why. Oh, this is not available for this particular version. Sorry. But OK, the demo had to have this one. Try again, please. B3gist. Is with underscore? OK. Oh, yeah. Thank you. Otherwise, we'll definitely not find it. This one seems to work. Excellent. Thank you. Let's do a third one to make sure that this is truly random, right? And I didn't ask anyone for favors before this to tell me explicitly the ones I needed. No, this is. So please, anyone. Sorry? GraphQL. Is it PG GraphQL? Yeah. OK, PG GraphQL. PG with underscore? I didn't say it.
Oh, you need to remove the B3 first. Let's check that is.
B3? No, B3 is. I also want this one. Now I want to container. Yeah, I want to add more extensions. I want to have a container with all the extensions that you have all said. I just removed ML because it was not available for this particular version. That could happen. GraphQL is written like this. Well, we'll see. Yeah, cool. So now, I mean, so far this could be all faked. Now let's see if there's some meat here. So what if I just Docker? Let's run this image, right? Let's give it a name. It's called PG. Let's pass a Postgres password, whatever. And let's use this. And let's run it as a daemon. I'm just going to run the container image. And now let's do docker exec on the PG, PSQL. Here connect, and select start from P available. Level extensions. And, well, we've got some extensions that are part of the base image. This will be removed later on. But here we have PG GraphQL, B3Gist, and PG Stat Monitor, which is exactly what you asked for. It worked. Sorry. Excellent. So, no tricks, no nothing. Really real-time generated images. Now, it's a bit awkward to see you asking for PGML, and it's not available. That was great. Because it's, I mean, I can do from command line, as you've seen, and it works, right? But in reality, how do I know which extension is available for a particular version? So on top of this, we've built a small website. Let me actually show you the website directly rather than the slide. It should be, no, this one, yes, this one, it doesn't matter. Yeah, so here's the website. Oh, the font size is a bit small. This is all work in progress. It's not officially published or anything like that. But basically, this is a way to actually do the same. And here's a URL. And well, this is like this really a la carte. This is the menu from the restaurant, right? I can select the extension here where we're doing 16.3, 16.3. There's no 17 here. Don't worry about this. This is just part of the process. I'll talk a little bit about this later. But here we can select the Postgres version. You could also have Patroni if you want as part of the image. And then I can add the extensions that I want. So here I have. Yeah.
Let's see if the PGML is there.
OK, that's a good one. PG. No, I don't see it here. Yeah, interesting. Well, I mean, could be some problem with the metadata. This is not all 100%. Again, this is just a work in progress. But it's a good one. We should double check that one. And well, this is usual, right? So here I can select the extension I want to add. I can obviously look for extensions. Actually, I could have done this. It's also not here. OK. So it's probably my slide that is wrong. Could also be. Here you have a summary on the right part of the screen, like which components are included, the size of the image, and how much space is devoted to each of these layers. Not all numbers are 100% right here. Again, these images are, the underlying images are work in progress also. And I can also generate a run command, so I can just run this directly. Or I also can pin the versions if I want to by just getting a SHA for the image. Right? So there is the option to run this from the command line. There is the option to run this from this website. And this website is powered by a REST API, which also helps with integration. So all these mechanisms will be published as part of this effort. All right, back to the slides. I guess you're guessing, right, how this works. So it's pretty easy. We just generate. There's a special web server that receives the request, generates a Docker file on the fly, and runs it very, very fast, and then serves the image. I'm kidding. It will not work. It will be painfully slow to do that. You cannot build images that fast. So the way it works is by realizing what is really a container image. And I'm not going to get into all the details, but essentially a container image, what is called a container image, is a set of layers where the layers are essentially tar files. Right? There's one layer for Postgres, one layer per extension. Those are just all tar files with the compiled stuff in. And then there's manifests that bundle them together. Those manifests are JSON files. So there are several to work on, but essentially the procedure here is what we call Dozer, Dynamic OCI Registry. So Dozer is a specially crafted, written from scratch, container registry that is capable of generating images dynamically. The way it does so is by pulling the layers that it has to pull, and then generating on the fly the manifests that glue them together. Doesn't need to generate or compile anything. That's why it's so fast. It's real time. It takes milliseconds to generate all this, right? And What it does, it is actually, Dozer is agnostic of the business logic, so it's not specialized for Postgres. It essentially exposes an interface of how do you want the dynamic image to be composed, and then you bundle in that logic, and you decide how you want to do that. For this particular example, what we're doing with Postgres, the custom logic is obviously Postgres tailored, and it leverages the fact that the images that we're generating contain a lot of metadata. This metadata, when pushed to this repository, is extracted into a database. You can guess which database is being used there. And then the custom business logic makes queries to the database to infer which layers do you want to pull, pulls the information from those layers, compose the manifest, and serve them over the wire. And it is conformant to the OCI spec. And yeah, it's a dynamic registry. Briefly looking at the metadata, it looks a little bit like this. It's also work in progress. It's going to change significantly. The internal table structure, just to give some numbers, there is around 6,700 layers. There's 18,000 images, let's say, blobs, right? Tars, layers. This may look like a big number. It's not that big anyway. We have this big number because we are compiling every extension against every minor version of Postgres to avoid problems. And the thing is that with a few thousand, maybe 100,000 in the future when we have hundreds of extensions, we will be able to generate more number of container images than the atoms in the universe, right? So it's still a good deal. Next steps, and I'm finishing with this, we will provide new layers, new images, new base images very soon. We need to rethink the metadata information, maybe merge it with PGXN 2 efforts, V2. Publish, obviously, this website and the REST API. Dozer will also be published as an open source project. And obviously, we welcome extension authors to join this effort and collaborate, see how this works and integrate. And if you're interested, on Wednesday, as part of the PGConf Dev conference at 5 p.m., me and my colleague, Jotas, we are going to be talking about how we generate those images, which is also quite an innovative mechanism. And if you're interested how we're doing it, then please join us on Wednesday. So, yeah, questions?
Questions. I mean, in the real production world, one of the pain points is when you install extensions, you may have to restart. But some extension does not need to restart. For example, like Postgres, you just install and create extension Postgres. But if you are in a container environment, you create a new image, which essentially means you have to restart the containers, which introduce downtime. You have like a mechanism to resolve this issue.
Yes, that is absolutely right. So there's two ways to work around this. One is to accept this anyway. At some point, and we want to push for that, the component that actually runs the container images in most container environments, which is called the snapshotter, it could be changed to accept dynamically layers on top without having to restart, right? This doesn't work today. It may be in the future, this may be added, right? In the container world, more things are added to be more dynamic. Anyway, most of the extensions that you use today, they typically require adding something to shared preload libraries, which means you need to restart your database anyway. And last but not least, on container environments like Kubernetes 133, now there's the option to, and this is actually what, for example, other Postgres operators are doing, or going to allow, is to use a container image as a volume. And then instead of adding it as the root image, you add it as an additional volume. And this you can add in without restarting the container. So there's work to be there. System might not be perfect for this. But most of the cases, most relevant extensions you need to add, then you will need to restart anyway your database because you need to put them in shared preload libraries. But there's workarounds anyway.
The trade-off for security will still be there in the dynamic.
Yeah, exactly.
Yeah, I'm really curious about that. Dozer, if I understand correctly, you found a way to make OCI layers commute? Or my question is, say the hash of, say you ask for extensions 1 and 2, and the hash of layer 2 is ABC. Will it be the same hash if you pull extensions 2 and 1, and then if you ask for 1, 2, 3, will the second layer still have hash ABC, or will the daemon have to re-pull another extension? I'm really curious about that.
Yeah, it's a very good one. So when we were considering whether this option would be feasible or not, we had to break kind of one misconception or general assumption that most people make, is that we're all told that suddenly like container images are Merkle trees, where the hash of one component depends on the hash of the previous one. And this is not true. If you go to Wikipedia, the first thing will say, this is a Merkle tree. Well, it's essentially not. So one part of the ecosystem of extensions, how the containers are run, it is, but the image, the container images are not. So the hash of a container image is the hash of the manifest. That's it. So if you can wire the layers however you want. If you write the manifest in the same order, for example, it will be the same hash. If you write them in a different order, it will be different hash. But it's not related to the layers themselves.
Awesome, thank you. Another question is about external dependencies. Like some extensions do require other system libraries to work. For example, the PG sodium requires leaf sodium. The PG stable oil require ClamV, and there are lots of extensions. So in such case, extension depending on external OS libraries. So how do you resolve this in a container environment?
Well, easily, conceptually at least. So basically, all the in our view, and what we're doing when packing all these extensions is that, so at the end of the day, the extension is an OCI image, which gets uploaded to the registry. And then the registry combines it with others to generate like the final image. Well, that image contains the extension and all its dependencies. Because they're all materialized on top of the file system, it's an addition. You'll get system libraries in their system libraries path and extension in the extension path. And that's it. It just works.
Alvaro, how are you handling dependency resolution for extensions that depend on other extensions?
It is a non-goal for us as of today. I know, that sounds like the easy answer, right? But that's a reality. It's a complicated problem. We'll probably look into this down the path. For now, we have plenty of things to solve still, and there's no easy answer for this one, so we just skip it for now.
You're also doing, I presume, platform detection, so you can ship on ARM64 if they want.
Yes, yeah, this is multi-platform. So actually, the way multi-architecture work with container images is that there is, on top of the manifest, another manifest. It's essentially an index. And the index distinguishes manifests by architecture. And it's the client who first downloads the index and is like, oh, there's a specific one for my architecture. And then will pull that directly that one. Actually, this is a very powerful mechanism because not only by architecture, you can target very specific CPUs. And we could create for ARM64, ARM9, ARM7, ARM whatever. And the client will pick the image that they want. So you can get very far from it with it.
You and I should talk more about that because I want to do that for Postgres versions as well.
I'm totally in to talk more about that. Well, I would say thank you very much for listening. Thank you.
Monitor 3, is it on? All good? All right. Well, thanks, everyone. Let's continue with this morning. We had a little bit of a delay, but it was only a few minutes. So today I want to talk about Postgres extension upgrades. And some of these insights are from me and some from Regina Albi from Postgres. Unfortunately, she could not join us for the event, but she has recorded her own specific talk about her view of extension upgrades, and it will be available to everybody to see after the event. So we'll see that. And let's just jump right in. Why am I talking about this? So I've built about 30 extensions at OmniGres to turn Postgres into a complete business operating system, or application runtime, if you will. I've contributed before to PGRX, and I'm developing CPPGRESS that I'm going to be talking about later today. And I really try to get people into extensions. This conference is one of those steps that I'm trying to make to get people into using extensions and developing extensions. So the goal of this specific presentation is I want to define the context. What are we talking about first? Then I want to highlight some of the problems that are apparent to me and some other fellow extension developers and operators, and perhaps offer some ideas that we can all continue exploring and figure out better solutions to things. But let's start with a simple thing. What is an extension? Because if you want to upgrade something, you need to know what it is that you're upgrading. So I will actually take audience answers. What is an extension? Can anybody offer a definition or anything, really? Any takers? And it's OK if there's none, but
Something that augments the functionality of something.
So one is something that augments functionality. OK. Any other takers?
Something not in the kernel.
Something not in the kernel. OK. Any more takes? Just for completeness? OK, we're good. I'll start from a slightly different perspective. I'll try to describe them for what they appear, to be. Like, what is their imprint on our work? So what are they on the disk? Like, when we deliver them, we have control files, which essentially contain metadata of that extension. What is it? Where is the SO file can be? What's the description, etc. And we might eventually even add more information to that control file. There's a SQL installation script file, which basically is a program to install the extension, to provision whatever it needs to get provisioned. There are migration script files that take extension from one version to another. And there's possibly an SO file, at least one, if you are supplying a native language extension that is compiled from C or other languages that can't compile native binaries. In the catalog, what is it? So if you have an extension delivered to a system and it's not installed in the database, well, you can still find it in the catalog. So you can see PG available extensions, PG available extension versions. You can see the representation of that extension there. In the catalog, when it's installed, obviously there's a PG extension record that goes in that represents that we have this particular version of the extension installed. Possibly PG namespace record as well. If we had to create a new namespace, perhaps PG proc, PG type, PG class, PG depend, obviously, because every dependency records everything that it installs. So it basically has a massive footprint in the catalog and really can touch just about anything in the catalog because we're creating objects of some sort. Casts, types, whatever, anything. And in the database itself, when it's installed, typically nothing. It typically would not go into your own database and do something there. But the databases that you have, your sort of user-facing databases, they will start dependent on extension objects, such as functions, types, views, whatever it provides. We actually want to use it because most of extensions actually have user interface to them. That is, they can be used somehow. And so the installation path, just for those maybe not aware, is at a high level very simple. We load the control file, both the default and the versioned one. We pre-process and execute the extension version SQL. So basically, this script for provisioning all the objects that it needs. And while doing so, we record dependencies so that we know which objects were produced by this installation script. And an upgrade path is kind of similar, but instead of that one script that we run to provision it, we run potentially a series of migration scripts that take it either from version 1 to version 2, or if you're upgrading, say, from version 1 to version 3, if there is a path from version 1 to version 2 to version 3, it will run them in sequence and, again, record dependencies. So files on the disk, like what's up with them, and what are the problems with these? So installing the multiple package versions of the same extension simultaneously, it would work if none of the files conflict. If they do conflict, you cannot really have multiple versions of the same extension available. So the idea that I've been running a lot into, and I've been practicing for quite some time now, version everything. So you have SO file, version it. You have bitcode, version it. Documentation, even headers, whatever extra you supply, everything gets versioned so that whenever you install a system package with extension in it, you don't want it to conflict with another version of the same extension. And there it gets very interesting. If you package it naively, you would include the default control file in the package as well, but that would create a conflict. So the idea that I came up with some time ago is split every package into two. So one would deliver the version of the extension with all the version files, and it would depend on whatever it needs to depend on. And then there would be essentially a virtual package that only has one file, and that is the default control file. What this allows us to do is to have multiple versions available, and only one version would be default at any moment in time. And there's an interesting caveat to upgrades that we need to account for at all times. PG upgrade expects names to stay intact during this transition. So if you upgrade and change your extension, like SO file, your pgproc entries will not point to the right one. So that will be a little bit of a problem. The reason for that is pgproc points to files, not to extensions. It has no idea of extensions. And maybe it should, but we'll get to that. And here's a very good example of this problem, again, in the upgrade path. So imagine you have an extension version 1, and there's a function bar, and then we release version 2. Nothing has changed in terms of the interface. So it's still the very same function, does whatever it's supposed to do. But let's say the implementation has changed. We fixed a bug or something like that. And if your SO files are versioned, and you look at your code and like, well, the function didn't change. Why do I need to change the signature of the function? You will have a record in pgproc that points to the old SO file, which will not work the way you expect it to work. So if you're developing an extension with this kind of changes, you actually need to refresh every definition of every function just so that pgproc points to the new version of the SO file as opposed to the old one. And that, again, goes back to that statement that pgproc does not know anything about extensions. It just knows where to find the file for C language extensions. Basically this. And the insight that I think we can draw from this is it's important to raise this conversation. If we say that Postgres is an extensible system, but it has parts of it that are very intricately related to extensions and yet know nothing about extensions, maybe we actually need to start looking even at the catalog itself and say maybe we can actually restructure things. We don't have to keep things the way they were, say, for 10 years. We see problems, let's evolve. That's how we develop software. We don't cast it in stone and say that's the blessed way. We need to solve problems. And this leads to actually a bigger, maybe not a problem, but a conversation. Extensions still feel like a little bit of a sidekick to Postgres. So there is this core Postgres that does things in the way it's supposed to do. But it's actually not modular as itself. It just has ways to add stuff sort of on the outer shell of it. or sometimes plugs certain things in some parts. But by itself, you cannot decompose it and reassemble it in a different configuration, replace some modules. So it's still not modulars. And because of that, extensions in this incarnation will always be sort of catching up and always be a sidekick. And this is all still very simplistic. Things do get worse when you have complicated systems. One of the most important, I believe, is that every time you start to use an extension, you create dependencies on that extension. There's one half of them that is not so bad, and that is those that are visible. So you know they depend on these things. And for example, Postgres will prevent you from dropping an extension without doing something about that, because you would have to disconnect and figure out how to do this. And that in itself is a problem, because how do you do that? Like, yeah, you know that there is a dependency, but I do need to replace this. I need to change the type. I need to upgrade the extension, but I can't really do that. It becomes really complicated. But it gets even worse. For example, function code can use another function. For example, that's PGXN. We run this, but this is just a piece of text. It really knows nothing, right? There's no way to do anything about that. And that's still OK, because we can actually at least look at it. There are extensions that help you, check your PGXN code. But what about other languages? But the worser part is remote clients. You can't expect them to know anything. They expect that this will work, but this is always removed from you. It's always somewhere there. They do not declare what they want. They just come with an expectation that this is there. There's no dependency that is declared. And another side of the problem is that you can't install multiple versions of the same extensions in the same database. And this creates a problem that you cannot really move forward if some other extensions, for example, your application depends on extension A, and then extension B depends on extension A. But if your compatibility level is independent of each other, so they need version 1, but you need version 2, there's just nothing you can do about it. You're done. Like, you have to fork it, I guess, for both and do something about it. But different databases can have them as long as the files are there. So basically what it means, it does not allow simultaneous installs in a database, but simultaneous availability is fine. And so what can we do about this? Of course, we know that multi-version would be difficult if it was possible. So for example, if you want to install multiple versions of the same extension, they would probably want the same namespace. Because, well, that's kind of easier, and this is where we're coming from. You would need to add a dependency resolution, and this, general problem of A depends on B, but only in this range, and the other one depends on another range. And of course, the hardest problem, you have state. So you have data, for example, using data types in your extension. And so what do you do when these upgrade? So what can we do about this, and what kind of direction I suggest to discuss? One is nested namespaces. What if it was possible just to say namespace is inside of a different namespace, and we can form virtual env type of setups? It would be interesting to explore what are the pros and what are the cons of that, and does it solve the problem? Or can we follow, say, a programming language approach to this and say, I want explicit imports. This imports that and nothing else. This is what we want. And so we know sort of explicitly what comes into the picture, and would, in this case, actually prevent, for example, the search path injection type of attacks. But those, of course, are fairly large changes to the upstream, not a simple conversation to be had, but nevertheless something interesting to explore. And one thing that I wanted to add here, I found a method that allows me to solve at least a fraction of these problems. The idea is simple. If we understand that installation script is just a script, when we do this script, what we can do, we can essentially define a function that provisions the functionality, the types, whatever you need out of this extension at any moment in time. So for example, you can provide this function and also call it during the install script, or you can leave it to the user. The idea behind this is when the extension will drop, all of this will stay, because if you call the function yourself, those are your objects. Those do not belong to an extension. Now, if you go back, again, you can see that there's a schema parameter to that function. So that means you can install your extension into multiple schemas, differently named schemas, so extension A version 1, extension A version 2 at the same time. And they will point to their own functions. They will have their own types. So you can start forming this multi-versioning approach without having any changes to core. And the other thing that is very interesting, besides obviously the multi-version capability itself, you can actually change what is being delivered by this installation function. That is, imagine you wanted to choose a type for a certain table, like what kind of precision I want to put in this table. So instead of int4, I actually want int8. Because right now, the only way to do this is set a config parameter to something so that install script picks it up and decides what to do. But with the function, you can just tell, I want this type to be used for this column. And essentially, it's like C++ template. So you're without the C++ parts, where you instantiate a particular template, and you can change certain things that are pre-configured by default, but you want to change that to something, so you can. And there are interesting challenges with this method, of course, as well. For example, how do these extensions record their own installations? How can we make it uniform so we know we can basically extract the whole list of all instantiations of all independent extensions, and so that they don't use different methods? So these challenges are to be solved. And how do you make it possible for extensions discover each other and essentially adapt to existence of each other? So for example, if you have one extension and that it sees, for example, an HTTP server extension is available, now I can provision a function automatically that will provide you functionality to connect some part of this application to HTTP API, and basically deprovision it when it goes away. It's challenges and conversations to be had about this method, how to implement this in a scalable fashion. I think we're now on time. So that's it. I'll take questions. We still have 5 minutes.
Okay. So about the second namespace, they do not want it. I asked for so many times. By the way, no pig. I was trying to do for the past 5 years, and then I gave up packages because we so needed. And I have like a way to artificially create packages, but basically the biggest no because package creates extra level of namespace and are not ready. So as much as I would love it, again I tried. I think that I don't know, unless we will just all of us corner the core team here, that most of them will be yes. But I mean, I hear your pain. Lots of extensions actually allow they are not bounded with a specific namespace. You can install them in arbitrary namespace. But then, yes, comes the challenge how they record, how Postgres records them, because it's the same like Postgres catalog and it's just one place. So that's why, by the way, none of my things are packaged as extension, because I do not want to appear in the catalog. Even like PG by temporal is called extension in Postgres wikis I found recently, but it's not actually, it's not extension, because otherwise we have all these complications. So I think that it's something we would like strive for, but that beyond us, I think, because again, it's lots of things which how currently Postgres catalog is organized. So the other thing is users discipline, because having more than one version of extension requires actually people knowing what they are doing, and they do not like knowing what they are doing. I mean, as much as I would love to have it for myself, again, me being a person working in a company where we have close to 400 production Postgreses, I do not have trust, but like again, happy to support all these initiatives. Tell me who they are.
No, 100%, and in fact, all the new extensions I'm developing are effectively not extensions either. They are packaged as extensions to be delivered, But after that, there are functions that provision whatever you need. So I 100% agree with you. And I think this is part of what I want to achieve is I want us extensions developers to have a bigger voice in the community. And so, this talk is the reason why I'm here. I want people to see where we agree on things and where we're missing things in Postgres, create that voice, and go and work with the core team to actually get stuff done. So that's the expectation. Any other questions or comments?
We could very quickly end up recreating apt or yum or whatever. Yeah. Where is enough? How far down that road do you think we need to go? Because we know what that looks like. We know what package managers, good ones and bad ones, for Python or whatever, look like. What's the smallest next step that's actually useful?
Great question. So what's the smallest next step that can be useful in improving extensions? I think, first of all, we need to separate at least two problems here. One is extension delivery. That is how we get them to be available. And the second one, how do they, let's say, manifest themselves in the database, right? So how they get provisioned in the database, how they get upgraded, how they coexist. Those are two different directions. They may intersect somewhere, but they're generally two different problems. And so reproduction of package management, and repeating basically their findings and mistakes is a very good concern. And in fact, that's the problem that I'm still trying to solve with another project that I have, Postgres PM, where I say, let's not invent a new package manager. We just need to generate packages for whatever people need. Do they need RPMs? Great. Do they need debs? Great. It's not an easy problem, but it's a big chunk of a problem. The problem that I'm more focused about is basically, how do we get this functionality into Postgres that helps us get functionality that is different from today? And so the minimal step that I would say is actually doing something like those instantiable extensions. They have the capabilities that are technically not available today. And so this is the small step. Let's try it out and see how far we can go with it. And we can learn from that and present something, say, next year to the core team. So I would suggest that. Yeah.
Am I okay? Cool. All right. Hey, everyone. I'm Phil. Glad to see a lot of you here, many of you for the first time. In person, I mean. I joined Enterprise DB last year, last January. Been here about a year and a half. I work on a product called Postgres Distributed, which is multi-master logical replication. And I'm super new to Postgres, which is a positive thing in some ways because it's a new perspective, and it's also negative, and you can call me out when I've completely lied. Hopefully I haven't. And this talk is going to be about some very basic stuff, but it's stuff that I run into a lot and that isn't often documented, so I think it might actually be useful. We're going to start off talking about memory management in Postgres and C in general. We're going to talk about memory leaks, what they are, and then we're going to create our own memory leak, and we're going to look at some different tools and see if we can find that memory leak. All right, so memory management. In C and in Postgres, we get malloc and free, which are very minimal. They're a good building block. You have to always remember to free. We'll talk about why. But more complex projects in C tend to have custom allocation strategies, such as the BOEM-GC, or Python has reference counting implementation where you have to manually call increment and decrement. You don't ever have to call free. When the reference count gets to 0, CPython can decide to free it for you. And in Postgres, we have memory context. Memory contexts are a nesting arena allocator. We'll talk about what nesting and arena means in this slide, where you, instead of calling malloc, you will call palloc to allocate within a memory context, and you'll call pfree to free that memory. The memory context can have child memory contexts, and you can free the memory for a memory context all at once. This is what makes it an arena allocator. Being able to free all of it at once, having children makes it nesting. And this kind of makes pfree optional, unlike with malloc. So these memory contexts form a tree. You've got these built-in ones like top memory context, top transaction context. And then maybe in my extension, I wanted some new contexts for myself. So I added this my plugin context on the left. That's going to be a child of the top memory context. And then also this my function context might be some other context that I've created. So we call palloc, and that is going to allocate memory inside of the current memory context. Current memory context just points to whatever the current memory context is. And we can switch between them from, so before we were in top memory context, then we're in top transaction context. All of this stuff is very basic, but it also took me a little while to get used to it when I was first starting, so I'm illustrating it here. Again, when we palloc, it's going to allocate inside of whatever current memory context we're in. So before there was nothing, and now we've got this little obj allocated inside of top transaction context. And then when we go to reset, it's going to free all the memory inside of that context and all child contexts. Memory context itself is kind of interesting because it is more of an abstract base class. And I guess the idea was that while you can always swap out malloc implementations themselves, which we will talk about, you can also implement new types of memory contexts inside of Postgres. So the default one you are probably using is alloc set context. But there are also a couple of others that you can pick from, like bump context, for example. What that one does is the free is a no-op. So when you do pfree, it just does nothing. So it is quite interesting that we have this memory context, and it's super useful because you can allocate all this memory and not need to worry about freeing it because you can just reset the entire arena at once. But you don't have to use it. And Postgres extension code and Postgres itself may still call malloc and free. Similarly, if you want interesting data structures, they have to be palloc aware if you want to be able to reset all that memory that you allocated during creating and querying that data structure. So in Postgres, we have some nice ones like list and psprintf for formatting a string, or string info data for building up a string. But if you want to use a third-party library that has a third-party data structure, it probably is not palloc aware. And at EDB, we have a bunch of like Rust extensions, and Rust has a great standard library with like a generic B tree, which is really cool. But if you use it, then you're not part of this memory context ecosystem. Interestingly, Rust is making it optional in the standard library for you to pass an allocator to the data structure. So maybe in the future, we'll have a nicer interaction between Postgres memory contexts and Rust standard library data structures. But for now, not really. Another interesting consideration with memory context is which one do you use? If you call palloc inside of top memory context, the top memory context gets created at the beginning of the process and will not get reset until the end of the process. It is effectively the same thing as calling malloc. If you don't free, it won't get freed until the end of the process. And another consideration is why, if we can just reset the entire memory context, why do we even call pfree ever at all? All right, so let's look at some examples of use. Here we have this iterator that we want to like run this process_data function for every item in the to be iterated over. And memory context we might decide to create one that will get reset after every single iteration. So this is just really convenient for process_data because it can call palloc as many times as it wants. It can do whatever it wants, but it will get cleaned up as soon as that iteration is done. And like if it needed to allocate memory that needed to live longer than that, it might switch into another memory context, but it will switch back before it finishes, before it returns. Another example use of memory context that I really like, I don't see it as often, is where you might want to do a bunch of allocations in a single function. For example, you might want to read a file and then build up a query string and then execute that query. You don't need the result of that memory. You just needed to do a bunch of allocations, and then at the end, you are totally fine to free everything. And memory contexts give you a really convenient way of like, just here's the memory context for this specific function. We're going to p-allocate all we want, and at the very end, we'll just call reset, and that's it. All right. So one of the things that can go wrong with these memory contexts is that we might lose track of memory that we allocated. And this, I think, is a much broader version, like definition of memory leak than what a lot of people use, but I think that it is appropriate. This might lead to both inefficient program behavior on our own. It might lead to out of memory, the Linux out of memory killer, killing processes. It doesn't really matter so much for short-lived processes or functions, because if it's short-lived, at the end of the life of the process, the operating system will just have that memory be available to it again. But when we're talking about servers that live for a long time, if they keep on allocating and they don't free, that's when it becomes a problem. And this just happens to be a really common source of incidents on my team. So interestingly, I don't think that memory leaks are even restricted to dynamic memory allocation. If you are doing static memory allocation, for example, to have some like fixed pool of objects, you need to track the usage of that pool. And if you are ever incorrectly tracking that usage of like how many nodes in the pool are still available for you to use, that is kind of like a memory leak. So I'm just going to refer to anything that is not effectively reusing your memory or giving it back as a type of leak. And the interesting thing about the static allocated memory leaks is that you can't debug them very easily, because like when you do dynamic allocation, you keep on asking the operating system for more memory. Even top will tell you that that is happening. But if it's in a static, like if you're doing a static pool of objects, you can have these same bugs, but nothing will tell you about it unless you build that in yourself. So just to make that concrete again, here's a little example. Like if we're going to parse a string at the very bottom, parse AST, we're going to parse a string into an abstract syntax tree. If we wanted to do this statically allocated for some reason, we might have this pool of AST nodes, and we would keep track of free underscore nodes, how many left are available. And if we ever keep track incorrectly of free nodes, that is kind of like a memory leak. All right. That's just interesting side note about static allocation and memory leaks. So let's look at some examples in Postgres code, or what might look like Postgres code. If we ever conditionally free and we miss a path, that's going to be a really common case of memory leaks. Another one is if we are using a wildly inappropriate context like allocating inside of top memory context I already mentioned. That's very similar to calling malloc if you do not free. And then maybe we even were smarter and we made our own memory context, but it's still too large and we're going to allocate too much, and this context goes on for too long before getting reset. Even that is a common source of a memory leak. So how do we find them? One of the first things to remember about memory leaks is that they are going to be some specific path through your program. It's a function of the workload. And if you cannot reproduce that workload, it's going to be difficult for you to reproduce that leak. Moreover, the easy ones are going to be where you're leaking a lot of memory and you're doing it a lot of the time, whereas, and some of the ones that we get in production at EB are like over the course of weeks, the memory seemed to have like slightly gone up. Those are much more difficult to debug. All right, so to demonstrate some of the tools that we have available for us for finding memory leaks, we're going to write a leaky extension. In this code, we create a new SQL function that sums two numbers, but we're doing it really badly. We are going to allocate for we're going to allocate an integer to store the result of summing those two integers, and we're going to do that in the top memory context. This is pointless, but it can illustrate really easily a memory leak. And then to trigger this, we're going to create a table with 100 million rows, and we're going to call that leak sum on every row in the table. So we're just going to be leaking a lot of memory. And when we talk about the tools, some things to keep in mind, all of them are going to require debug symbols, which if you are using Postgres in production, you're probably used to this, but I still find it really painful, like trying to recreate some of the stuff for this talk on Debian. Like finding how to get the debug symbols on Debian is not convenient. It's basically easier to build from source, for me anyway. A lot of these tools are going to be Linux only. Some of them only work well with hardware performance counters, so it will be difficult if you are in a VM or a cloud provider. And many of them don't work well on Mac ARMs, even if you're in a Linux VM. All right, so what are the tools that we have available? First, we have built into Postgres memory context stats. We'll talk more about this. We have part of the BPF tool suite, memleak. There's another third-party tool called HeapTrack. And I alluded earlier on that just like we have these memory context implementations, we could also swap out malloc implementations. And some of them come with really sophisticated heap profiling tools. So we will look at that. And I'm not going to cover Valgrind tools, because even the Valgrind manual page, I think, says Valgrind is like 20 to 100 times slower than normal execution, which is too slow for me. Perf. This tends to require hardware performance counters, which means you definitely can't use it on a VM. And also, I think it's going to be good only if we're tracking like tons of allocations, but not tons of allocations that have not been freed. And Adder Sanitizer sounds really promising, but I have never gotten. It's a built-in tool for Clang and GCC these days, and it will tell us about leaks, but I have never had it work well with Postgres. So if anyone has, I would like to talk to you about that. And even if you haven't, but you're interested in getting it to work, I'd be curious to talk still. And lastly, there are even more malloc implementations. The one that I'm going to show you in this talk is JE-malloc, which is one that Facebook uses. But the MI-malloc from Microsoft and the TC-malloc from Google also have these built-in heap profiling tools. And they look promising, but I did not have time to go look at them. So first, we have this Postgres native method for showing allocations by the memory context. It dumps a kind of human-readable string to standard error. You can hard code calls to this in your C code, but in like our support guides, we typically tell people to like go into GDB and call this from GDB. So here, for example, is one of our scripts where we GDB attach to a process, and the important line is number 6, we call memory context stats. And that will dump to standard error. This is why I say it's kind of human readable. It's kind of not human readable too, because like it's not very formatted. At the very top, you have top memory contexts, how much memory has been allocated entirely there, and then for each child memory context, how much memory has been allocated. And again, this goes to standard error. So for Postgres, that will typically mean it'll end up in some log file if you're not running it in the foreground. And the way that you debug with this is that you just repeatedly call that function, and you repeatedly get that like this output. And you basically look for changes in allocations by memory context, which is pretty difficult because that's just difficult to read in the first place. And it also won't work very well if you don't have a bunch of fine-grained memory context to see like if this particular memory context had a lot of memory growth recently. That would tell you you could go look in code that referenced that memory context to look for P allocations. But if you're not using tons of memory contexts, like very fine-grained, then it's not going to help you very much. Or it's also not going to help you if the memory context is too large. Like if all the allocations happen in a top memory context, then you know that, OK, there is a leak somewhere in your entire program. Yay. The positive side of it, though, is that it's not very invasive. And this is why like at EDB, all of our default guides for memory leaks start with this. But I find it super painful. I do not enjoy it. And if I can recreate the like workflow that led to this memory leak, then I would prefer to do anything but this. So One of the first tools that I started looking at when I first got these bugs was this memleak from the BPF tool suite. It's part of eBPF, so this kind of requires more recent kernels. But it does work in Linux VMs on Mac, which is great. And they have this particular tool called memleak.py, which just looks at every allocation and every free and will tell you what the biggest allocations that have not been freed by stack trace are. So the way that we debug it once we have it installed is we start a Postgres session, Postgres client session. We grab the backend PID. We call memleak, we call memleak, and we attach to that PID for the Postgres backend. And we trigger our workload. And this is why memleak is my favorite, because it will start printing immediately all outstanding allocations. You don't need to wait for the program to finish. All the other tools actually do require, that I looked at anyway, all the other tools do require you to wait for it to finish. And we're going to get this, which it keeps printing out all these top outstanding allocations, and the very biggest one is actually the one that we introduced, where we've got this pgleak_sum. So that is incredibly useful. That just told us exactly the function where this leak was. It didn't give us the line number, so that could be an improvement. But yeah, that is pretty useful. I'm very happy with memleak. And I've been using that for like a year now, and I've written a couple blogs on the EDB blog about using it. Another one that I looked at just for this talk was heap track, which some folks on the Postgres mailing list have suggested. It also works in Linux VMs on Mac, which is great. Similar to memleak, we start a Postgres client session, grab the backend PID, and tell heap track to attach to that client backend. We trigger the workload, and this time we do need to end that process, end the backend process. And then the heap track has this tool called heap track print, and they have this option called print leaks. And once we get the output of this, and we just search for the string memory leaks inside of here, it also will tell us exactly where this leak was, even down to the line number, which is even better than memleak. So I am super happy with this. This version of this output is on a bare metal Linux machine, and this version is on a Linux VM on my Mac. This did not include the line number. I don't know why, but it just goes to show, like, you might have different experience on different environments. Yeah, so that is awesome. Just to give us the exact line number where this leak was happening was great. And the last tool that I started looking at was JE-malloc. So this is an alternative malloc implementation used by FreeBSD and Facebook. Like TC-malloc and MI-malloc, it has built-in tools for heap profiling. We just set the LD preload environment variable with the path of the library, and we set up this malloc-conf to just say we want to look for leaks. And we run Postgres, the server, with this on. Again, we're going to start a Postgres client. We're going to trigger the workload. We're going to exit it. And then we run this JE-prof tool that comes built in with JE-malloc. And this tool is not super easy to use. There are not a lot of docs for it. But just after playing around with it for a while, I did get it to show me something that looked like it might possibly be this stack trace. Because like exec simple query, that sounds reasonable. It was a palloc inside of a query. This was as good as it got. So yeah, I'm not a huge fan of this. But I don't know. It was interesting. I still would like to try MI-malloc and TC-malloc out. They might do a better job here. All right, so summarizing, these memory contexts make memory management pretty easy. You need to make sure that you're using a reasonable one, if not the right one. At a minimum, you probably want to be comfortable triggering these memory context stats so that you can manually and visually figure out which memory context might be the problem. Or if you can reproduce the workload, you can use these tools like heap track and memleak that much more quickly can point you like at the line where they're happening. In the future, I would like to check out MI-malloc and TC-malloc. I'm also curious at this point, like I have been complaining about memory context stats, so we could probably just make it better, like integer formatting or formatting the bytes as like megabytes, gigabytes. That might be more useful. And if we can do this in third-party libraries and third-party tools, I suspect that we can also just do this in Postgres itself. So that would be another interesting direction. And that's it. Thank you.
Yes, I have a question. I was wondering, are you recommending managing memory separately in private objects, or is it better to do it globally? I imagine the answer, the proper answer, if it's done correctly, is that it depends on the kernel. What is your recommendation?
The main recommendations I would have right now from this would be you probably want to make more judicious use of custom memory contexts that will help you figure out in which memory context you're leaking. And separately, also, if you can reproduce these workloads locally outside of customer environments, it's probably going to be easier to debug the memory leaks with heap track and memleak rather than just memory context stats. Those are my two main recommendations.
I was thinking perhaps for private objects, you might just statically allocate.
You can. Yeah, you can.
I see. Because that's where you have much less risk of memory overflows in the private classes and objects compared to globally.
Although, as I mentioned, I think that there are tools that will tell you about leaks in dynamic allocation, and you have to build those tools entirely for yourself if you're doing static allocation.
Thank you.
Cool. Thank you very much.
Hello, everyone. I'm Sweta Vooda, and I'm a master's student at Georgia Tech. I like learning about databases, and one of the reasons why I'm here today. So as part of my presentation today, I'm going to talk about Postgres, not just as a database, but as a powerful control plane that can orchestrate and extend to use external services and offload the compute. And so understand about this pattern from one of my small POC project that I worked at my lab called PG Vector Remote to offload the vector store index to Pinecone. So as part of the agenda today, just start off with having a bigger picture of the different extensions and think about new categorization of the Postgres extensions, that is data plane versus control plane, and understand why offloading compute can be a benefit for developers and users. And then talk about my project that I worked on, PG Vector Remote, as a case study and some of the learnings and challenges that I faced while building this that can be helpful to develop new extensions in following similar patterns. And the goal here is to learn from these patterns and be able to build extensions in just days, which took us months. So the bigger picture here is understanding that Postgres is super helpful. It's not just now a data store, but it is evolving into a huge platform to build more extensions and a database just on top of the database system. And one of the reasons here is because of its extreme extensibility. And this extensibility is coming from the ease of being able to create new types, functions, indexes, and background workers. And it's super easy that you can now just hack in, create new extensions very easily. And now when I see this big picture of all the extensions, I was able to categorize them into two major categories. One is the data plane, where all the extensions are generally adding new indexes. They're working on the data plane, that is to create how things are indexed, how things are processed, queried, and run, which is internal. For example, PG Vector, it created a new index type to do ANN search, versus control plane is when we think about Postgres using external services to orchestrate and maintain consistency and use those external services to do some parts of the compute. For example, is ZomboDB that uses Elasticsearch for the text search, and PG Vector Remote is the project I worked on that offloads the vector search to Pinecone, and we see this pattern. So patterns and patterns help us distinguish this and guide us to make design decisions, and that is why it is important to be able to divide and understand how different extensions are different from each other. And for example of control plane extensions here, you can see all the foreign data wrappers use external services, and Elasticsearch in the full text search space is using, ZomboDB is using Elasticsearch, and so in the ML space, we are also using external functions to perform our operations on the data in Postgres. So why offload these extensions? Why is this important? It is so much easier as a developer to just use SQL instead of having multiple services and have the pain of actually maintaining and keeping both of them synchronized. And it is much faster, it's easier, and everything is inside Postgres, and all the consistency is followed, and it guarantees all the ACID rules. So this opens up endless possibilities where we can use the specialized engines in the market now and integrate it in Postgres to build new extensions. Moving on to my case study of the project we worked in our lab. PG Vector Remote was a simple fork of PG Vector. What we wanted to do here is we created a new index access method that buffers the entries, buffers the data that we get, and it ships the embeddings into Pinecone instead of the PG Vector internally. And all the computation, all the index is all run on Pinecone, which is an external service. But why is this useful, and what is the problem that we are trying to solve? PG Vector is super useful. A lot of people are using it, mainly because of the SQL interface. But there have been other cases where I observed a lot of people are still using the external services such as Pinecone because of some performance enhancements or other reasons that the other services are better than PG Vector. So for that, the application developers have to struggle in maintaining the synchronization between the data store and the Pinecone or the external service here. And what PG Vector Remote does is it solves this problem, provides the user an SQL interface, and all the synchronization is handled within the extension itself to talk to Pinecone, send the information to the external service, retrieve it, and return the results to the users. So using it is as easy as just create an index and say using Pinecone, which is our new index, on a particular column such as embedding. And what happens whenever we insert data or update is these, let's call embedding as a vectors. These vectors are buffered in memory, and we flush them asynchronously to the external service that is Pinecone. So when we are flushing it externally, we are basically storing this data in the external service. And whenever there is a select query and you want to retrieve some results, we are querying on Pinecone to get these results, as well as the local buffer, because there is an asynchronous flush. We are doing a scan of both and merging the results to return the top K results for the vector search, and that is the final output. So this matters because it is so much easier now for the developers to use Pinecone but still have a SQL-like interface, which is so simple. And this design actually validates that power of Postgres hooks for offloading the compute to other services. Now it can be, it may not be a vector service, but it can be a different type of extension, and we are using a specialized service to offload the compute. So there are a lot of categories in this as well. We discussed here, which is creating a new index access method. We saw foreign data wrappers. There are like other executor hooks that get the information from the columns and then push it to external services for some computation or mathematical ML-related functions, and a lot of background workers. So the pattern here we are discussing is about the index access method, and some example extensions here are PG Vector Remote and ZomboDB that we will be talking about. So while developing this extension, we faced a few challenges, and putting it all in all, it was these four main challenges that kept recurring, and solving this, I feel like, is a pillar to create any similar extension. So I will be discussing about each of these challenges and understand why this is a problem and how it is resolved in the current industry. Challenge one is buffering and back pressure. Now, because we are maintaining two services and we have to send some data from Postgres to an external service, it is important to understand how to send this information. Because sending one row at a time is going to be very expensive because we are making external calls, API calls. And having, let's say, unbounded buffers can also cause issues with out of memory or stalls. So how this is done in these services is ZomboDB has local buffer, JSON buffer of around 8 MB, and it basically stores all the data in the buffer and flushes it whenever there is commit and or whenever it reaches the size, full size. So it does an external call to Elasticsearch. And whereas pgvector remote, the flush is based on the batch size and timeout. So it's like a hybrid which says whether if this much time has exceeded, flush it, or if this much buffer space is being used, flush it. So some of the key takeaways from this was batch early and also make these thresholds configurable. As suggested, you can batch in different ways. We can have size-based batching or time-based batching, but both of them come with their own trade-offs. So what you're supposed to do here is obviously have a hybrid trigger, and which comes with a complexity. And therefore, it is super important to expose all of these configurations to the users so they can take their own decisions and configure how much, what values they want to input for such batching strategies. And also ensure circuit breakers and rate limiters as resilience patterns so that in case the external service is not responding well, we have methods to recover this and run it in the background later. Next challenge is with predicate pushdown. So this is a very unique thing, a way we can actually improve the performance of services by integrating it with external services, because at query time, if we pull all the rows from the external service, it can be very costly. It can take a lot of time and memory. And also, if we are making any mistakes in the filtering, we are returning wrong results. So how this is done in pgvector remote is that whenever we are creating a new index, we can use, like, we can give metadata. So the first, when we say using pinecone, the first value is the vector column that is embedding, and the remaining ones are the metadata that we also store in pinecone. And whenever we are running a select query to retrieve results, at wherever there is a condition, let's say price is less than 50, we are pushing this filter also to pinecone so that we fetch only the embeddings that are less than 50. The price column is less than 50. So we are already reducing the amount of data we are retrieving by pushing this into pinecone instead of waiting and doing it after we retrieve all the results from pinecone, which is not possible in pgvector, because as an index internally in pgvector, it pulls all the results and then it applies the filters. So this performs much faster and better because of the predicate pushdown. So how extensions generally solve this is they create basic API filters. So also depends on whether the external service is compatible enough to and has all these API filters available. And it is very important to translate properly, because the semantics of SQL can be different from the semantics of the external service. So testing here is the key. Testing is super important, and always have a fallback strategy in case a specific filter is not available externally, so that it is done in Postgres after we retrieve the results. The next challenge we faced was connection management. Because we are connecting to an external service, it is important to be very careful about how many connections we open, how we do it, because that can cause latencies. And this is something that we overlooked when we were developing, and once we resolved it, once we had like connection pools and we configured the size and timeouts, we were able to reduce the time from like 100 ms to like single digit numbers. So that was a very big learning for us, and also having health checks and back-off strategies in case the client is having some issues, remote service having some issues. So all of this is important, and always any configuration, expose it to the users so that they are able to monitor and make those changes. So all these are some design takeaways from the connection management. Next, we saw about, we saw how to buffer, we saw about predicate push down when we have to retrieve results, but what exactly do we buffer? Do we want to send all the data, all the rows and columns into the external service, or do we want to send only little or few rows? And what metadata should we use? So all this is very important, especially because Postgres has, we must preserve ACID guarantees and MVCC to remove the dead rows. This is very important. And the goal here is to send quickly, make it lightweight, but also have the important metadata. So how ZomboDB does that is they have a full row JSON. They send the whole row to the external service, and they also have these fields for MVCC such as the xmin and xmax to ensure the transaction is also recorded and it is sent to the Elasticsearch. This simplifies the query time merging, but also it has like a memory cost because you're sending a lot of information. And in PG vector, we send only the vector, primary key, and any metadata. As you saw, like the filters that we were using other columns. So this reduces the data sent, but then you'll have extra heap lookups whenever it is required. So it is a trade-off, and based on what the use case is, how your system works, you need to ensure that enough information is sent, but always including MVCC tags for visibility and the primary key to fetch or delete things later is very important. With that comes consistency and cleanup, which is a very difficult challenge because maintaining two services is difficult with how Postgres does the cleanup. So during commit, always recommended to defer the writes and deletes using the register exact callback so that only successful commits are pushed to the external service, and also embedding the xmin and xmax so that these rows have the information about the commit timestamp, and we are not retrieving some stale information and returning it to the user. And also during vacuum integration, ensuring that on a deletion, whenever the vacuuming is triggered, the external service also deletes these rows is very important, and having a function to do that is something very useful. And also from the observability, having all of these metrics available, having a reindex to rebuild after crashes, and all of that is helpful to understand how the cleanup and how everything is happening. So all in all, the short blueprint for building any similar extensions, if there is a specialized engine and you want to integrate in Postgres, is to understand how to buffer and flush this data, what goes in the buffer, that is the payload, and also what are the filters that the external service has and how we can utilize that to safely push the predicates and filters down. And then how to manage the connection with the external service and when to do it. And finally, maintaining the consistency between these two services. So if we are able to address these challenges, it is very easy for us to integrate any external service into Postgres and create new extensions. So the key takeaways and learnings from here is that Postgres can be treated using extensions not just as a database, but now as a control plane. And we can build these extensions in real time, have ACID compliant systems to tap into external services that are very specialized and utilize it in Postgres. And learning from these patterns shown, it can help in developing these very efficiently. And this is just, I think, the beginning. There is more scope. I think there are a lot of other extensions coming up in the areas of GPU compute, encrypted indexes, graph search, and more. And we can easily tap into all of these categories as well, following this similar design and approach. So that's all about extensions and offloading compute and Postgres as a control plane. Thank you. If you have any questions or feedback here.
Congratulations.
Thank you.
Very good talk and very
Thank you.
interesting topic. I have a question. I'm not sure if I understood it correctly, but what I understand is that once you perform a write operation to the index, I'm thinking of write operations, right?
Mm-hmm.
It is sent asynchronously to pinecone.
Right now, it's sent asynchronously. Okay. It is not sent immediately. We buffer it, and we send it after a short period of interval, or if the buffer reaches a certain size limit.
Yeah, exactly.
Yeah.
So then, how is actually back pressure exercised? Because the write has happened already. What if the buffer is full or pinecone is not responding?
Yeah.
How is user visible, the back pressure?
Yeah, so here we try to utilize PG vector to do a local scan in case pinecone is not responding, or in case there is some amount of data left in the buffer that has not been sent to pinecone yet. We do a double scan, that is, we scan the buffer as well as we get results from pinecone, and we merge the results. But it may not work for all extensions. So in that case, back pressure comes into picture, where we have to send the data to the external service after every commit, or even before retrieving or having a select query.
Yeah, because I'm thinking particularly of writes. So I insert a new record.
Yeah.
Right? And pinecone is not responding.
Yeah.
But the transaction has committed successfully, right? Let's say the buffer
yes.
is full, or buffer is full, and pinecone is not responding.
Yes.
So my transaction will get committed successfully.
Mm-hmm.
And if so, how do I see the back pressure?
Yeah, so at least in PG vector remote, I don't see this as a problem because we are using PG vector as a fallback. But other services will have back pressure because we have to ensure that the data is sent to the external service on a commit. So only after that is successful, we commit.
Okay. So
yeah.
So for me to understand it completely, so in your case, it will be just stored locally.
Yes. Yes.
Okay.
Yes.
And is it possible to maybe exercise this back pressure at the time of commit so that commit will block? I'm not saying this is desirable, but maybe is what
it is possible. It is possible. We just decided not to do it for like performance reasons, but it is definitely possible and would be a more resilient way.
Yeah. Okay. Thank you.
Thank you.
Thank you. You mentioned that you store metadata like CTID, xmin, xmax.
Mm-hmm.
I think it's called. How do you control plane extensions play with other things that might be writing to the underlying data store for MVCC and transaction isolation? Say I write something that has all the metadata, and then there's another system that may write to my database. How do you handle this?
So is the question writing to the external system, like multiple
yes.
multiple systems? Okay, got it. So I think that is based on like how we configure the external system. It is a valid problem if we are using, let's say, pinecone for different reasons, not just for this session or this connection. So that definitely needs to be handled. But how do we do that? Not really sure. It's a really good question, but right now the scope of what we were working on did not go up till there, so we didn't really address that issue. Yeah, that's actually a very good point. I should make note of it. Thank you.
Thank you. That was a very good talk.
Thanks.
Do you have any plans for making it like a two-way connection, so someone who's using Pinecone doesn't really want to be locked into Pinecone and can use this extension to migrate to Postgres?
That can be challenging if they already have data in Pinecone and then they want to migrate to Postgres. That may be a little bit challenging to like set up and ensure that it is first consistent and all the information is there. But it is definitely possible. It's like a migration that they need to do, and after that it should be possible. It right now may not be like as smooth. We don't have all of that set up. Yeah.
My question is, what is the main benefit to use index access method in this case, rather than like using existing FDW for wrappers, or just like wrap a PG.NET, PGHDP, wrap the Pinecone API into HTTP SQL functions? What's the main benefit and trade-off in this case?
Good point. We were focusing more on usability side to be able to use Pinecone as like just an index, like how PG Vector does it. So we were trying to get people who are using PG Vector to be able to move to Pinecone also, maybe if they want to. So the syntactically it is like very easy because it is also an index. That is, I think, one of the reasons why we chose it in the first place, but we didn't think about like the other ways of doing it.
So back to the question about the deferred commits.
Mm-hmm.
You've got, let's say we've got a bulk load operation going.
Yeah.
So there are multiple batches, they're all busy writing out in parallel through your connection pool out to Pinecone. But you only want to, from a consistency management point of view, commit them all at commit time.
Yes.
Is that one of the caveats here, really, that we have to have a downstream, an external engine or offload engine that is capable of the same atomicity? Or do you see an opportunity for a cleanup job?
Yeah, we can do a cleanup job. So all the stale logs, all the stale records and all the records that have not been committed can be cleared out. So I think I'm trying to understand your question. So are you saying, let's say buffer size is X and we are trying to send like 2X amount of data to Pinecone, and that is happening before commit. So we are flushing it and then we commit if the commit fails.
Yeah, if the commit fails.
Yeah, if the commit fails. Yeah, yeah.
Is this then a case for a cleanup, or is there any other way you thought of dealing with that?
Yeah, so right now, because we send the metadata such as the primary ID, the CT ID, so whenever, let's say, a commit fails, but still the information is in Pinecone, inconsistent. And whenever we're retrieving this information, it is still checked across the MVCC timestamps to ensure that it is a valid transaction and if it is successful or not. So if it's not successful, we are not returning the results to the user. But definitely Pinecone will have data that is inconsistent with the Postgres based on the transaction and commit because it failed. So, yeah.
So at the moment you just let the invalid data accumulate.
Yes.
The Pinecone.
Yeah.
Thanks.
baffled here in the sense that I was wondering if there's a threshold where offloading your compute becomes so prohibitively computationally expensive that it's no longer becomes efficient. You know, I'm thinking about how you say a big query and how all the computations can be performed without any control plane, not using integrated control plane and computational database solution. So where, at what is, can you define some sort of threshold? Of course, it's a function. It's a function of the portability of your database and also of latencies. But can you define such a thing? Can Postgres really be used in this way to do, let's say, significant computations that are offloaded? For example, if you want to offload a fraction of your database to a massively parallel environment, is there an application? Thank you.
Yeah, I think we can do it. It's about how we do it. So we can maybe have background writers to ensure that we are balancing the speed and the amount of information transferred between services and use it. Essentially, what we are trying to do is, instead of having two applications and the developer managing both of them, we are trying to have the extension manage it. So I don't, there might be a limit, but at least to what I know so far, I feel it is still possible. So maybe I'm wrong. Not sure. So, but I think it is still possible. Okay, thank you.
that okay? It started. Okay, good afternoon, guys. Today I'm going to talk about the package manager and the software repo for Postgres ecosystem and extensions. Well, my name is Ruohang Feng. I'm a distribution maker. I have been playing with Postgres for 10 years. 10 years ago, I was just a user. And then I become a database administrator. And finally, I become an architect and doing a distribution thing. And what we have achieved is we have collected like 450 extensions out of box. You can just install and enable them all. But it is not something that bound to our distribution. This is actually something that can be shared with the community that can benefit us all, which I'm going to talk in a why, what, how next sequence. So why would we ever need a package manager? Last year, I wrote a blog post. Postgres is eating the database with extensions. We have observed that a significant growth that is leading by pgvector in the past 2 years. And in the past year, what is happening is people are putting DuckDB into Postgres as extensions. We saw like 6 extensions doing so. And last year, I can recall in the PGXN, we have 370 extensions. And today, this year, we have 50 more. It's a 12% YOY increment. Extensions are just booming in the PG ecosystem. So with so many extensions, it comes to mind that Postgres is becoming the Linux of database. And what happened like 20 years ago in Linux ecosystem is people are all using Linux, while the real difference is about distributions. We have Red Hat, Debian, SUSE, Ubuntu. And the definitive distinctions between this Linux distribution is their package manager and the software repo. And maybe in a year or two, we will see a lot of distribution for Postgres emerging. But that is not the only reason why we need a package manager. The real reason is install and using extension are very hard for ordinary users. People may say, why is that hard? If I want a pgvector in my MacBook, just git clone, cd, make install, everything's all set. That is true. But what if you are installing PostGIS? I still remember 10 years ago why comparing PostGIS from source is still a nightmare. And what if these extensions are not even exist in the pgdg YAM or apt repo, like pgsearch, the Elasticsearch alternative extension? It is written in Rust and not gonna happen like they put into pgdg repo. So, and we got more Soviet cases like Supabase. Supabase is really booming like these days. A rumor says that OpenAI are going to acquire it. And then Supabase, it uses a lot of its own extensions like pgGraphQL, pgJSON schema, and the wrappers, which contains dozens of FDW. So if you're requiring users to building these extensions from scratch, it'll be very hard for them to do so. Not only hard for users, but also hard for developers. Let's say if we perform a 4-table scan over the GitHub extension repo, we will figure out most of these extensions only provide tarball. And some providing 1 or 2 RPM, some provide more Debian packages. Well, but if you want to have all the platform covered, this is an example, ParadeDB. There are 1 pgsearch extensions. They got like 44 packages for 1 extensions. Yeah, it is really hard. Not much extension does that. And even if the current infrastructure have limitations. For example, PGXN says we got 422 extensions, and I counted as like 400. And what you can just install from the pgdg repo is around 100. So it's actually 1/3 coverage. Not all that extensions can be accessible to most of the users. And extensions are useless if people cannot just get and use it. So I think that is something we have to address and to solve. By the way, even the extensions in the repo, they have some missing combinations. For example, these extensions does not work on certain PG/OS combinations, and we will have like dozens of these examples. So here's why, and here's what. How do we resolve this issue? Well, I just wrote like a package manager, which is called a pig. Well, it's a standard Longo binary, which is quite simple, just one line and it's installed. And all you need to do is add repo, like pig repo add pig style or pgdg, it's all set, and you can install whatever you want. If you don't have the Postgres kernel installed, you could just pg install pg17 or 18 is not supported. And let's see a real example. So we have pgext. You can list all the like 415 extensions, and you can like scan the extensions you are already installed. You can like status to print the current status in it, and you can pick install like Postgres, and it will install that for you. No matter you are running Debian or Red Hat, it's 7, 8, or 9, or Debian 11, 12, or 1 to 20, 24, 22, it will all set up that for you. But this is for users. We are developers, so I'm not going to talk about a lot of details that are already written in the docs. So essentially, it has extension management capabilities. It can manage repos. It can build extensions on your distributions. Yeah, for example, if you wish to build status or timescale DB from scratch, from a bare VM, this is everything you will need to run to get that done. We could have like pig ext build extension. Let's build status, and it will just do all the things for you. You will get the RPM and Debian in the package in your directories. Sorry. Yeah, but the package manager itself is not important. The real important thing is the software repo behind it. So that is the real magic and real tedious work lies in. We have built a repo for mainstream Linux, and here's some statistics. We have currently like 400 extensions available on Debian and the EL packages. And the different PG major version have different coverage. From now on, the PG15 has the most extensions. 16 and 17, there are like some extensions are still not catching up. But most of the major extensions, important extensions already have all fully covered. Besides, we also have an extension catalog, which is a metadata that categorize all the extensions, like these 400 extensions, into 15 categories. Like we have time-related extensions, geography-related extension, G stuff. We got vector stuff. We got full-text search stuff. We got OLAP, like DuckDB extensions. And some cannot be easily categorized, like OmniGrass. We put it here, Apache AGE, the graph extensions. And there are a lot of like languages, stored procedures, types, utils, administration stuff, observability, and security, foreign data wrapper, or database simulations. They are all categorized into these 16 categories. So if you want to know what extensions can help me, this is something that can be used. We have actually a catalog, which is a route table, which contains all the essential metadata for extension. For example, its version, its RPM version, its package name, RPM, Debian package names, license, URL. Does it has a bin, has a solib, has a control file? Does it know trusted, relocatable, and schemas, dependencies? Everything is already like covered in this one file. It's open source and published. So if you want to build your own repo and extensions, this could help for building a distribution.
So that's a word part. We have an extension repo. We have a package manager. But the most interesting things I want to share with you is how the challenges we have been, and the lessons we learned from it. Well, building extension and maintaining repo is not not a simple thing. For example, combination will explode. It will exploding, like we mentioned this morning in the container stuff. The combination will explode. What factors do we got? Like we got EL, Debian, Ubuntu, if we want coverage all mainstream Linux. And they got like 7 major in the life cycle versions. And it will multiply with the architecture. You got ARM, you got AMD, and maybe S3090 and other architectures. And it has to be multiplied with PG major version. We have 5 major versions in the line. And sometimes API breaks on minor versions, like 71. And with all that combination, so the result is for one extension, on average, we have 135 packages has to be built. So currently, the repo contains like 40K RPM and depths for the 400 extensions. And the second thing we have to deal with is Rust extensions. Rust extensions is just rising in the ecosystem. We have like 28 Rust extensions I have already included. It's like 8%. But even though they're only 8%, but some of them providing very great features like PG search, like PGML, like p-vectorized wrappers. Well, it's literally a lot of good stuff. But the problem with Rust extension is it's too damn slow. I mean, comparing a C extensions usually take 1 second or 10 seconds, but comparing a Rust extensions usually takes 5 minutes. And considering you have to compare 100 extensions, 100 packages for one Rust extensions, it usually takes a whole day or 2 for me to just bump all the Rust extensions. And another tricky thing about Rust extensions is that they are using a framework called PGRX. And PGRX itself has version. Like some extensions are built against the PGRX 12, some are 13, 14. And you cannot just like cause these minor versions to build these Rust extensions, which brings a lot of difficulties here. And another challenge is some extensions are too big, cells are too big. Darren once asked me, why don't you providing like SRPMs? There's a reason. For example, the PG DuckDB and the PG Mooncake, their source code are like 400 megabytes. And with all the combinations, the source code is much bigger than the binary packages. And some extensions, they call them extensions, but they actually are Postgres forks, or they only works on Postgres forks. For example, Bubblefish, they are extensions, but they only works on an AWS patched version of PG kernel. And OrealDB, which is acquired by Supabase, now is only works on a patched version of PG. So to build these extensions, you have to build the patched PG first. That is another challenge. And people are competing for names. I mean, 400 extensions, there are a lot of free names, but people are competing for it. The example is Citus and Hydra. Hydra is a fork of Citus columnar, and they are using the same name, so there's a name conflict. You cannot just install Citus and Hydra simultaneously. That's a conflict. And the name conflict happens between extensions and operating systems. For example, Vector is also a login collector agent. ACL is a package that Debian already taken. gzip, bzip, no mention, they are well-known packages. And we have other challenges. For example, DuckDB. There are 3 extensions that are currently using libDuckDB. Like PG DuckDB, PG Mooncake, and DuckDB FDW. All they want is a libDuckDB, and you only got 1. So who will have it? If you install PG DuckDB and the DuckDB FDW simultaneously, one of them just crashed because it does not have its own version. So that's really challenging. And well, this question has some fix, like PG Mooncake has already yelled and renamed their lib.db to PG Mooncake.db, and DuckDB FDW can just reuse the PG.db's lib.db. But this happens in the extensions ecosystem. And some extensions are just not well maintained. For example, Apache AG, which is a graph extensions. And sadly to hear that the team is like fired and then no longer to maintain these extensions. So I guess 17 is the last version they supported. Hydra, they're moving to PG.db, and Hydra seems to be abandoned. And we have more cases which I wish they could support PostgreSQL 17, but it takes like several months, still no progress at all. And some extensions are just retired. For example, PG vector is good enough, so the sparse vector extension, PG sparse, just we're no longer maintained, just use PG vector, and we got a branch of this case. And some extensions cannot be included in this repo because it is too old. If you see the GitHub Genie log, it's like 10 years ago, and it's just not working on the latest PG version. So that's some challenges we have encountered in the building the repo. So what's next? So in the future now, what do we want to do? Here's something we want to do in the future. First, this extension package manager and the repo is already used by ourselves. And like OmniGrass, Yurii is using this repo to deliver extensions. The Autobase, the Wetbake, is using this repo. By just adding this repo to their distributions, they have 400 extensions available. And I think, well, it saves a lot of time if you don't comparing everything from source. But if you wish to do so, the pig build can still help you to achieve that. The second thing is that we want to build extension against PG folks. We currently have several folks like Bubblefish, right? We have OreoDB, which claims to be 4 times faster than the Oreo vanilla Postgres. We have OpenHaloDB, a kernel which claims to have MySQL capability, wire protocol compatibility. We also have PolarDB, AverySQL, and a lot of PG folks. Well, these folks are good, but they don't have extensions. But what if we already have a package manager can build these extensions for them? They can also share the superpower of the PG ecosystem. And what we want to also do is to make it work for containers. Well, I think that Alvaro has provided a great solution, OCI images, to address this issue. But, I think it's a great thing to support both like Linux and the Docker container world. And finally, Yurii is doing a great thing. It's called PGPM, which the vision is UIL in, RPMs out. Maintaining such a big repo like 250 extensions is tedious work. Each time extension version got bumped, you have to recompile everything. But what if there's something that can automate all this stuff? It's PGPM. And I would be very happy to be the early adopter of this project. And another thing is alignment between EL and Debian. As you can see, the PGDG repo, it has a lot of extensions. EL has a branch of extensions. Debian has a branch of extensions. What we can do is make them aligned. Some extension only works on Debian, some only works on EL, but at least with this supplementary repo, we can make it work on both distros. And finally, I would like to providing some statistics about which extensions are mostly used or downloaded in the future. But since the repo is hosted on Cloudflare, they charge a lot to get CDN logs. So that is something maybe happening in the future. So that is something I want to share with, and I hope that could help you as no matter as an extension user, a distribution maker, or extension author. And finally, it goes to the QA part. Is there any questions or comments?
So does Pigbuild have any solutions for situations where some extensions can only be built with proprietary libraries? I'm thinking about something like Oracle FDW.
Well, currently, these were leveraging on the PGDG. Some extensions are provided by PGDG, like you are using non-free repo of PGDG-RAM. They provide Oracle FDW. So if we look into the simulation category, and we can see the Oracle. Oh, it's a FDW category, Oracle FDW. You can see it's already provided by the PGDG repo. It's covered, but it's not working on ARM64. So this non-free repo are already covered. Another non-free extensions, I think, except Oracle FDW and DB2 FDW is timescale like TSL. They're using a dedicated license, which is the only exceptions in the repo.
All right, this is all great. So one of the things, as I mentioned before, we're doing these containers, but we're also building the images for those containers, which we will be presenting on Wednesday, by the way, if anyone is interested. One of the things we decided to do is to build against all extensions, against every minor version, to avoid API breakage, and to avoid basically having to introduce exceptions. That will multiply.
Yeah.
What you're doing, what your thoughts are.
Exactly. This is actually an important question, and it will fundamentally change the package convention we already established. For example, the major version name is part of the package name in current naming conventions. You got like PG vector /17, but if you are putting minor versions into it, problems are going to happen. Since if you want to upgrade these extensions, well, it's actually not that easy as before. So I think the solution of this problem is that we stick to the old convention. Since what happened in 70.1 is they revert the API change in the minor version. So it's actually a convention that API will not change during minor versions. I think the timescale has rebuilt against the minor version, but the current policy for us is just to rebuild every extensions against the latest minor version. And it saves like 5 times or 10 times space and the extension numbers.
I'm wondering about the metadata you were showing, all that huge table that you say is available, all the work basically that you've been doing, is it all done by hand, like basically just elbow grease?
Yeah, it's done by hand. Yeah, we have a lot of comment on the things we fixed. We marked, we open sourced everything under Apache 2, so you can get all the specs. And some are missing, some are not working on certain combinations. It's all handworks. How many? I only got 2. So, but I'm glad if anyone was interested in joining the extension building things.
I just want to say really quickly that on the minor version issue, there have been 2 developments. Postgres 18 has API guidance in it. It says in general things should be stable between minor versions. There are exceptions, of course. But to that end, there's a Google Summer of Code student I'll be mentoring who is going to develop an API checker for the back branches that will then complain like the build farm does if they break something. So hopefully that'll help improve the situation.
So thanks for listening.
for me? Yes. Yeah, I still had it muted, you know. All right, great to see everybody here. Thanks for having me. I wanted to talk about releasing your extensions on PGXN. So first, a few notes about me. My name is David Wheeler. I am a principal architect at Tembo. And no, do not give me this. I've been using Postgres since 2000. And I've been a contributor and participant in the community since 2008, roughly. Back then, I developed a testing framework, unit testing framework for Postgres called PGTap. I also built, about 13 years ago, a database change management system called Skitch that's reasonably popular. And I also developed, around 2011, the PostgreSQL extension network. So let's talk about PGXN.
Did you crochet that elephant yourself?
No, Mark Huang did that. I spoke at a Postgres user group or something, and he gave it to me. So PGXN, the PostgreSQL extension network, was established in 2011. It is a source code distribution network, so that's in contrast to like Pigsty and Trunk and some of the others. It's for distributing your source code. The idea is that if you have something that extends Postgres or is tooling for Postgres, you can release it there and it becomes findable by the broader community. It provides full text search, nice presentation of documentation, tagging for categorization to help it make it easier for people to find stuff. There's also a command line client by Daniel Verrazzo that you give it a command like install semver, and it will download, compile, and install your extension, assuming you have the compiler toolchain installed. So this is what it looks like as of a few weeks ago. A few years ago, I revamped it so it didn't look like garbage on small devices. And it's been going along very well. I'm grateful to Pej for hosting it on his server in Germany all these years. This is just a quick example of like the top of the documentation for one of the extensions that's there. All of the documentation is indexed by the search engine internally. So today, PGXN has around 422 extensions registered. That's in 398 distributions. Some distributions have more than one extension in them. There are almost 2,500 releases of those extensions by 470-ish users, and there are 2 mirrors. One of the key aspects of the design is that the basic registry is just a bunch of text files, JSON files, that can be, so you can replicate the entire thing via rsync and have a mirror going in no time. However, there's somebody who did all this work on GitHub in a page to list all the known extensions that are publicly available, and there are almost 1,200 of them listed there. So we have 422 or 398, depending on 400-ish. We only got maybe a third of all the known extensions on the system. So it's not enough. One of the original goals was to be the source of record. If you will need an extension for Postgres, you would go to PGXN to look for it and find it there. We didn't solve the install problem, and maybe that was part of the reason it didn't take off as much. But the goal was to make it the place to find stuff. And unfortunately, extensions are distributed everywhere. So I'd like to try to encourage people to actually get all of your extensions on PGXN. These don't just have to be create extensions. They can be hooks, they can be modules, they can be command line clients, like Mark Huang has his PGTop extension on there, or app. I mean, it's completely independent of the database. It just knows how to read the process table for Postgres stuff. So not just extensions, but we want to get all the extensions plus into PGXN. So I'm going to talk about how to release your extension on PGXN. So the first thing you do is you go to manager.pgxn.org and you request an account. And all you have to do is talk about, you give us your email, at least your nickname, and why you want an extension. Now the why field is there for spam pairing purposes. That really has made it so that I don't think to this day anyone has ever got through who didn't belong. So the idea there is you like describe your extensions. Hey, I have this extension I want to release. That's usually sufficient. You have a link in there to GitHub, even better. And we'll get them approved, your account approved post-haste. Oh, good, a screensaver. Now, here's the anatomy of an extension distribution. You have typically like a changes file. You might have your thorough documentation you've written for your extension so that people know how to use it. You've got your PGXX make file or your PGRX cargo.toml or whatever you need in there. You need your extension control file. Traditionally, README, that like we'll usually have instructions for how to build and install an extension. You have your SQL files, and you have your test files, right? If you've written extensions before, most of this should be pretty familiar too. What I didn't cover though was this little guy, this little person. The meta.json file is PGXN metadata. This is the one file you need to release an extension on PGXN. All this other stuff is stuff that we make assumptions about, and PGXN uses this knowledge to try to index stuff, but the one thing that's absolutely necessary is the meta.json. So, like I said, it's an extra file for PGXN. It defines the distribution metadata for your extension, the name, the version, the license, et cetera. And it's used to index the distribution so that people can find it on PGXN. And PGXN converts it into the static API. So when you upload an extension to PGXN, it puts a timestamp on it, it puts your username, adds those fields to the metadata, and then publishes it more or less as is. So the content of the metadata file is pretty simple. It's just a reasonably sized JSON object in which you have, this one is the minimum. So you have what you'd expect, your extension name, its version. You need to have an abstract that says briefly what the extension is, and then author information about who maintains the extension. License information, and it provides here, you say what it is that you're providing, the extension or extensions you are providing, along with their version numbers. And then the meta spec is there for future reference so that PGXN knows what version of the spec it's handling. So if you have that file in there, that's all you need to make a release. Assuming you're using Git, you can run a git archive command to create a zip file. And PGXN uses zip files natively, so if you upload something else, it'll convert it to a zip file. So it's good to just do this by default. And then you just upload it through manager.pgxn.org. That's it, right? Simple. Now, I know what you might be thinking. You might be thinking, that seems like a lot of work. Maybe. Now, that might be you. So let's automate it. A PGXN tools is an OCI image, nay, Docker image, that allows you to package and upload your extension to PGXN. You can use it in your CI/CD pipelines, ideally like on a tag push with the version of your extension. So let's say you're using GitHub. It should work on anything that can support an OCI image for execution, but I'm going to use GitHub workflows here for example. Sorry, I keep hitting the mic. First, you want to put in a couple of secrets into GitHub, your PGXN username and your PGXN password. Or as this slide says, your PGXN password and your PGXN username. PGXN does not yet support like auth tokens, but we'll get there. So the workflow, right? You just want to say, well, when it's on a push for what looks like a semantic version, because PGXN requires semantic versions, Your job is going to use this container, and you are going to set the PGXN username and PGXN password environment variables from the secrets that you put up there, so to keep your password safe. And then there are really just the two steps. There's PGXN bundle, which basically replicates that GitHub git archive command, or if you're not in Git, it'll run zip command. And then you run PGXN release, which uses curl to upload the release. Now, releasing it is as simple as, why do it keep going to screensaver? You are annoying me. Tag your release. You make sure that the version in your tag is the same as the version that is in your meta.json file, and then push it, right? And then voila, you've made a release. Here's a release that was made by Keith Fisk a while ago after I sent him a patch implementing this for PG Partman. So that's just making a package and releasing it on PGXN. There are a couple other things you can do to optimize. One is to, as I said before, write detailed documentation, because PGXN indexes that in a full text index that can make it easier for people to find specific features that you might have implemented. Also, it's just really good to give your users all the information that's there. I've given two competing solutions or two competing extensions. I think people will gravitate towards the one with better documentation. You can write these in Markdown, ASCII doc, restructured text, HTML, POD. It supports a bunch of different formats. Ideally, you have one file per extension in addition to your README. Another thing to do is to use your git attributes file to exclude files from the archive. You don't need your .git directory. You don't need your git attributes file. You don't need your git ignore file. You don't need your GitHub directory to be released on PGXN. So you can use the export ignore command in git attributes to say, hey, ignore, don't include the git ignore file in this file. That will keep the size down too. I've seen releases that include the git directory occasionally, which this shouldn't do, but. And furthermore, you can provide additional metadata, again, to help users to be able to find your extension. So here's a more complete example of the meta.json file that I just made last week based on PostGIS, or a subset of PostGIS. So first of all, in addition to the abstract, you can put in a longer description to tell them people a bit more about it. This is like the couple sentence or paragraph level description of stuff. You can have an array of maintainers listed if there's more than one person who maintains or organization that maintains your extension. If you need to support multiple licenses, as in fact PostGIS does, you can list multiples in an array. If you provide more than one extension, I think PostGIS has like 5 of them. Each one is just a key with the name of the extension, with an object that has the abstract for that extension's version, the file, which is like the main file for the extension. PGXN doesn't actually do anything with that, but it does require it. And if you wrote a documentation file for that extension, put in the path to that documentation file. And that way, PGXN will list the extensions in your package and say, here's the docs for this one, this one, this one. You can specify dependencies, including PostgreSQL itself, stuff that's internal to Postgres, and other extensions. Here is saying we recommend using PGTap for testing. Ads, why are you messaging me right now? And runtime requires Postgres 12 in this example. It also supports configure, build, and develop steps in addition to runtime and test. You can put in a list of resources. This is really important so people know where to go to file the bug reports, to get more information, to get the workarounds when it doesn't compile yet on Postgres 18, all that. And then you can put in a list of tags that, again, can be used to index it. You'll notice that on the screenshot I had of the site, homepage is a tag cloud because I'm that old. That's where this will play in, just for help people find stuff. Okay, so that is what makes a really good release of an extension on PGXN, or all those steps. But in addition to that, you can do continuous integration testing with the PGXN tools OCI image. So it uses the Debian PGDG packaging system. So it supports Postgres going all the way back to 8.2, all the way up to 18, because Christoph is just that much of an animal. It includes support for doing builds with PGXS, which is the usual makefile situation for extensions with Postgres. Also configure, make, and make install. And PGRX support I added in the last year. So the idea here is you build another workflow in your CI/CD pipeline. Here I'm going to use GitHub workflow. Again, you just say, this is the container I'm going to use, the PGXN tools container. And then in your matrix, you list all the versions of Postgres that you claim to support for your extension. And then use them to give your workflow a name, and then tell it to use PG start command inside the container to tell it which version to start, and it'll start that version of Postgres in the image. And then you run PGX build test to run the PGXS test suite, PG regress and all that, or use PGRX build test to do it. Or if you have custom commands, like I have a PGRX extension that does both PGRX and PG regress tests, so I just have make test in here for mine. But these will do what mostly is right for your extension. And then you can have this very nice, for every commit you push or every pull request that gets run, it'll test against all your supported versions of Postgres. I value this a ton, and I highly recommend it. I can't tell you how many times I've seen somebody say, hey, I fixed this extension for Postgres 17, and they've broken it for all the other versions, and they don't realize it. So super useful for that. So what's all this for? As I said, I wanted PGXN to be the source of record for all extensions, and that is still the goal. In the last year and a half, I've been working on a design and started implementation for what we're calling PGXN v2, which includes support for a whole bunch of additional metadata and different kinds of distribution, with a big goal being making it even easier to discover and find your extensions. Somebody asked in the Extension Ecosystem Mini Summit a couple weeks ago, how do I find extensions when all I find when I search through the search engines is AI slop? Well, we're hoping that if there is the one place you can go that's for the PGX and Postgres extensions, and that is maintained with care, that it'll be reliable for you to find your stuff. Our longer term goal, and the part of what I started working on, is to be able to have it feed into these packaging systems, into Yum, into apt, into Cloud Native Postgres, into OCI packaging stuff that Alvaro and I have been toying around with for Pigstyle, for whatever. The architecture has I want to build a system where when somebody makes a release, like it publishes an RSS feed, you can always consume, so know when something has been updated, but also we might do something like webhooks so that you can very rapidly get stuff built in your downstream systems, and stuff will just automatically appear after a couple days. So the idea is to have it be a feeder for all the other registries that are out there, because this one, as I said, is source code distribution, fundamentally. And we want it to be the source of record so that all those that consume from it know that they can have a comprehensive and complete offering of extensions that are available. Because what we want, right, is extensions everywhere for everyone. So that's my talk. Thank you. Happy to take questions while this goes in the screensaver again.
Thanks, David.
Yeah.
Quick question. So it seems to me that there's still quite a bit of friction on, do I still need to create an account and do a whole bunch of stuff?
You need to create an account once, yes. And then probably what you can do is copy a meta.json file from somebody else's project, which is what I do all the time, and then just edit it and set up the secrets. And yeah, but the nice thing is that once you take those steps, which I have like a long list of things I do every time I have a new project, it's kind of a pain, but then it just takes care of itself.
What I was wondering is, would you consider a possibility to move that step to a later stage, like basically just require people to have a meta.json and just submit it without no need of pushing any zip file, creating any account or anything. Just say, hey, here's my meta. And then in the meta, have a whole bunch of compulsory things, very basic, like the ones you already have. But basically, the biggest one would be the pointer to the other repo. And then that's having just that as the only unique required step gives you, I don't know, like I'm very into this, but like gives me, in my mind, I see that it gives you the 99.9% of completing the index, and then everything else might come later.
Well, yes. I mean, I guess I hadn't thought of that, no. It's an interesting idea. Offhand, I would say that it doesn't feel to me like much less work, because you still need an account. You still need to maintain the meta.json.
Why do you need an account?
To submit the meta.json.
No, that's the thing. Like, I just give you a meta. Hey,
How do you give it to me?
Form. I just upload it. I give you the URL to my repo where I have my meta. It's like, hey, this is my meta. This is me. And then like you don't care who I am.
So, an idea I have played around with, and I actually wrote a long blog post about this over a year ago, was like trying to borrow from the way the Go ecosystem does its stuff, which there is no, it's completely distributed. And all you do is you publish your thing on GitHub or GitLab or wherever, and the first time somebody uses go get to pull from it, it'll go get it from there and do the indexing and get it in its documentation and packages.dev.go. So you don't have to do anything. And I really like that pattern, and they build this whole caching system to make it fast, right? If all you're doing is downloading the stuff. And that's still something I might want to look into at some point, but this is what exists today. Yeah, and it also goes along with that, has very much like namespacing built into it. It's where it's like the full URL for your package, whereas Postgres is just a name, and so is PGXN. And other than the Go ecosystem, that's how they, or maybe Java, that's how they all work, right? So. There are limitations. I would like to make it a no-brainer at some point, yes.
Thanks.
Yeah, because there's nothing worth preserving more than developers' brains.
David, I have a question. It's quite similar to the previous questions. For example, I collect this metadata in a pull mode. I pull this repo. If there's a new tag, I just update the metadata. But the daily of my task is to scouting the PGXN first to see any extensions are updated in the very source. But I wonder if I could just submit this metadata update of my own to feed back to the PGXN. For example, there are several dozens of extensions not registered but already compiled of the metadata. Is there a way I can feed back to PGXN? And another thing is is there possible to bumping the version automatically? Each time a GitHub tag is added, maybe the PGXN could just update it. So I don't need to perform a 4-table scan on all the sprite.
Yeah. So when just to take a diversion here, when I first was proposing PGXN back in 2010, I got all these questions, people saying, well, then how are you going to support building it on Windows? And what sorts of build things are you going to support? Are you going to support configure? Are you going to support this? And I kept having to say, no, 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 no. This is really limited. You upload a zip file with your source code and a meta.json file. How you install it? Relying on PGXS as the main way to do it, right? And the reason for that was to keep the scope of what I was trying to accomplish very limited. And in the time since then, I haven't had a lot of time until I went to work for Tembo to work on it. So I want to collect all these ideas and get them into the system to be thinking about, and they help me to think about the ways I want to architect it going forward. But yeah, it's not, some of these things may not align with exactly what it wants to do, and some of them may be just like, hey, that's a cool thing we'd like to get to someday. Anybody who'd like to help me work on version 2, let's talk.
That was the perfect lead-in to the question I was going to ask.
Yes.
Is V2 going to have any metadata indicating any kind of hint about how to build the extension?
Yes. There's, are you going to be at PGConf this week?
Yes.
Okay, come to my talk on Wednesday. I go over a lot of that stuff. But there's a V2 version of the meta spec that expands it quite significantly, and a lot of it is like, what dependencies do I need in order to run this extension, and like what build pipeline am I using to build it? What are the platform variations? Like, oh, on Linux we prefer, I don't know, this CPU, or we prefer, you know, this library or whatever. It has a lot more flexibility, very specifically to make it much easier to automate binary packaging from those distributions.
Java,
and
the maintainers who preceded me already went through the, well, is it more difficult to get configure and make to do the Java stuff right, or is it more difficult to get the Java ecosystem tools to build the C part?
Right.
And that's the way it works right now. So
right.
This is the Java tools, and the documentation that you get is all in the form you would expect if you were documenting something with Maven.
Right,
and
yeah.
You somehow get that impedance mismatch covered.
Yeah, it's PL Java, right?
Yes.
Yeah, I think that's on my list of things that's funky. It's like, but I mean, you know, Maven long-term would be a pipeline we'd support, ideally.
So on the side of collaboration for V2 in Inlining, and we'll sit down together with a lot of ideas. We built a lot of metadata as well as PHP.
Sure.
I think we should all get together. We'll do this. Now the question is one totally small, or not a small topic, but I have a small concern about actually uploading the source code. One of the things we've been doing for the system that builds our container images is being very explicit about provenance.
Yeah.
So this package comes from this URL and has its digest.
Right.
And that is a precondition for building anything. We've seen supply chain attacks where the uploaded package is not what you think it is.
Right.
So for us, everything we build is based on, we go to the source repo, do a Git archive there, through the official mechanisms, like on GitHub is a particular URL, right? That right now ensures some stability. So we have deep concerns about reproducibility. I'm thinking if someone uploads a zip file, there's little to no control to that zip file. May have been maybe different from what you get from a Git archive at the given time it is produced. It is supposed to be produced.
Right. Yeah, so today, currently, the way that is handled is that you have to have a registered account. That's a part of it right now. And you go through that process where I approve you. And I've had people come in and say, I want to release a new version of this. I'm like, well, did you talk to the owner, right? So there's some level of that. The other bit is that when a registered user uploads an extension, it gets a checksum. It's SHA-1 because 2010. But then clients should verify, like the command line client verifies the checksum. I have an RFC on GitHub/PGXN/RFCs for actually doing Java web signing of extensions, where it would be signed in addition to checksums on upload by PGXN itself. But that also builds in the ability for authors to sign with their own keys that could provide an additional level of verification. I'd love to get to that at some point.
Because actually, even with the SHA, SHA-like doesn't matter.
Yeah.
My point is that it may differ for small things, such as using a different version of zip or tar to generate the archive, right?
Yeah.
So, because one of our folks to make all builds fully reproducible.
Yeah.
We've seen these cases, right? And there was an issue with GitHub some months ago or a year ago where they internally changed the tar version they were using, and they broke a lot of digests. And then they had to roll it back and then explain in a blog post how important it is, because even if just a small header change, right, on the tar file, that will ruin the digest.
Right.
So that's why our focus right now, or our perspective, is to lean on whatever users, Repo, SCM are using, and capturing the archive from there, because kind of the source of truth, to avoid this particular problem.
My question would be, what do you win by having the upload? That's the part that
Well, in part, it's making releases official, and a big part of it is to index the whole thing and make it much more discoverable rather than this whole distributed way. But this is also part of what attracts me with the way the Go ecosystem does it, where it basically does live on those servers. They can cache it, and you can disable the cache to make sure you're getting it, right? And it's all, fully automated. That would be fun to build, but not there today. Thank you. Thank you, everybody.
Yeah. All right. Hello, everybody. Thank you for coming, and thank you for having me here. And today I want to share with you how I kind of extend a Postgres extension based on C into the Java space. So it's kind of like a hybrid approach. So it's not fully C, it's not fully Java. It's like a combination of both to achieve a scenario in my case. So let's get started. Oh, by the way, my name is Cary from Hornet Labs, also known as HiGo, also one of the sponsors in PGConf.dev. And Grant and I, we are from Vancouver. So it's still our home country, traveling to Montreal. So it's first time here, though. OK, so here's the agenda. So basically, we'll talk about why I want to do that. Actually, in my case, why I want to do that. So we have a case study. It's actually one of the project I've been working on that actually utilize this hybrid approach. So we'll talk about JNI, how I kind of bridge the two applications together, discuss their memory architecture, and some of the kind of challenges that I faced during this development, and how I address them. So we'll be sharing all that today. And yeah, let's get started. So first, why? Why you want to do this kind of things? So why would C need Java, or why would Java need C? And we know they are two very different languages. They all have their advantages, their own use cases. So C may need Java for its modern libraries, for its UI development or cloud, or basically a lot of fancy things you can do with Java. And that's something that C is not suitable for doing those fancy things. But C is also good for faster access to the OS level. So it's very close to the hardware. That's why the drivers are mostly developed with C, because it's so close to the hardware. So they all have benefits. And Or simply, it's just no better way. Whatever you need is available in either one. And in order to kind of harvest all that, you need to kind of tap into the other kind of runtime, the other runtime. Or the modern languages such as C++ and Go, they are kind of already considering the lower level and the higher level approach. But most likely, your application may not be written in one of these. And in case it's still written in C, like a Postgres, how it's usually written, then we can show you that you can use a way to bridge the C space to the Java space to harness more power, more rich features, I'll say. So in my use case, I want to use the Debugging engine, which I think some of you may have used, to do replication, like a logical replication from different database sources. And here I simply refer to them as a heterogeneous replication. It's a fancy word, but I think it just means different. And we want to have that, because Debugging is already supporting connectors, they call it, to replicate from MySQL, SQL Server, and Oracle, and a bunch of others. But now I only have 3 to start with. And I want that in Postgres. That's my goal. And in order to do that, I started with the extensions. But because we are also working on applying to Postgres, so that's why we want to keep the C part here as well. So it's not just Java doing everything, because we still need C for the faster access to Postgres executor engine or SPI or whatever, things that it's better to be done with C. So that's my use case. And I just want to share with you some challenges I face by doing this kind of setup. So Debugging is normally deployed like this. It has kind of deployed in a architecture that has the connectors and has a Kafka in the middle. So it's for a highly asynchronous setup. And on the other side, it has a JDBC connector, and then they kind of inject to Postgres, to Postgres. So you can look at them as a different components or different Docker image, I should say, to have all this kind of connected and work. This works, and actually that's why Debugging can work not just on Postgres. You can have a different destination as well, because they set it like this. So you can have a web GUI that you can configure with the source and the destination. So that's how Debugging normally deployed. It works. But I don't want that kind of complicated setup. Instead, I want to have, well, I don't want to have all this stuff in the middle. And instead of JDBC, I just want Postgres to be able to just to take stuff from your source. So it's kind of direct, but inside is also the Debugging in the middle, but it's just not deployed as a standalone service. So it's all kind of embedded in the extension in Postgres. So let's talk about SyncDB. So this is the project I kind of started working on last year. That's July, August, kind of around that time. And the idea here is to keep the C part, which is the blue part right here, and build a Java part to the entire extension. And so they are kind of separate, but they are not so separate. They are together, but separate, logically separated. And in between them, I would say is their boundary, and here it is Java stuff here. So I use something called a JNI, Java Native Interface, to kind of enable the C-based extension to access or to harvest the resources from the Java space. And of course, I put the Debugging there. They all have this embedded engine that you can use to build your own application. So I want to take that piece out. So ignore all the Kafka and Kafka Connect stuff, and I just take the core and the connectors they supported, and have a driver here. I call this Debugging runner, which is just a Java app to drive all that, and use the JNI interface to obtain changes in JSON. So that's how Debugging represent the data. So process the data and basically apply it to Postgres. And we support DDL and DML. So that's the basic idea of the entire approach. So this is another view of the whole picture. So it's just basically showing you the data flow coming from the left, your source, and to the debugging runner, which is the Java driver I built. And they use JNI to deliver this JSON as a, they call it change request, change event. Deliver to the C space, we call it syncDB. So this is now in C. So this is Java, this is C, and that's their boundary. So you get that stuff in C, you can process it, you can interpret it, you can transform, whatever you want. And in the end, you apply to Postgres. So it's faster to apply changes directly in Postgres because they have this executed API. You can just call insert, update, doing all that already within the C space. So we just need the Java part to get the source, okay? And the Java part, or the debugging part, they are doing the conversion from interpreting of the changes and data from different database sources. So there's something already done by debugging, so I do not have to reinvent that, but rather I have to make sure it's converted to a format that Postgres likes, right? So when I start a Java, I need a Java virtual machine called a JVM. And when I create that within a Postgres C extension, it looks just like a normal background worker, because my extension started a Postgres background worker. So it looks just like a background worker, just like you connect PSQ to it. But inside that, if you open HTOP, you can see that one worker has a lot of threads right here. And they are all because this background worker is trying to run this jar file with a JVM. So this is actually a Java virtual machine running inside that background worker. So you can see a lot of threads. They are just all Java thread doing networking, maybe running some services, doing all kinds of stuff. So that's what it looks like when you run it. So that's how the interface in between Java and C. Something called the JNI, Java Native Interface, is available as libjvm.so. So when you install Java, it's already there installed. And this is a C library written in C so that Postgres can just load it and use the APIs inside to create a JVM and run some Java app. But it has a drawback though. It's slower than the native Java code, of course, because it has extra overhead. But how slow is it? So I just want to run just a simple test. So if you keep calling a Java function from Java, well, I just say 1x, that's my reference. If you call it with JNI, it's about 3 to 5 times slower. But don't get me wrong, it's still fast. It's still in like nanoseconds difference. It's just slower than the native Java. So 1,000 and 1 million JNI calls. Here, I mean continuous calling. And this is an empty function. This is calling a Java function that's empty, that does nothing. So it still has a little bit overhead. But once you start doing something, the difference tends to go a little bit higher. So the more frequent you call this, the slower it becomes. So let's say you call it 1 billion times. You see, this is just pure overhead. It's tens of thousands slower if you want to call a Java function with JMI 1 billion times. So this is we're talking in seconds. This is microseconds. Nanosecond, and this is probably micros. So slower than Java for sure, but it's not the showstopper here. So it's something that we can live with because we do have some technique to reduce these call frequencies. So we can actually make this a little bit more efficient the way we structure this. So things to be aware of. So right now inside your Postgres background worker, I should say, there's a C part and there's a JVM part. So if one of them crashes, it crashes the whole thing. And the JVM, they will produce a crash down by default. And that's mostly display in the Java's favor. So debugging may be a little tricky. When something crashes, you have to know who crashed. Is the C application crashed or the Java part crashed? So you have to kind of examine that crash dump file and maybe attach GDB to see if it actually originated from your C application. So that's make debugging a little bit different, I would say. It's more work to do. And exceptions. Java does have an exception that erases. And in C, it doesn't have that. So we have to explicitly check for possible exceptions. So in addition to checking the return code, to learn more about the error, okay? And of course, when you use C, the JNI in C, there's no garbage collection. You still have to manage the resources, manage the array bounds, check no pointers, even when you are using JNI library, because it's still written in C. So all the C stuff, you have to kind of follow that. And threading, well, there's no, Java is multi-threaded, and this absolutely cannot be shared with another process, at least not in this setup. So I want to talk about the different memory models. Sorry, I'm going a little fast because time is a little short. So the JVM, we have to define a maximum heap memory for JVM. You have to tell Java how big of a memory the JVM should use to allocate. And in Postgres, we don't normally do that. We do have some settings to define the memory bounds. But when we go over, it doesn't necessarily mean it will crash or the OS will kill it. It just means it will spill to file most of the time. But if you keep calling palloc, I think there's talk about memory content, you keep calling palloc, eventually, without pfree, you will be killed by the operating system. So that's the similarity between two of them. But in Postgres, we don't normally have to set a maximum, absolute maximum of heap memory that it can use. You're just getting killed by OS. But JVM, when you run out, you will get exceptions, and mostly will crash if it's not handled, right? So that's the major difference of this memory architecture, and you just have to be aware when you have the Java running inside the C, because it may tend to eat more memory than what it appears to be in the Postgres settings. So, normally it will consume more memory. That's it. And another problem or conflict is the signal handlers. Postgres needs signal handlers for a lot of things, for wake up your latches, for logical replication, for spawning a worker, for parallel query, right? And when you install JVM, it also has a signal handler, and it most likely may conflict with whatever Postgres register or whatever your background worker register. And that will cause maybe your latches failing to wake up, or all kinds of other weird problems with signal-related stuff. So the way I address this is use this option, -XRS, when I start a JVM, to make Java not to handle the signals. So have that all kind of handled by my C extension instead. So in that way, there will not be conflicts. So we make the C application or the C extension to be responsible for all the signal handling. So that's just something that I didn't know, and I had to take some time to what's going on. Why is it never shut down properly, or why is my latches not waking up? It's because there's some conflict in here. So just keep that in mind. And just some example code where the C extension starts a JVM. So basically, you need to locate a jar file. So you need to tell the library where to run the jar file, and that's kind of compile separately. So it's not compiled together with the C. That you have in the Maven to compile to resolve all the dependencies. So once you have that, you can load it in here, and then you set your max heap memory, and then you disable signals, and then you basically call this create Java VM, and voila. And that's if it doesn't get errors, then you will have the JVM running inside your C extension, and that means you are ready to run Java methods or locate Java class and to do things with Java. So bashing the throttle control. So I want to mention this because in my case, there's a lot of data coming in, okay? And they will all arrive at Debugging first, okay? And they have this queue right here to store all these, they call it change events. And originally, I did not have a throttle control, so Debugging would just keep adding changes to queue. And my worker is not processing fast enough, and then you will result in a rapid growth in memory usage. So you will see your Java JVM start eating a lot of memory until it hit that maximum, and then it just kill itself. So the JVM crashed, and then your C side, your extension also crashed. So I just want to have the synchronization problem kind of deployed in there, so that to prevent this rapid growth in the memory allocation in Java, because mostly it's faster to read than to write. So that's the problem I have. So I have the throttle control here. So basically, you will put this to a halt until something gets processed here by Postgres, by the C side of the extension. So I add a throttle control there. And batching just means when I request use JMI to get resource, get change events from the Java space, I don't want to just get one record. I want to get a batch of them. And this batch is configurable and based on your available resource. So of course, the larger it is, the faster it becomes because there will be less calls involving here. So doing batch to reduce function calls and have a throttle control to prevent rapid growth in memory. So at least that's in my case, I have to be aware of. So a batch is basically just a list of change events. But I converted to list of streams and deliver to C side. But it's not the best way. Why? Because when I get a list of something in C, it's still not usable in the C side because you need JNI to call Java's list routine to get the size of it and to access the elements in the list. So when you get this, you still have to call JNI a bunch of times just to get individual element. So this is not the best way, but it's just kind of there right now. A better way is to probably kind of serialize the data or send in binary instead of string, or instead of list of streams, you send a serialized byte array or something. So that would make it more efficient. So it's just a problem with SyncDB right now. And coordination is very important because you're working with two components, C and Java. And especially when there's a service running in the Java that does its own things on its own, like a continuous running. And on the C side, you want to get something out of that. And you need to make sure that it is working, it is running. Because you're trying to get something from it, and you say, I have nothing. OK, you have nothing, I'll try again, still nothing. But does it mean that it really have nothing, no new changes available, or does it mean that it's dead? I didn't know, so I would just say, why is it not getting things when there's new data? And when things appear to be running, even the JVM is running, but the service inside may be dead. And this is where we kind of need to coordinate between Java and C. So when something happens inside, maybe one of these is down, or all of them are down, we need some sort of exit callback to kind of notify these things back to C. So we are not blindly asking for new changes when it doesn't have it, because there's some issues that need resolved. So we need to kind of notify that to report to the user to handle it, basically. So maybe the C will just shut down as well. Maybe leave a log message or something, make a report saying there's something wrong with these connectors. So synchronization or coordination is absolutely important. You have to know what's inside, what's happening in order to deliver the right message to the user. Now, the concurrency concerns. JVM, you can do multi-thread with JVM. You can have multiple threads accessing Java resource with from one JVM instance. But you cannot do that from multiple workers. So when you have multiple workers in Postgres, each of them has to kind of create their own JVM, which is kind of independent of each other in order to have some sort of parallel operation, okay? So that's one of the things with this Java approach. So we cannot really fully harness the multi-threading technique, the support in here, because Postgres does not do multi-thread yet. There's discussion of that, but it's not here yet, and I don't think it will happen very soon. So this is something that we have to kind of keep in mind. But what if you really want to use multi-thread of JVM? You want to get more data in Postgres faster. Well, you can do that certainly within one worker. You have multiple threads right here, but they can only do the JSON or the Java stuff, meaning that each thread can get new changes from Java, no problem. With JMI, no problem, because you can do multi-thread. You can parse them in parallel, sure, because that does not really involve Postgres core. You can convert that with your own logic, sure. But the moment you want to apply, I'm sorry, you have to wait, because one worker has only one single copy of global state, global transaction state, the latch state. So you cannot have all these threads trying to insert a record to Postgres at the same time. Even if you want to insert it different tables, it still won't work. You will just all error out in here, which causes the entire thing to exit, because it just simply cannot do that. So the way I do this, not the best way, is to simply have multiple workers, each one running its own instance of JVM. But the thing, you gotta be careful here. I assign them different tables. So this is how I do the kind of concurrent replication. So if I can assign them different set of tables, then sure, they can run this in parallel and in a safe manner, and both of them can apply to Postgres because they're coming from different process. So this is thanks to a kind of limitation, shouldn't it, just the way it has to be done like this with the JVM and this hybrid approach. And also has a drawback. That means you have to run more JVMs, and if they handle with large tables, you need more memory allocated to them, and just, you need more resource for faster processing. And of course, there's a same table concurrency. We can have concurrency, maybe they're all working on the same table, then that just means we need kind of strict transaction boundary and ordering. So there's more work to make that happen. But for now, we just live with this, and maybe one day we'll support in the same table, but we can have multiple workers trying to process the same table, but you just have more work there. So this more on SyncDB. This is just a project that I've been working on that kind of utilize this Java and C architecture. And right now, you can support MySQL, SQL Server, and Oracle. And you can do transformation like data type. So their data type, we can transfer to something else in Postgres. And of course, you can transform to custom data type that you created. And you can do DML and DDL, and you apply using SPI and SQL API. This is mostly for DDLs, and we use the API for DMLs. So this is kind of an open source project that kind of use this architecture to deliver something like Debugging to kind of enhance the Postgres replication ability to be able to replicate from a different database source that's not Postgres. Okay, so just a key takeaway here. We talk about Java and C, and they just all, in my setup, both running inside one process, and we have to remember to set the max heap memory boundary. Don't use the default because you never know what Java picks as a default, and it may not be suitable for your case. And using bash to reduce calls, handle conflict, and keep them synchronized. So you have to know what's going on inside the JVM. And the concurrency concerns right now, just multi-worker, different JVM. So that's it today. That's just something I want to share with you with the problem I have with Java and C architecture. Thank you. We still have some time. Questions?
Okay.
Yeah.
Questions?
Yeah.
Or comments. The first one is shout out for using the Basim engine.
Thank you.
It's a fantastic technology. I know very well because actually we used to know one of our own software called Postgres, which is a platform for Postgres.
Yep.
We actually use the Basim embedded for the same reasons you mentioned, to avoid the use of Kafka.
Oh, that's great. Yeah.
And to replicate from, in our case, it's just Postgres to Postgres, but to extremely simplify replication. So it's very powerful. The BCM supports partial snapshots, incremental snapshots.
Yeah.
It's really, really powerful, so it's a great idea. Now, on the Java land, which I happen to touch on a lot,
Okay.
there's a few things. First one, I would seriously suggest to avoid JNI for all the reasons that you mentioned already. JNI as of today is marked as warning prior to deprecation. Right? And there's a substitute for it, which is a foreign function API, which is like infinitely times better than JNI. It's going to solve so many of your problems.
Oh, we should have a talk after.
Infinitely faster. It's basically zero overhead, calling it into C code.
Yeah.
Because it's the linking is done at linking time, right? And it's also safe, completely safe.
Okay.
And you can exchange data types, like for example, you can create structs in Java and share as be received as pure C structs in a safe manner. So it's like infinitely times better than JNI from a performance and safety perspective.
So what is it called again?
It's the foreign function API.
Foreign function API. Foreign function API. Okay.
Foreign function, yeah. And actually, it's going to replicate JNI in a couple of releases.
Okay, I will.
Yeah. So that's one of the things.
I'll take a note of that. For.
I can tell you that.
Okay.
The other one is that there's another path, totally different path to do all this, which is to use GraalVM, which we also use again. GraalVM allows to compile a Java program into a native binary or native shared
Oh, that's.
Yeah, like you can compile everything you mentioned.
I see. I see.
Tickets, but you technically can compile DBC engine.
Yeah.
That .so. And then you create your extension and call the .so, and you're done. And no JVM.
Oh wow, that's a really good insight. We should have a talk after. Thank you.
I was also going to mention the foreign function and memory interface, which is something more recently added in Java. It was previewed in a few releases, and then it landed in 21 or 22.
Okay. Foreign. So you're just trying to. Foreign again?
Foreign function and memory interface.
Okay. Written down.
I think Alvaro has surprised even me with the idea of JNI being deprecated. Most of the JEPs that I've read about that have said that it is a non-goal to deprecate or remove.
Is that right? Okay.
But the main thing that would get you able to use FFMI is if you have no need to pass Java objects between the Java and C. The overhead of JNI is that if you're passing Java objects, the JVM, all of its automated memory management has to be kind of stopped. It has to pass you an object that you can work on.
Yeah.
But another question is, okay, the error handling, you're calling into C from your Java code?
Yeah, I think time's up. We can talk. Sorry. Thank you. We'll talk to you. Let me put that stuff.
Hello, everyone. Can you hear me? Yeah. Hello, everyone. My name is Cheng Chen. Thanks for having me today here. My talk is about rethinking OLAP architecture, the journey to PG Mooncake v0.2. So in the last year, there have been a lot of several extensions that try to embed DuckDB into Postgres. And PG Mooncake is one of that. And I'm going to do a quick review of all of them and also talk about the future for PG Mooncake. So a little bit about myself. So in fact, I only worked with Postgres very soon. I'm very new to it, like since last September. But I've been building analytics system before. So previously I worked in single store. So it's a HTAP database. It's one copy of data for both transactional and analytical workloads. It does that by combining an in-memory load store and an on-disk column store. And it has very good multimodal support for JSONs, full-text search, and vector. That's part of the things I've been working on. So last September, I left single store with other two single store guys, and we founded Mooncake Labs. Yes, this is how PG Mooncake started. Yes. So PG Mooncake is yet another OLAP extension in Postgres. There have been many of them, many attempts in the past. So the well-known ones in the past are like Cytas. This is not a complete list. So yeah. So the well-known ones are like Cytas, Swarm 64, timescales. But then recently, now we have like DuckDB and data fusion. It's way easier to build analytics engines nowadays based on DuckDB and data fusion. So that's why in the last year, you literally see like many extensions try to shower DuckDB into Postgres and enhance its analytics capabilities. They have like country data warehouse, PG Analytics, PG DuckDB, and also our PG Mooncake. So let's stand back and ask, what does analytics mean for Postgres users? I think for initial Postgres users, they don't really distinguish like transactional or analytics workloads. So those Postgres users, they say, oh, my data is managed by Postgres. I just have some analytics query. Yeah, you can just run it. Everything works well until you run it at scale. So this is just classical database core stuff. Basically, Postgres is good for transactional processing. It's handling like day-to-day transactions for user-facing applications. The workload is mostly high concurrency and read-write. And most of the access modes is like fast index lookup. But for analytics workloads, this is quite different. It's mostly like low concurrency but read heavy, and you are doing large scans of the table and doing a lot of like joins and aggregations. So at its core, the way you're accessing the table is very, very different. For transactional workloads, you are reading very few number of rows but many columns. But for analytics, you are reading many rows but only few columns. So this calls for different storage for these different workloads. So row store is better for transactional processing, and column store is better for analytical processing. Like think of like you are building like a stock exchange, and for transactional processing, you want to just look for like trades where the ID equals to 1, 2, 3. In this case, you have some kind of index, and use the index find that row and directly read the entire row. But for analytical workloads, what you have is, for example, you want to count how many times a stock has been traded for the last month, for example. Then in this case, you are just reading like one column. You only want to read this column and just do some aggregation on top of that. So that's why column store is better in this case. And on column store, for row store, Postgres just executed like row by row. You evaluate the expression on the entire row first and to go to the next row. But column store, you want to do some kind of vectorized execution. You want to process rows in small batches rather than like row by row. So for example, in the previous example, you have some kind of stock exchange. Then you want to do some kind of dictionary encoding and make them into a dictionary. Then you can set your batch size so it can fit into the CPU cache. You can do SMD to do data parallelism. You can even compute directly on the encoded data. And because you are running it on a batch, it minimizes your function calling overhead. So as you can see, these different workloads require like different storage, different execution. So Postgres at scale, it doesn't work very well for analytics queries. But so for the next level, this user says, okay, but my data is most of my data are still managed by Postgres. I still want to use Postgres to query my columnar data. How can I do that? So Postgres natively supports this by foreign data repo. Let's say your data is already managed by ClickHouse, then you can just create a foreign data repo to query it. For example, if this is a plan, then this R is some kind of row store table, then this is run in Postgres. C is some kind of column store data managed by ClickHouse. Then foreign data repo will just forward this table scan C into ClickHouse and run it in ClickHouse and get the result back. Then the rest goes through Postgres. It works. So the next extension to it is PG Analytics. It's still a foreign data repo, but unlike the previous one, you need to use ClickHouse, which you can't run it inside Postgres. There are some kind of CHDB you can run it, but yeah. But DuckDB is designed to be embedded into another process. So it makes sense to embed DuckDB inside Postgres. So it's still a foreign data repo, but you have DuckDB inside Postgres, but your scan is forward to DuckDB, execute it, get it back. Everything works. But the problem with all these two approaches is that only the table scan can be pushed down to the vector execution, but not like joins aggregates. So this comes PG DuckDB. So Postgres is very extensible. They can allow you to fully rewrite the planner and also the executor. So they have this thing called customer scan, which you can fully push down the entire query, and PGXN does that, and push down the entire query to DuckDB. And the way it works is the Postgres query, SQL query, is rewritten into the DuckDB SQL dialect, run it in DuckDB, get the result, and streaming it back to Postgres, and do all the load conversion if necessary. So because the entire query is pushed down to DuckDB, then you also need to be able to support scanning load store tables in Postgres. So PGXN adds a way to scan the Postgres table. This is done by a storage extension, which is very similar to the foreign data repo in Postgres. So in the future, PGXN is also planning to support hybrid execution. Their current support is not that good, but there are some kind of open source contribution to it. So the reason to do that is because there are still big feature gaps between Postgres and DuckDB. And not the entire query can be pushed down to DuckDB. So the idea is to push it down only the part that can be executed by DuckDB into DuckDB. For example, an insert select query here, you can push down the select into DuckDB, then insert back into a load store table. Yeah, so this is PGXN. So everything works very well, except that your data is not stored in columnar format yet. So if you look at the ClickBench, which is a well-known analytics benchmark, so PGXN performs very well compared to DuckDB on Parquet, very, very close, about 1.5x slower. But if you just run PGXN directly on Postgres load store table, it does not improve much compared to just run it on Postgres. So the next question is, how can I make Postgres to manage column store data? So the foreign data repo idea can still work. The foreign data repo allows you to also write into the remote table. So still take the ClickHouse example here. You can write into ClickHouse and read from it. Everything works, except that most of the analytics engines, they can't keep up with the OLTP-like system. Like for ClickHouse, it only works well for like batch like inserts or like append only writes. But if you have like a lot of like point update, point read, point delete, it doesn't work. So this is where, so in this stage, let's still talk about the batch job. So this is where PG Mooncake v0.1 and Crunchy Data Warehouse come in. So what we do is we use a TAM to create table T using column store, different names. Then it's just like a regular Postgres heap table. And everything expect to work like transactional insert, update, delete, but in batches. Then you can do join with regular Postgres heap table thanks to PGXN. So PG Mooncake uses PGXN inside it. And you get performance comparable to DuckDB on Parquet. So how does this work? So at its core, if you think of the column store storage, it's kind of simple. It has two kind of things. You have like data files like stored in columnar format. In our case, it's just Parquet. And you have some kind of table metadata which tracks like what's the current data files associated with table. So we just create a regular Postgres catalog table to track what data files are corresponding to this table. And the metadata is stored in Postgres, but the data files are stored in the disk and in the object store. So how can we accessing this column store table? So still, both Postgres and DuckDB are highly extensible. Postgres has this table access method to allow you to fully write the storage. And DuckDB has this storage extension allow you to fully write the extension. So essentially, we create some library to read-write into this column store table, and having Postgres and creating wrappers in their own this extensible way to using this library to access a column store table. Now let's look at the execution. So let's first look at the scan. So for the table scan, what we do is we just first get a Parquet scan. We just first get a list of data files to scan from the table metadata that is stored in the Postgres. Then we do some kind of segmentation. We prune the files based on the filters. And then we just invoke the DuckDB on Parquet scan to scan those Parquet files. And on the com store update, this is a little bit more tricky. We ask because for update, you need a way to identify these loads. So we ask com store scan to also populate the file ID and the load offset to identify the load. Then the update will just write the update and undeleted loads into new Parquet files. Yeah, we do copy on write, so it only works very well on batch jobs, doesn't work very well on single updates. So how do we achieve like transactional consistency? So all the changes to table metadata are stored in Postgres. The changes are transactional. And the mental model is basically Postgres is the source of truth. And DuckDB is just the execution engine. So for each of the query, DuckDB takes a Postgres snapshot and reads all the metadata from that snapshot. This is how to achieve transactional consistency. So what's even better is that we write data files in Parquet, and we also write additional table metadata called using open table format like iceberg and delta. So this is the metadata stored in Postgres, and we periodically flush into this open table format. And this open table format will allow this table to be also readable by other engines, not just Postgres. So DuckDB, ClickHouse, Starlogs, or Spark, they can even just directly read in this iceberg table. There are also background modules. There will be background modules to also do some compaction. So with this, we were able to get into top 10 on ClickBench. This was in January 14th. So all the vendors are improving a lot on this. So now this has been changed slightly. But at that time, we were top 10. And all the things before us are not Postgres extensions. And most of them are actually not on Parquet. They are using their own proprietary format, which is more seekable, so they are better there. We are using the open format Parquet. Yeah. So now, we actually build the initial version very fast, like just in 2 months. But then we talk to the customer, they say, okay, oh, this is cool, it's battery jobs. But the thing is, my app does all these kinds of inserts, update, deletes, high concurrent. What I actually want is just on-demand analytics on up-to-date data. You give me this like batch job, data warehouse, it's cool, but I can't directly use it. So there are 2 problems to meet this requirement. The first problem is that the com store table as it is, the naive way of doing it, can't keep up with Postgres keep tables. This is the same thing for other analytics engines like ClickHouse. However, we know how to solve this. We spent actually a decade building an operational Chrome store at single store to solve this issue. The high-level ideas to do that is we just buffer the small writes and periodically flush this to Chrome store on disk. And the table scan will read both the buffer and also the on-disk COM store. We do some kind of union read. And on the COM store side, we need to add indexes to allow you to directly know which loads I want to read, and also improve the seekability of the COM store so that we can read it, we can directly read it. So this is the part we know how to solve it. But the other part is that there is a big contention between Postgres compatibility and the performance. Like if you look at the first version of PG Mooncake, we don't support indexes. We have limited support for types. Like geospatial types, those things we don't support. We don't support triggers, constraints, and not to mention like other extensions like the UDF and the usual defined types from other extensions. We don't know how to support it, or we can support it in a naive way, basically fall back to Postgres, then we are sacrificing the performance. So this is not just we seeing it this way. Here's the code from Sai, from PureDB ClickHouse, previously working on Citus. So he mentioned the same thing on our Hacker News post. He says, one potential value of an extension is Postgres compatibility, compared to if you build like a specialized database. But the biggest challenge they face at Citus is that there's a constant trade-off between Postgres compatibility and performance. And in our case, we have Postgres and DuckDB, and they are both evolving to the world's best, like the OLTP system, OLAP system, how to bridge the feature gaps. It's very hard, a lot of hard work. But on the other hand, if you look at the HTAP in practice, most people don't use HTAP by just running analytics directly on your operational system of record. That's actually a bad idea. This is because it's really, really hard to convince some people to replace their OLAP system. It's mission critical. And for OLAP system, they have different workload needs. Like OLTP system, they need to be always on, but your OLAP system is kind of on demand. They want different scaling things. And shared nothing architecture works actually better for these OLTP systems, but shared disk is better works for OLAP systems. They have the different storage requirement. And even politically, OLTP and OLAP are often owned by different teams. OLTP is owned by the product engineering team, and OLAP is owned by the data team. I mean, you don't get promoted by just replacing, introducing analytics into your OLTP system. So in practice, what people actually do is that, okay, you have some kind of OLTP system like Postgres, and you do some kind of logical replication into a specialized analytic system like ClickHouse, in this case, PureDB into ClickHouse. But the problem is that you can only get 10-second freshness, and it doesn't work for very well for update deletes. It doesn't work. So this is a mooncake story. Essentially, we want to follow this replication style. So we have actually 2 copies of data. So if you want to run OLTP, run it on your Postgres. And if you run analytics, run it on mooncake. So essentially, this OLTP will be replicated into mooncake, where we have this kind of arrow batches, battery or small inserts, directly flush into these Parquet files. You have index to make it operational. You have this iceberg set up so that this iceberg can be, you can do some kind of union read by Postgres and other engines. And we can achieve sub-second freshness, and we will be able to support update, delete, and iceberg, and it's very easy to deploy. So this is mooncake story. So what does PG mooncake mean in this? PG mooncake is this mooncake thing embedded as a Postgres extension. So essentially, we have this Postgres OLTP running in the backend, replicate into this mooncake, which is a background worker that's all this mooncake thing. And you use union read to allow DuckDB to get a up-to-date and a consistent view of this table at sub-second freshness. So this runs in the backend process. This runs in the background worker. So this is more details. So in the backend thing, we have this Postgres. Now, let's say you want to run a very complex query. This thing gets pushed down into DuckDB to run it. And if you want to scan this table, heap table, then you call Postgres to scan it. If you want to scan this column store table, you set up some IPC between this backend and this background worker. You send this IPC request, some table T and the count snapshot, and you get a metadata, which is basically the data files and all the deletes according to this table. And now you run everything in DuckDB. And here you set up the replication from the source table into the mooncake table, or in the background. And this is very easy to deploy. You can just run it in Postgres. Just install the extension. It just works. So now let's do a more technical deep dive into it. So first, it's a replication. So replication, we need to first do a full table copy, then CDC via the Postgres logical replication. So Postgres logical replication works by the word sender decodes the word records before that and reorder that by transactions. There are different versions of this replication protocol. In V1, it sends the individual committed transactions one by one. So you only get it when the transaction is committed. So if the transaction is really long, a big insert select, then it introduces a lot of delay. So luckily, V2 introduces streaming, which allows streaming of large in-progress transactions. However, there are still many caveats with this Postgres replication. You don't get an up-to-date view even when streaming is on. Like Postgres will keep some kind of internal buffer, and that by default is 64 megabytes. Only when that buffer is filled up, then it will send like update to you, and which means you don't get updated like data. To my understanding, the only way you can get updated data is you need to decode the physical log, physical world log yourself. So at the same time, another thing is snapshot also doesn't mean LSN. There's also an issue with Postgres where the order when transactions become invisible in the primary is different from when they are recorded in the world. So the transaction order in the primary is different from the read replica. So if you really want strong consistency, you need to actually send the snapshot, like xmin, like all the in-flight transaction stuff. Also, you need to handle like replica identity. That's a way to handle like how to identify loads. If it's a primary key, then you can use it, but in those cases, you don't have such things. So this is the right path for Mooncake. So in the foreground, when these small inserts come in, we just append the loads into very high level. We just append loads into the load buffer. When there is some kind of delete, it goes into the delete buffer. And you build some kind of index on your column store. So you use this index to quickly figure out what loads to delete. And there are like two different types of delete. You might delete the in-memory buffer, or you might delete some kind of disk. It's important to note that in this delete, to construct this delete buffer, you don't need to actually touch all these things. You just need to do some kind of index lookup. So it's very fast to just append to this buffer. So at the background, we flash packet and deletion vectors. And we also flash like iceberg snapshot during compaction and also update index accordingly. So on the read path, so because of all those complications, in current version, we are just doing read committed and eventual consistency, but sub-second freshness. So we just create a snapshot every like 0.5 seconds in the background. It's not iceberg snapshot, just a snapshot of what's things in the memory and what's on the disk. Just send these file names into the reader, do a union read. And the read will still send some kind of LSN, so that what's the current state I want to read. And the reader will wait until the word sender has processed that LSN. So this is a summary. So Mooncake is a real-time layer on top of Iceberg, achieve like sub-second freshness, real-time analytics, and it links any of your OLTP system to Iceberg. And PG Mooncake v0.2 is a Postgres-centric Mooncake embedded as a Postgres extension. So we also reload PG Mooncake 0.2 in Rust. In our previous version, it's super fast, but we write everything. And I would like to thank everyone here, like Postgres, like DB, PGDB, Iceberg, and we also get inspirations from our earlier HTAB attempt, like single thread and TiDB. Yeah, thank you. Yeah, any questions? Okay. Okay, thanks.
Actually, I have a question about the extension building. As far as I know, the PG.db is competing with PG Mooncake with the name lib.db. Well, what do you think of this finding your rest? Will you consider using a static link public lib.db rather than comparing your own?
Yeah, I think PG.db already introduced a way to do static linking with DB, and we're also using the static linking for the actual release. Yeah. Yeah. Also, I think if you choose the PG.db and the PG Mooncake version correctly, you can also use shared like library using the exact same DB, but there are complications. You need to make sure the version actually fully matches.
1, 2, 3. Okay. Okay, so I guess I have to put a cherry on the mooncake. I have to say this, sorry. Well, so that's a new extension I've been working for a few months now. It's still in alpha, even pre-alpha, so don't use it in production for sure, but you'll get the idea. Now, a small asterisk here. The first feedback I get is why Redis, why not Valky or whatever. The main point here that this is inspired from Redis from an API perspective, right? So the TLDR version is this one. So basically, you get the extension, you compile it, and you do a create extension Spat. And then you can do some operation like this one. So you can set a DB, which is basically a namespace. And then if you look at the functions that we have here, it emulates basically a key value store with some additional semantics. So what is now known as the data structure server, which Redis really made it popular, right? So we'll delve into this in more detail. So a bit about me. I come from an analytics/data engineer background, right? So most of my work around Postgres is in extensions, bringing some basic domain-specific algos into the database, like alternative aggregates for correlation statistics, and some additional stuff which is basically working around making ETL pipelines, being more involved with Postgres. Lately, I've been doing some more work in JSON path stuff, especially trying to expose this into extensions. So if you're interested in that, just reach out at some point. That's unrelated to this presentation, though. So caching. The fundamental operation of caching is basically set and get. So you set a key, you associate a value with it, usually string. There's no really type definitions there. And then at some point, you try to get that key faster because it's stored in memory. Memcache was the first, I guess, one of the first really popular cache servers. And then came Redis and changed a bit, or quite a bit actually, the landscape because it introduced some more semantics on the value. So instead of having just a string on the value, you have like sets, lists, and normal data structures. And then people started using this for all sort of use cases like rate limiting, queues and counters, leaderboards, and so on, right? So a little bit step back. Shared memory in Postgres and pretty much any database for that matter is used mainly as an IPC mechanism for ways for the database to share data between different backends, different processes. So, and the important thing here is that up until recently, it's only pre-allocated during server startup. So if you do something more, you have to restart the server and so on. PG10, Postgres 10, introduced the dynamic shared memory areas, so at this commit. And pretty much the landscape remained the same. So internally, Postgres uses a dynamic DS hash table, which is basically a hash table which is generally used for a lot of operations, right? So a lot of things changed into this commit in PD17, which, by the way, for me at least, it went unnoticed because initially, even in the hacking newsletters, the mailing list, it wasn't in the release notes, right? But I was looking for another, working on another extension which was LLM related. So I was looking for a way to store an arbitrary binary payload, which is basically a GGUF type of thing, and store it in shared memory and use it in another extension. And while looking for ways to actually achieve that, I came along this commit by Nathan Bossard of AWS, which it has an inconspicuous title that says DSM registry, right? So one by one, why is it dynamic? It means that you can allocate it after server startup. So in practice, this means that you can allocate more shared memory without having to build into the shared preload libraries in the pgconf, right? The shared is because it's shared memory. And then the registry part is that it did a very interesting thing. I said, OK, I have a server. I have some shared memory there. Why don't I just associate a string with that, right? And then different backends can either create a new segment with that or attach an existing segment if that segment has a name already. So if you think about it, it's a very interesting case because it adds a namespace into the shared memory, right? And then the Pythonista inside me remember this element, the last element of Zen of Python that says, okay, namespaces are a hockey great idea. Let's have more of those. And that's what I did exactly. I said, okay, we have one registry. So why not just treat this as a database name, like Redis does, put a name on it, and then do an operation like that. So when you do set spat.db = db0, it would go behind the scenes, create a new DSM segment using the registry, put a name on it, and then all subsequent operations will operate on the hash table that internally is represented into this DSA area, right? So you can do like simple set get values, and then you can switch a database. This key here does not exist into the database, which is database internally is represented as just a dynamic DS hash table, right? So you can see the main logic there. Now, internal implementation-wise, the SpatDB struct, it looks a bit like this. So it has a simple lightweight lock for locking. And then you just have two things to take care of. One, upon creation of the database, create a DSA handle, so DSA area. And whatever you do after that regarding that database, you do DSA allocate. So Phil earlier was saying that you do a palloc or palloc 0 to allocate some memory in the context. So following the same exact logic, whatever you do here, you allocate it to the DSA area. And then for that database, you have a DS hash table internally. So behind the scenes, what happens is I go to another backend. I request a database with that particular name. If it exists, I attach this hash table to the process, do whatever do I do, and then switch a backend if I want to. Each SpatDB is actually a hash table of one of a set of or a list of SpatDB entries. So a database entry looks a bit like this. So it has a key. DSS here is basically a C string or a text, a normal datum, which is instead of being allocated to the memory context of the database, it allocated into the DSA area, right? And also it has an expiration date that you do expect in the cache environment. And each implementation, if you see here, yes, the answer is obvious. You have to re-implement pretty much all the native data structure you'd expect from a data structure server, like list, set, hash tables, blah, blah, blah. So you have to do like a union like this. If it's a normal string, it's just an allocated datum in the DSA area. If you are going to create a list, you should keep track of the current size of the list. If you do add an element to the list, you have to increment the size by 1. You have to take care of the head and the tail. So the very fundamental things that everyone does on the fundamental data structures. So taking some examples of the expected API, right? And then the whole API is Redis inspired. Valky does the same thing. So lists. Why do you use a list from a use case perspective? Let's say you have to create a queue of something, right? So a list of emails, you create an L push here. This list here is not existing, so it will be created. So behind the scenes, go on, create a new head to the list, do all the accounting there, head, the tail, and the next pointers, so on. You can left push, left pop, or right push, right pop, based on if you want a thief or a leaf or type of thing. And then you can store like activity fields, like last n items, and so on and so forth. Hashes, a very typical, which hashes are basically dictionaries. So to the value itself, you can as well store some metadata. So that's the key name for the top key. And then we have a set of properties, attributes, key value pairs for the value itself. Now, a smart one would say, OK, you might as well store a JSON-B right there, right, and do that JSON path. That's true. The main problem, let's say there, it's, OK, pretty much slash that and asterisk there. Everything is a string, right? You do not have the type definitions here. So you have to pay serialized or deserialized cost if you do stuff like that. But if you do something JSON-y, from my experience, I've used this type of thing to cache expensive JSON objects or as metadata of sorts, like payloads, right? So instead of writing these things to disk and fetching it out again, you just store it into the shared memory. Alternative implementation, another set value is, value type is sets, like unique sets. So let's say you have a set of posts, 42, how many visitors does this post have? You save the IP, you can get the cardinality of the set, whether or not it has a particular type of value on the set, and so on and so forth. Plus some additional semantic, which I don't have here on the examples, the normal operations you'd expect from a set, like intersection, union, difference, and so on. And handle expiration, here, so we have an available API like this one. So you create a key and a value, and you associate a time to live to it. So when you'd expect its time to live is less than a second at some point, and if you sleep for a second or two, after some time passes, this key should not be there, so it is null. Pretty standard stuff. Now, it's a monstrosity of sorts, right? So people don't usually use shared memory for exposing that type of thing to front-facing stuff. So things to keep in mind. It operates in shared memory, so everything happens instantly, but you have to be careful with how you'd expect transactional semantics. So the way I've used it so far, I never use it like select SPSet or SPGet from join whatever. You just put set and get some values in shared memory. If you want to do something more complicated than that, then you're actually going into a time travel back to the 60s, and you're eventually going to have to reinvent SQL all over again, right? So you don't have MVCC, write-ahead log, or rollbacks. It operates on shared memory. Atomicity, everything is immediate. No concurrency, but you can lock per database and per key. So I have to do some more unit testing there, but the fundamentals are there. And of course, don't expect any durability. People say that, okay, Redis does a flash to the disk every now and then. Maybe you could do that. I don't think this will ever happen, because then we're not competing with Redis with just a utility on top of Postgres to try and say, okay, when do I use that? I use that when I use just a subset of Redis or Valky operations, and it doesn't make sense for me to just host another server and another service and have Ansible playbooks, blah, 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 when instead I could just use Postgres as a data store. So the catchphrase with Spat is not really as a caching server to speed things up, but mainly as a data store with some data structure semantics. So that's the selling, let's say, idea. Considerations, don't use in production for sure. It's still in alpha 5 version, and will be in alpha for a few weeks or for something. Will it ever be faster than Redis or Valky? Probably never. Even, for example, by the time that Redis has got a value from the key, probably Spat will be still evaluating the SQL query through the parser and then devising an execution plan of it, even if the execution plan is very dumb, right? So it doesn't make any sense there. And then, to quote a famous unnamed DB academic / YouTube persona, which you may guess who I'm referring to, when he saw that, he told me, okay, thanks for reaching out. Nice idea, but okay, slow. He didn't say nice. He said, exposing data structures to queries is a bad idea. You're inventing IMS, Information Management Service, from the 1960s, which I get as an argument, but then again, that same argument has been told against Redis again and again, but then Redis and Valky are still popular, still used, so take everything with a grain of salt. Related future work, I think trying to be an oracle for the future, pun intended with Oracle. So the reference, the commit that Nathan Bossart pushed in PG17, I expect it to be very, very fundamental going forward, because it exposes a whole new application of ideas of application, right? So another idea people started asking is, okay, do you speak the Redis or Valky protocol, like the wire protocol, so overuse anything? No, and probably won't. It doesn't make much sense. What does make sense, though, is exposing a C API, right? So for extensions. So a simple way, a wrapper around the DSM registry to say, OK, I'm an extension. I want to put and store some arbitrary data into the shared memory. Can I use that with some rough API, with some more beautiful and simpler API? Yes, you could do that. Not yet, but it does make sense. Richer data structure and operations. What I have so far satisfy my needs, but some more semantics and data structures could come in handy in certain scenarios, especially simple stuff like increment by one or increment by an integer. Stuff like that they are very frequently used in application domains and can save a lot of CPU cycles. And then on the hackers mailing list, there have been some general activity. So Rahila, he's been working on a patch. It didn't land, I think, it definitely didn't land for PG18. I hope it will for PG19, which basically proves the accounting for some memory allocations. And then there's another view that I have put in the last couple of commit fests. Unfortunately, couldn't make it to PG18, although it was certainly possible that was due to my procrastination, which we already have like PG share mem allocations, which you track the allocations. So I've been working on the DSM registry. So a very rough idea to say, OK, these are the strings I have on the registry. This is how much bytes I do have each of one consumes, how many keys on the hash tables, and so on and so forth. So again, shared memory in Postgres, I think it's going to be very, very popular going forward, both for extensions and, of course, for internal operations as well. And I think that's it. Thank you. Questions?
You said that you don't think it will be faster than Redis or as fast. I ran some tests against Redis and then
I have, it's
10 years ago, and then Postgres already was almost as fast. So, why don't you think that doing it locally with shared memory is slower?
It can be, in theory, can be faster, even if you compare it, for example, if your Redis is on another network or something, it may have a chance there. But the implementation we have internally, I have internally, is a hash table, right? The implementation, it's a very simplistic one, does a good job, very simplistic, but the implementation that the Redis and Valky have, it's a way more complicated than that. So they store a linked list of the keys and the values, not just a naive hash table. But more importantly, you have to acquire a connection, you have to parse the query. Even parsing the query is an expensive operation. It has to, whether you do it or not, you cannot avoid the execution planner. So not sure how much you can do there.
The other question is, why shared memory? Why not put it, say, on top of temp tables with maybe some direct manipulation and then
yes.
use shared buffers?
Exactly. So yeah, you're right. So actually, unlocked tables could be very different. Yeah, it's mainly about the API. So internally, you could do a thing that you set a key and the value, and then behind the scenes, you could do the create an unlocked table or that. But I think from an API perspective, working with key values, it's more convenient for me at least. Because to create work with an unlocked table, you have to create an unlocked table and then add keys and values. How do you work with set semantics, for example, there? You have to check for duplicates across a row or a column, right?
Yeah, I mean that you could do the other things like you do now, but just the thing to store them would be
or locked table, yeah, you could do that. You could do that theory, but implementation-wise, I think it would be faster. It would be even less lines of code than doing this with creating and manipulating tables. If you think about it, right? So if you think about duplicate, you have to do select blah blah from where, right? And I want to avoid all the complexity of the SQL query there. But you could do it in theory, yes.
You don't have to make a query. You could make the plan directly.
Yeah, you could for sure.
Actually, you could just call the index functions.
Yes, you could do that. You could at some point, yeah. But as an implementation. But again, I think I tried doing it with an unlocked table. Didn't make from an API perspective that makes sense. But if you take the test case and try to re-implement it with unlocked tables, I think we could do it as well, yeah.
Also get the store to disk free.
Yes, for sure.
So
Yeah.
Coming back to the thing Sweta spoke about earlier about putting other pieces of code alongside or almost inside Postgres.
Yeah.
How much slower would it be just to pack Valky into back-end work and talk to the IBC? What?
To pack it, how do you mean?
Just run it inside back-end work?
Like embed it?
Yeah, all of the code that's already there for all of the types. Take what's already optimized and just...
The main, is because I don't think Valky has like an amalgamation type of thing like SQLite 3 does, like SQLite does. So I think even the logistics of it, like trying to get a simple, if we could get a simple huge C or header file with Valky, one could do this, but I don't think it's anything there available. But so I think it's mostly a logistic type of thing. Yeah.
I like the project a lot. I was just talking with some folks about this at lunch, like why isn't there a convenient like Redis-like API inside Postgres yet?
Sorry, there's actually the Redis foreign data wrapper, so you could do something like this semantics, right? Which I guess it should work with Valky as well, right? Sorry, go on. Yeah, still.
It seems like you made a lot of arguments for why you should re-implement the Redis-Like protocol, including that you could skip the Postgres parser and query planning. But you said in the slide if you would do it, and you said probably not. So could you share why you're thinking you wouldn't want to do it?
No, it's too much complexity, I think, and not for some reason. I think I said both times that it doesn't make much sense. I agree, and I am a fan of the API that Redis exposed, like the data structure server API, but re-implementing it because you have to compete. It's like startups. You shouldn't talk about revenue because when you start talking about revenue, people say how much, and you don't want to do that, right? So if you say I'm going to implement Redis or the protocol, is it faster, is it not faster, or something? So you don't want to compete with it, I guess. But you do want to compete with a scenario that says, I have Redis, and then an Ansible playbook, and a DevOps team that manipulates it, and I just use 2 or 3 functions of the API. You might just as well use Postgres for that.
Your presentation, you didn't give us any numbers. I was wondering, is your alpha version order of magnitude slower than Redis, and is there a difference for reads and writes? Can you give us those numbers?
It's 3 or 4 times slower for reads, a little bit more. It's even slower for writes.
So almost an order of magnitude. All right, you've got a lot of work to do. Thank you.
Yeah, Redis is like 12 or 13 years old, right?
Yes. Okay. So look forward in 15 years.
Then you have like convenience and developer time, right?
Yes.
Thanks a lot, everyone.
Ready to go? Yeah. Okay, perfect. Thank you. Thanks again for sticking around. I know it's been a long day, but we only have 2 talks to go. So, and after that, all the fun. So, right now I want to speak about a contentious topic. How many of you hate C++? 7 people. Now you're accountable. Why do you hate it? Just one reason.
It's impossible, right? I mean, I loved C++ before. Like, at university time, it was my favorite language. And now, templates take more than the whole vertical screen. I can't even finalize reading the method definition, let alone reading a compiler error.
Perfect. So templates and compiler errors.
Yeah.
Okay. Any other reasons for hating C++?
The package dependency, so it's hard for me to view other people's.
Right. So package management is a little wonky, right? Okay.
C++.
Okay. C++ itself. Good. You know.
Last one. It doesn't run on a JVM.
Does not run on JVM. Okay. Well, maybe. Anything else? Just so we clear this, hatred. Like let it out, Like here you're allowed to say, things like that.
Okay, operator overloading.
Okay, fair. Anybody else, or we're good to go?
The errors are undecipherable.
Yeah, we already talked about that. But yes, good. All good points, by the way. Not to discount them. And now we'll, return back to Postgres. And I know there are different opinions, and I want at least some of you choose one of the answers or suggest your own. So how many of you feel writing extensions in C is powerful? Okay, like 7-ish people. An acquired taste. 4 or 5 people. Painful. 3. A minimalist heaven. Nobody thinks that. Any other options?
Still the best available option.
Still the best available option. Good. So a little bit of my personal story with Postgres extensions. Before starting Omnigress, I built my first extensions actually in Rust using what at the time was called PGX, now PGRX. I contributed to PGRX, and I wanted to change a lot of things because, as with any open source project, you want to help it grow, and you need certain features from it to achieve whatever you want to achieve. But then I realized I'm spending about 50% of my time contributing to PGRX instead of developing the extension that I need to develop. So that kind of started dissuading me from going that route. And I even considered forking it and making it smaller, making it more extensible sort of on my end without forking it. So it's kind of recursive. But then when I was starting Omnigress project, at the time, I decided to explore the area of possibilities. And I actually landed on implementing my extensions in C. And the first emotional desire was I really hated the compile cycles with Rust and PGRX. Rust itself is not very fast. PGRX also adds overhead to that process. So every time I'm changing one line and recompile to test this thing, I can go and brew some coffee. Like it's good for coffee drinkers, but then you can't get asleep. So that's a problem. And I really like the fact that, well, Postgres is implemented in C. Everything is tailored for C. Basically, there's no impedance mismatch. That's how, it's meant to be, right? They did not really design it for anything else. And I've done that for about 2 years. And I get tired of some of the strains that developing extensions in C puts on you. So of course, it's a little bit tedious. It's a little bit error prone. You forget certain things to be done, and then you're chasing that bug, sometimes 5 days, 6 days, and you're like, where is this bug exactly? And so I wished for better C again. And I've definitely always been, keeping my eyes open, whatever is available, new developments, old developments. There's Zig programming language, I still support it, even financially to this day, or even older languages like Ada that provide good compatibility with C. Of course, it integrates well and has things like generics. So you can basically build container type of types. There's essentially forms of resource management, similar to what C++ would have. But then it kind of hit me, well, there is a quote-unquote better C. I mean, it's not really C, of course, but it kind of started there. The name kind of alludes to that, C++. And what hit me there was, hey, well, the compiler and build toolchain is the same I use right now. If I wanted to plug Rust in, like I need completely different compilers. I need to tell which version of that compiler the users need. I need to integrate it with my build system. Well, it's a lot of work. And I'm like, okay, I'll just try it, and see what where I can get with that. And I really like the fact that semantically it's close to C. So when you switch between looking at Postgres source code and writing C++ code, the semantic distance is not as great as you would have traveling between other pairs of languages. And that led to creation of this little project called CPPGress. Basically, it's a very tiny library that wraps Postgres APIs and makes it just classic kind of modern C++ library, specifically designed for C++20. You might say, a new wrapper, not again, right? I mean, it's the vortex, right? It just sucks you in and you start contributing to it and it's a never-ending thing. Sure, but I really wanted to make it count. So one problem that I always had, not just for myself, but say involving other people, is how to teach people develop for Postgres, such as extensions. And of course, they have to do a lot of learning how it works architecturally, all these things. But even very simple things, like what is the function that I need to call to retrieve this? And you have a namespace of thousands of functions, basically. And so you start searching, like, is it get this, 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 or get that, that? And naming conventions don't match. And so people get lost. Like, I get lost in functions that I have not used for a couple of months. I'm like, was it that one or that one? So I have to read the documentation. If that doesn't help, I mean, commentary, basically. Then I read the implementation of the function to understand, like, does it do what I actually want it to do? So I wanted to build something that it serves not only as a library, but something that serves as a structured reference material. And in a sense, it's executable because, well, it is source code, but it's structured, with structs and methods and everything. So it embeds state, documentation, and it has tests. So we know it's kind of up to date. And I wanted to experiment with things like additional primitives that Postgres lacks. And one of the most interesting ones that I'm playing with right now is MVCC-aware containers. Like, can I have a hash table that respects our visibility snapshots? Kind of a wild idea, but an interesting one. So let's start with simple things. How does it look like? So basically, you start the extension the same way. You need the magic signature. But after that, you can basically define a Postgres function, and you can pass parameters into it by using C++ types. So for example, here in this example, it takes a string view, which is just basically a pointer to a string and the length of it, and does whatever it wants to do with this, and returns length, which is size t, I would think. And basically, the library in compile time looks at this signature, figures out what code we need to generate, what type checks we need to do. So basically, whenever somebody is calling into this function, we validate that these are the types coming in. Because otherwise, it's a problem if it's something else coming in. And what is this Postgres function? It's actually just a convenience macro. So people who write extensions in C would recognize this code. So basically, it has the function definition. And it basically wraps the function that you provided, whether that's a lambda function or just a reference to a function, and calls it with the parameters that Postgres gives it to it. So that was kind of too simple, right? I mean, yeah, cute, but we just passed parameters in and got something out. What is getting more interesting is how would you write things like set return in functions. So instead of making you abide to Postgres protocol, like do we do materialize, do we do value per call, it basically tells you, give me something that is iterable. And there's an iterator standard basically in C++. I will turn that into a set return in function. Right now it only implements materialize because I only needed a smaller scale, but it's very easy to add more code that will turn it into any other convention of how we get the iterable stuff in. So in this particular case, it's just an array with tuples, and we return it. And we don't have to think how we need to generate those tuples or tuples per call. And then, of course, I had to spend a lot of time on SPI because, well, we do use a lot of SPI if we want to do anything about tables. One interesting thing, it has flexible return types. So for example, you can return a tuple with whatever you queried. You can return a struct, and I'll show an example of that. Or you can return a single value. And every time when it's returning data from the database, it will type check everything. So there's no chance that you wanted a string, but it was actually an integer of value 0, and now your pointer is 0, and you're having fun with the segfault. So it will check and just tell you, no, that's not actually what you requested. Your query returned an integer instead of a string. So here's an example of a struct return type. So the idea here is that instead of referring to the results of your query by index, like first column, second column, etc., you define a type, and it basically returns the value of that type. So you can later iterate over, say, products in this case, and go for product ID, product name. So it makes it really clear what's going on there. It's not, P1, P0. It's what it actually is. And of course, it has a pluggable and extensible type system. So you can define type traits. So basically, we can compare which C++ type is which Postgres type and vice versa. And we can define conversions between them. So how do we take it from, say, in this case, Postgres text, how we create a C++ type called text, which is basically an abstraction for Varlena in this particular instance. And it even has support for things like expandable datums. How many of you actually know what expandable datums are? 2 people. So great. So expandable datums, I think the simplest way to explain them, it's basically a way for you to hold complex data structures that are not necessarily fitting into a flat, flat definition. You have multiple allocations, etc. But while you hold them in memory, you can operate on that. But the moment it goes to the database, it gets flattened into a binary representation, but not before that. And so the way we do this is with this form. It's called flattenable, and it's using C++ 20 concepts. And this is also to address, Alvaro mentioned the template hell that C++ has. Concepts have started improving C++ a lot, because you no longer really program with templates as much. But you can define a kind of a type, basically ad hoc. And so in this particular case, it says whatever has these methods, and some of these are actually static, as you can see, like by double colons, is flattenable. So basically, when we call the type colon type, it has to return type. If we call flat size, it should return std size t. If you call flatten into, it should return it should flatten the representation of this type into that span of bytes. And reverse action restore from a span of bytes, and it should return this type. So basically, once you do that, you can just simply say, I'm taking flattenable, and this can be any type. For example, I'll have an example, I think, of it later. But one of the examples that I've recently done is an extension for embedding SQLite into Postgres. And what it does, it has a type that has a SQLite object in it, and it basically serializes it when Postgres needs to flatten into something. So it serializes the SQLite database, and that goes into your database. So that we support as well. And we support things like nodes. So for every version of Postgres, we have a set of all the nodes. You can basically pass a node, whether a pointer or a reference to a node, and it will basically choose the overloaded, whether you're doing this in band or using just a function reference. It will dispatch it to the right handler, so you can essentially build custom walkers very easily, saying like, I want to handle this type, but the rest just does the default thing, whatever it wants to do. And I think this is a very interesting direction, especially where C++ is going now. C++ 26 actually has a lot more support for compile time introspection. That is, you already can do this with some of the libraries where you can compile time, figure out the field structs and their types. So you can do a lot of this, just not very nicely yet. I mean, and it requires a little bit of shimming. But it's coming to the language. It's already going through standardization. So it's a matter of time. So we'll have more ability to work with complex structures, for example, for optimizers, for executor planner, figuring out how do we want to change or analyze it. And we have things like memory context allocators. So everybody, I assume, whoever develops Postgres extensions, of course, knows about memory contexts. What we have is an ability to use these contexts for C++'s purposes. So for example, you can use memory context to allocate, say, any kind of container, like vector or map, on that context. So it still lives with Postgres, but it's C++ primitive. And on top of that, we implemented things like tracking memory context. So we register a callback for a memory context reset, so that whenever there's a reset, we increment a counter. So if you start tracking some of your pointers using this context, you always know whether the pointer that you have is still referring to something that is valid or not. And we use this technique quite a lot to basically prevent crashes in runtime. So basically just checking one number, if it's more than 0, it's gone. Like basically we don't resolve that pointer, and we rather throw an exception. The next one is a little bit contentious. I think I've heard today at the lunch, like some people do write extensions that have to use threads for one reason or another. Of course, this is not a very sanctioned thing to do in Postgres, to use multiple threads, but that's happening anyway. So don't tell anybody about this slide. I know it's going live anyway, but if you do take care of your signal handling and you do use threads, how can you reliably and responsibly call into Postgres? So we built this little tiny thing called worker, which you typically would run on a main thread. And it's just basically a loop that you can use to post lambdas, so basically kind of closures, into it and wait for results. So for example, you need to call something in Postgres and get the data back. You post this thing, it goes to the main thread, executes, grabs the value, and you have a future here that waits for it. So that thread can safely and reliably get to that information. So that's really nice ability. Now, going a little up about the design of the library, it's header only. So basically, there's no build system involved. You take one amalgamated header file, and that's all you need. It's perfect because it would run on whatever version of Postgres it supports, and it can change the shape or, for example, the contents of our list of node types, because node types do change between versions. And so it attunes to that. And in the future, if we would want to make some features, say, configurable at compile time, you can just do that with defines. So you define certain features, and it will change its shape or functionality, depending on what you want out of it. Again, no build system involved, so you don't need SO file, or static files, nothing, just headers. Well, one header. Some people would say, of course, well, C++ is better C, but it's not C. People say it's a superset. It's not a strict superset of C. They have different behavior, different expectations, and they're very subtle usually. A good example of that would be in C, a struct with no fields has a size of 0. In C++, of 1. And that's kind of an important distinction. It is a different size. But we do include Postgres headers in that header. Right? So in that header that you use in your C++ program, we just include whatever we need from Postgres, and that's still C. It's not in a separate file, so it's not a separate translation unit. So what do we do about that? Well, this problem really bugged me because I don't want to expect structure to be of one layout, but in fact it's something else. And so very early in the project, had to come up with this kind of CI-based solution. What we do, we compile the headers from Postgres, both with C and C++, using Clang, dump the layouts of all the structs, check their sizes, and check the offsets of every single field in them, member. And if they're all matching, we're all good. So far, no failures. So every CI run confirms, and if something will break on master, and actually this is the next slide, we're catching the errors very quickly because we have CI runs on master. So the moment something breaks, we're on top of this. In fact, just very recently, maybe a few weeks ago, a change made by Tom Lane broke C++ counterpart there because designated initializers in C and C++ have different expectations about them. In C, you can make them in any order. In C++, you cannot because you have constructors and there are certain expectations about order of initialization of the designated initializers. So I reported that, and within a day we fixed it. So basically, this really allows us to catch errors very quickly. So if we see a problem with, for example, layout mismatch in a new version coming up, we'll see it within a day. So that's a very useful tool for us to catch this type of problems. So the first guinea pigs, first one I already mentioned. So we have SQLite extension that embeds SQLite. The other one is Worker, and what this is basically a pluggable extension where you can dispatch Postgres work to background workers where you can supply your own native code to be executed in the context of that background worker. So the first such plugin is embedded, and it's basically SQL statement executor. So all it does, it basically takes the message, executes it, and basically says whether it was an error or not an error, and that's it. But the beauty of it is basically allowing you to plug your own SO files. So basically say, hey, I have a new handler for these types of messages, with this type of with this particular message type, and it will start processing them. So in the future, we're planning to use this, for example, for our HTTP server, so that HTTP server can use a generalized worker pool instead of having its own worker pool, therefore decrease the number of background workers necessary for the whole system to run. And there's more work that is not published yet, but we have OmniCluster for basically creating something that would Patroni and etcd normally do outside of Postgres, but we have consensus management and switchover and failover inside Postgres using Raft protocol, and we have basically that whole networking layer sitting in its own threads and doing whatever it needs to do, communicating with Postgres. And we have coming up an integration with Codon, which is an interesting project. It's a C++ based project that gives you Python, basically. It's like 90% of Python, but it's C++ speeds. So basically, they compile it through LLVM, and you get really performant Pythonic code that supports things like NumPy, et cetera, and like GPU computation. So really bringing fast computation to Postgres without the overhead of Python itself. So it's a lot faster. Few bits of reflection. So, resource acquisition and initialization is great, just like in any other language that does similar things. How many of you who develop extensions have ever forgotten to say free a tuple? And then there's a runtime error, and you have to chase all of these things. With simple things, when things go out of scope, they just automatically get deconstructed. It really eliminated a lot of problems very quickly, and I'm very happy about that. And another one is about C++ libraries. Just like with, say, Rust, where there's also a huge body of interesting libraries, C++ has been around the block for quite a while. It has some interesting libraries and some interesting techniques. The one that I found immediately very useful is Boost Interprocess. So it's one of the Boost projects. And basically, it allows you to communicate between processes using shared memory. the most interesting innovation there, and that is very tiny actually, they have the concept of offset pointers. It's basically the same thing that DSM do, where you have an offset for a pointer. Except that in C++, you can define that as a type, override the pointer arrow operator, and basically to you it looks like a pointer. You don't need to use special functions to figure out where it is. It just always actually resolves to the actual pointer. So it does all the calculation for the offset and allows you to write code like that. So it's very straightforward, and that makes it very integratable with just about everything that C++ offers there, because at that point you can store very complex structures allocated on the shared memory and refer to these pieces, so it becomes very efficient. So we are now using this for backend to backend communication and data sharing sort of pipeline. Basically, it just enabled us to do a lot of things very cheaply. Still lots to do, of course. It's a very young project. It's about 3 months old. So those who either don't hate Postgres, don't hate C++, but want to start learning how to hate some parts of it and love some parts of it, come in and we'll show around. And I also always interested to change people's minds about C++. A lot of people that I spoke to, they disliked it or hated it even, but I found that a lot of them are not aware of the recent developments. And by recent, I mean probably perhaps last 5 to 10 years. And when I start showing what's possible, how does the language look like now, they oftentimes start going like, I should look into it. I might not use it, but it's interesting. So I'm trying to change people's minds a little bit, 1% at a time. And why not Rust? If anybody is interested, basically, the point I was making, a lot of people are not aware of the state of C++. Make it C, I guess, cool, something. Explore it, please. Libraries to share, that's very, share and use, very important. And as some of the people on the stage were mentioned today, building Rust extensions does come with its own problems in terms of compile times, in terms of packaging their dependencies. They are not as bad of problems with C++, firstly because it's the same compiler, and compile times are not as bad. And addressing somebody else's point about dependencies, that's the funny thing about C and C++. Yes, it is hard to do dependencies in these. And I sometimes find this a blessing, because then you only choose dependencies you really need. So you kind of really invest in them. Whereas in other languages, you pick whatever temporarily solves your problem. But also to add to that, actually C++ does have some package managers. It's just more than one. And that's kind of a little bit of the problem. There's Conan, there's VC package. So there are actually options available for those who do want cargo-like experiences. So that's about it. Questions? We have 2 minutes maybe.
Yeah, almost convinced.
Almost what?
Convinced. I just missed one slide more. Why not C?
Well, that was in the beginning, actually. C, basically, lack of containers that could do interesting things. So basically, there's a number of containers that you can use, even going all the way to like DS hash, right? But they are clunky and they depend on a particular version of Postgres you're using, so they're not independent of Postgres. So for example, in some extensions, I had to ship an augmented version of DS hash. Because say on version 15, it's not the same as on 16, so your containers are kind of linked to the database. Whereas in this case, I just wanted something where I can focus more on the algorithm, like basically what I'm about to achieve, rather than on how. So basically, why not C? Lack of, or rather the need to manage resources completely manually. That is, if you have a heap tuple, you need to, or tuple descriptor, you need to release that. So you always need to track things. It's doable, but we're not perfect. We're humans, right? Containers is second, and libraries, basically. At some point, I was running into the need to wrap C++ libraries into C, because there's just nothing available and I do not have time to invest, for example, in a URL pattern parser, because like that's going to take like a month or two of my life, and I couldn't do that. So I had to invest a day or two in wrapping that library in C, so kind of backwards. So why not just use C++ in the first place? So those are kind of the main ones. Of course, there's more subtle details, and I'm obviously happy to discuss that afterwards, like on particular items. But those are high levels. Any other questions? Oh, we're out of time, actually. So I can happily answer that later.
Lights. I've got it saying it's hearing stuff. Okay, excellent. Brilliant. And then, where's your gizmo? You're over there. Sorry? Hi. Sorry. Oh, one back. Okay, cool. All right, thanks. All right, hi everyone. I'm here to talk about the Postgres side of what we've all been talking about today, the extensibility hooks, what we can connect into. Some of this is content which I'm sure we have all seen zooming past us over the past year and a half. Tracking hackers is difficult, so there are a few sort of select bits out there which I think are interesting and which are worth commenting on together. And then a few things that Bacona is doing in that area, and maybe a wish list sort of as a conversation starter for some things that might be nice to see in the extensibility world on the Postgres side of this extensions thing sometime soon. So firstly, who am I? I'm Alastair. I've been doing database things since sometime in the 90s. Most recently, before joining Bacona, as a technical evangelist, whatever one of those is. I was a pre-sales techie for 13 years, so there's still some bad habits I'm trying to get out of there. I picked up on Postgres sort of round about 2000. There was a very interesting range of open source databases available at the time. Explored a bunch of them and then settled on Postgres. So what we're then going to talk about today, so introduced myself, and then sort of three categories of extensibility. The stuff that's fresh out of the oven, the new things that have arrived in 18, which offer some interesting opportunities. Some stuff which unfortunately didn't make it into 18. And then the wish list, some interesting stuff which has been talked about, which may cause us to have to wish for some other things as well. And then finally, if you haven't all run away for beer yet, some Q&A. So, I was surprisingly, actually, I think this is the first presentation with various AI-generated imagery today. Generally, there are a lot of them. This is courtesy of Google Gemini. So, what is fresh out of the oven? And the general theme of the two that I'm picking here is allowing extensions to tell their story. We've talked a lot today about how to get them to build, how to get them to manage their own data better, but how do we make what extensions are doing more visible to the user, both on a per query basis and in aggregate, what's happening overall. At the moment, extensions can create log entries, which is which is nice if you're going through all the log stuff. And extensions that implement custom scans, we're going to come back to that word custom later, can inject content into the explain output. So this is a screenshot from the pigsty page for PostgreSQL PGDuckDB. And it does show that really what ends up in your output from the custom scans is just a blob of text. This thing looks very disjointed because you've got stuff that's formatted the way DuckDB wants to format it, stuck in the middle of some stuff that's formatted the way Postgres wants to format it. And as of Postgres 17, there was no convenient way to get some totals for what was happening inside an extension visible at a higher level to everything else in the Postgres ecosystem, including the various monitoring tools. So the first thing I'd sort of like to mention here that has arrived in Postgres 18 is supporting some extensibility to explain plans. So the original thing was as part of an effort to support query hinting, so some work Robert Haas did. And looking at all the feedback that came in for the patch, it was also mainly about people wanting to bend query plans and make some note in the explain output about what had happened to the query plan as it went. So not information for individual nodes, but information around how the selection of nodes had changed, their costing had changed, that sort of thing. And what this extension allows is the ability to add new options to explain. So the keywords were at the moment we have analyze, we have verbose, etc. Add more and more keywords at the end of that list, and each of them will have a different meaning. The sample implementation is a delightfully named extension called PG_explain, which will give you all sorts of information about a particular query plan, rather more than any end user would particularly want, but very much designed to help people who are playing with the planner or playing with extensions to bend the planner's behavior to see what was going on. The other interesting one from the stuff which has now made it into 18 is the pluggable cumulative statistics. So this started off as a set of infrastructure work to make pgstat statements more neatly integrated with all the other infrastructure in Postgres, particularly to get a bunch of the query data out of files, which creates some of its own locking problems, and into shared memory. It also allows, being an extension point, the additions of new kinds of statistics. There is the idea of a statistics kind. And here, the IDs are tracked on a wiki in the same sort of pattern as happens for write-ahead log resource managers. There's a page on the wiki where you can go and register the fact that you want to use a particular ID. Here, the sample implementation is a little more inward-looking. It's a set of injection points for test modules to use, or a set of APIs for test module injection point code to use to keep tallies of how many of certain things have been run during test runs. So then in the next batch, the extension points which unfortunately didn't make it, the copy format one is one which I think is a bit unfortunate, didn't make it through this time. This has been discussed for quite a while, making sure that we can build new copy formats in extensions, allow us to move different kinds of data without resorting to using third-party code like DuckDB. The discussion started off around JSON. There's also been talk about being able to use Parquet, Iceberg, those sorts of things directly as table types for copying inbound. And what has been shipped and polished so far is work to move the existing formats that are available. The binary, which really is quite thin, the CSV and the text imports onto the other side of this plugin layer. So rather than maintaining a hard separation between what is internal and what is external, actually try to use that same interface for everything. And this led to an enormous amount of performance testing. Lots of things around artifacts in the test setup, a little bit slower, a little bit faster. Eventually what is landed is that they can be on the other side of the plugin layer. The code for moving CSV and text out is now there. It seems from feedback on hackers to be ready. But just looking at the three of these, they come up with a few common themes. And some of this comes back to some of the points Yurii was making earlier about Postgres is not modular, it's not composable. And this is quite obvious from how some of this code has been written and how some of the discussions have happened. Just sort of going right back to the start of those examples around the custom scan implementations, there is a standard scan and there's a custom scan. It's very clear in the way things are named, the way they're structured. Some of these issues are around performance, like the testing of the copy formats, and also some performance at runtime where some things need to happen very quickly. So for the cumulative statistics, how to make sure that people can add new kinds of cumulative statistics without everybody paying a penalty in terms of increased overhead with the standard ones. And the design decision that Mikhail, who built the patch, eventually took there was that there would be a list for the standard ones, which kept behaving the current way, used an enum, didn't have to do any lookups, and then a list for the custom ones, which did a lookup, went and found the right thing. And that's the sort of design decision that we're seeing a lot of people taking here. And it just reflects a need for some, beyond just sort of talking about how are we going to build extensions, how are we going to package them, also some work on how are they going to keep interacting with core. We've got the naming conflicts, the idea of the wiki page, the idea of, well, when you install them, if there's conflict, it'll go wrong. And even on the debate around the copy formats, the opinions have been expressed that maybe it shouldn't be possible to overwrite things. That maybe there should be, fine, you've installed something with a naming conflict, you've got a problem, or you cannot overwrite text. We have to stay with a built-in one. Does that need namespaces? These are all questions that need settling up there in core Postgres land to make it possible for all of us to build more extensions. And these are probably debates that we should all be trying to get involved in. So looking at our wish list, this is the last generated elephant of the day. So storage is an area which Pacona has a particular interest in. And we know here that there are some forks that have just completely rewired the storage engine. Everything is just accessed differently, talked to differently. Neon, Oriole are the two that sort of come to mind there. And when we see, rather than people trying to totally re-architect what the engine looks like, why people are building storage extensions, it's often to do with changing the way the data is between memory and disk. So encrypting it, compressing it. An interesting example that someone came up with in a discussion at PGDA UK last year was around avoiding the need for these virtual file system wrappers in certain environments where Postgres is run. So it's a crowd called ElectricSQL who build Postgres in WASM for use in embeddable environments. And in order to make all of the current comms work, they have to put virtual file systems in place to then use the WASM storage primitives. It would be nice for them to be able to use the stuff directly. And there are two approaches which have been discussed here and are still very much work in progress. One of them is callbacks for the storage manager, and then the unified file API. So if we look at patching the storage manager, the folks from Neon introduced a possible patch for this some years ago already. I presume just to reduce the burden of the size of the patch set they have to keep carrying to keep being able to build Neon. And the team at Pacona, who are working on encryption, picked this up. as a way of supporting TDE as an extension. Because TDE is one of those things that's been talked about in core a few times and has never really made it because it just gets too contentious, it gets too intrusive. So it feels like a good thing to sort of have living in an extension. And this would fix part of that problem for us. One of the things that we changed in the patch was that there is now a chain of these extensions. So whereas it originally came from a world where there was really only going to be one change, now maybe there will be multiple. There are modifier hooks into the storage manager, so where we would use them for encryption, people could use them for compression, and then the terminal, which provides the right to the disk, which in our case is just a normal thing that will just write data out. Patch is in review, a little bit of feedback from some of the folks at Yandex. So if this is something you care about, if this is something you think could be useful, please go and pat the patch on the head. But this doesn't fix all the problems. WAL files and temp files are some of the big exceptions. So beyond the storage manager, again, part of the initial discussions around getting TDE into core, there was this idea that there should be a unified file API. How to deal with everything except the basic contents of the tables. There needed to be a way of addressing all of this. Temp files that spill to disk, all of those sorts of things. And one of the holdups there in that discussion already was the idea that anything that gets in the way of WAL files is very, very sensitive. Any hooks or any callbacks, it's a critical code path. We need WAL to work from a performance point of view, because until that data is on disk, we don't have any way of knowing that we have resilience. And also, if WAL gets broken, all sorts of things downstream break. Your replication breaks, your point-in-time recovery breaks. So it's very important that this is solid. Another point which I'd like to sort of put out there for some feedback is that it's been asserted that this is a hook which would really only be useful for one thing. It would only be useful for making encryption work, making transparent encryption work. Now, given how many times trying to put TDE into core Postgres has failed, that might be good enough in itself, but there must be other things that are trying to do this work. So if that is something that anyone else would be trying to work on, it would be nice to hear about. At the moment, Pacona is carrying a patch for this in our distribution in our builds, but obviously it would be nice to get some wider use and get something a bit more standard that we can push upstream. Now, logging is the other area where I think the wish list gets a bit interesting. So there was a patch proposed 8-9 months ago to separate out the way that the logging of duration-driven logs is done. Stat minimum duration, all of that sort of, log minimum duration, all of that sort of stuff, because they can get very verbose. And you can actually run out-of-disk space risks using them. So the basic structure of the patch is that it labels log entries with a type. So every log entry, as it carries down through the API, has a type label. The original proposed patch implements only one of those. And then there's a separator at the bottom when the log is actually written to disk, which takes action depending on the kind of type that's labeled. Now, this kind of thing was originally built for that one purpose, but there are some other places where it would be useful. Separating out audit logs is an obvious one. I'm sure all of us who have customers who use PG Audit have heard this request. They want the audit logs to go somewhere else, different audience, different resilience. So that's an interesting one. But now if we've got logs for just the standard database, we've got logs for durations, we've got logs for audit, we've got logs for the logical replication conflict resolution, which is another thing that's coming down the line. It looks like it's going to get very verbose. What do we do about configuring them? Do we just provide, this is your file name and that's it? Or do we try to present the entire list of log configuration options for every category? One of them, which I think would be very useful, is, for instance, allowing the syslog targets for the audit stuff. That means you can hand them off to people who have syslog syncs like Splunk. Out of the DBA's hands, everyone's out of trouble. So the question that was raised, and I think there are other areas of extensibility where it's relevant, is what about how we write these things into the file? What do we call the gucks? And the idea of a container is one that appeals to me at the moment. So if you look at all the stuff on the right of these lines there, these are all the standard things for configuring logs. So you've got the log destination is CSV. Let's say audit also has a CSV target, but it's got a different logging directory. And then PG audit would have its own thing saying flag these directories this way. But for those top ones, the idea of being able to structure the config in, we have multiple targets, the one with this name for this value, and leave all the rest of that to be validated, acted on exactly the same way the rest Postgres would by default. Feels like an interesting idea of configuring some of these very fragmented, repeated processes, which I just think might be worth thinking about and commenting on. Thank you. Questions? I was guessing so with the notes you were making.
So one thing about... Hello?
Yeah.
So
yeah.
One question about the logging containers. Should they, if we find at all, maybe they should be just callbacks, like we currently have a single callback, which is, it has some issues. For example, it's always gets formatted string, which you may not want if you do some, want to decide to set it to log. But it could be not lots of configuration values, but maybe just provide have a way to have a less processed log structure sent to the callback, which then can make all the decisions.
Yeah, but the thing here really is about configuring that callback. If you have a callback which is processing just the logs for durations, what should it be doing? Where should it be writing those logs to?
But if it's a callback, then you can put your own callback to its own configuration. It doesn't really need to have the call discussions if they are holding things back. So you could, each of the callbacks could have its own way of doing it. And of course, we should provide some sample, but currently we have a callback and we don't provide any samples for it anyway. So, but the thing is, the current callback has some issues. For example, if you want to log everything, then you have too much overhead because some formatting is done before the callback. If you So if we could move the expensive ones on the other side of the callback, then we could just use the callback much more.
Yeah, yeah. I think it would still leave every extension provider who provided those callbacks defining their own configuration language.
Yeah,
and
that's the idea that they can, and they don't need to get the full consensus of everyone else, which means that maybe something gets done quite fast.
But yeah, I suppose the counter argument that appeals to me is that if you've got the same way of configuring all of them, they're easier to adopt. It's not just can you write them, it's can you get them adopted.
Doing the same thing, you can't do new stuff very easily. And why would you have many anyway in this case?
Yeah, so I can think of 3 only, but yes.
Yeah, and then the other thing is about audit logs. Have you thought about pushing audit logs through some special type of file record? Because most people want write-ahead log record. Most people want audit log records to be as durable as everything else. And it seems that the only way to do it is to actually put them in write-ahead log and pull out on the other side somehow.
Yeah, that was in fact discussed in a thread on Hackers a few months ago. One of the Oracle Golden Gate developers was looking at it because they have a requirement from one of their customers. So I think there's one transaction callback. One of the transaction callback hooks isn't in an ideal place to do that, putting them into WAL. But yes, that is the most durable answer. To ensure that these things are looked after by a WAL archive, you can logically decode them, I suppose, is effectively what you do to get the audit out.
Yeah, and last from me, you mentioned that it's really hard to get consensus about getting callbacks for write-ahead log and other file operations. And I know that Oracle has done actually a file system, Oracle clustered file system. So maybe we should look at moving things out of database and provide our own file systems, because we would need to, because they are very different for data and write-ahead log. You could easily wish very different performance characteristic for these.
Yeah, yeah. Once we've got over the direct I/O hurdle, we can take that one on next. But that still seems a while away.
We could do it earlier if we had just specifically tailored file systems we can use, so and then get there this way instead of trying to have hooks inside Postgres. But again, not sure it is faster.
Yeah, I'm not sure it's fast, but yeah, it's an interesting thought.
Thanks.
Thank you. All right. Thank you very much, everyone.
I'm just going to make a closing statement, and now we can all relax. Is it working? Good. So thank you, everyone, for coming today, and especially for those who traveled here. It's a long way for a lot of people. It was a great day, I believe. We had a lot of talks. We ran completely on time, which is great. The video recording is already available because, well, we're still live streaming it, but it's available to be watched, and hopefully within the next weeks or so, we'll be able to timestamp and cut it so it will become more digestible and more shareable in some shape or form. But at least you can refer people to particular timestamps in the video right away, as in now. I would also, again, would like to thank our sponsors who helped put this event together. So Amazon Web Services and Postgres helped finance this event. I'm hoping that next year we, in whatever format, but I think we need to continue doing this. There's a lot of Postgres events, and they all have their own focus, and all those focuses are important, but our focus is important as well. And just the number of talks submitted and the talks that we were able to put on the stage today shows that there is pent-up demand for this type of content. We'll organize it earlier, than just 2 months before the event, so we can get more people to attend, more people to speak, so we'll create more opportunities to share and discuss things. So stay tuned. Of course, you'll get follow-up emails on that, and please do share information about the event. Please do share the video, because we need to promote this whole space and what is possible. We need to involve more people in this development. So there's that. Also, this event has been operated under Postgres Extension Developers Coalition. Those who are interested to take more active roles in this small but growing community, please talk to me. It is now an official nonprofit, so basically it becomes more of a real organization, and there are roles to be taken and responsibilities to be taken as well. So those who want, reach out. Either now, today, or during the week, or over email. There's a lot to do, and I think we can all achieve a lot of interesting advancements in this field. So thank you for coming. Please give a round of applause for all the speakers and for all the attendees, and that is a wrap.
Great.